Hello, everybody. How are you all? I hope everything is good. Hi. Very good afternoon, Andariki. Am I audible? Am I visible? Kasari Chapandi. And in class lo, we are going to discuss about a branch and any modern physics. Yes. So, in this session, everybody, hi. Am I audible? Am I visible? Okasari Chapandi, all of you. Yes. Hi, good afternoon, everybody. Good afternoon. Hi, good afternoon. Sir. So that means I'm visible to everyone. Ide kada? Yes. Good afternoon. How is the energy, sir? How is the energy? This is the branch in physics by itself, Ram. Okay. So there are some chapters and the first chapter that we'll be seeing in your modern physics is your atoms, Ram. Okay. Atoms and nuclei. Next chapter will be your dual nature of matter. Okay. Yes. దాని తర్వాత we'll talk something about your radioactivity. And lastly, we have your nuclear physics. Nuclear physics ante we'll be talking something about your mass defect and all. Sometimes this is considered as a single chapter, right? So 3 లేదా 4 chapters will be discussed in this series. So I need a high amount of energy, okay? Chala high energy kavali. And like the video, andariki, before starting the session. Sir, so are you all ready, Ra? Yes. Hello. Hi. Hi, Isha. Hi. Semiconductors will be in a separate chapter. So we'll take one shot on semiconductors. The time will not be sufficient. You're understanding? Semiconductors will at least require 3-4 hours. 3 to 4 hours at least minimum. 3 9 to 12 hours of session will be there. It's gonna be a marathon, a long marathon. Okay, Gada? Yes, so semiconductors will be taken separately. Okay, separately. Sorry. Okay. So let us dive into the chapter, students. Okay, sir. This entire discussion of your modern physics, it started in the late 90s. Late 90s, and you can say in the age of Einstein, not Newton, Albert Einstein, and all those things. Okay, so modern physics is a branch of physics that just started in the late 90s and talks majorly about your quantum mechanics. Quantum mechanics ante enti, sir? The rules, the laws of physics work differently for different systems. Ante enti? Do you remember in the case of gravitation, I've told you something. Ante a gravitation lecture lo, I've told you that the mass is the most astonishing thing. You're understanding? When you say you have a 10 kg of block, you have a 10 kg of block. What is the force of this block? Mg, gravitation force. Mg, you're understanding? Yes. So it will be a significant force, and 100 Newton of force is there, sir. Everybody understanding? Kani, if you have a very tiny mass ante enti, right? Me దగ్గర ఒక electron is there. So mass of the electron, let us say somewhere around m is equals to 10 to the power minus 31 kgs. Eppudu can I say that the gravity will act on this mass? No. Ante your mg, your classical physics fails abruptly ee case lo. You cannot use your classical physics. Newtonian physics you cannot apply over here. Mari em cheyali, sir? So to deal with these tiny masses, you need another physics. You need another set of rules, another set of laws. ఆ రూల్స్ ని we will be calling as your quantum physics లేదా modern physics. Okay? You are understanding? Yes. And when the mass becomes extremely high, ante let's say you have a black hole ra, and the mass of this black hole m is equals to 10 to the power 70 kgs ra. In case lo, you can never talk about quantum physics in this scenario. You are understanding? So when you are discussing classical physics, the masses should be in different range. When you are discussing about quantum physics, the masses should be in different range and very low, very less. Ide kada? Yes. And when you are talking about massive objects, massive objects ante enti ra, black holes and all these things. So here your physics is different. You are understanding? Here we will be talking about your theory of relativity, ante time dilation, traveling into the past. You are understanding? Not past, I'm sorry, traveling into the future, time dilation, all these things we'll be talking over here when the masses becomes massive. You are understanding? Not there for your syllabus. Gravitation is the end point of this discussion ra, ade finished. You are understanding? Similarly, when the masses are significant in our ranges, ante 100 kgs, 1000 kgs and all, so మా దగ్గర ఒక separate branch of physics is there, mechanics. Hi, good afternoon. Kani when the mass becomes very less ante 10 to the power minus 30 kg, our range kosam you cannot use your theory of relativity, you cannot use your classical physics, kani you will need another branch of physics ra. Our branch pair ante quantum physics. Okay, you are understanding? Sorry. Yes, we will take it, don't worry ra, I will complete your whole syllabus. Okay, sorry. So we will be talking about your quantum physics లేదా modern physics. అంటే ఎప్పటి నుంచి we will be just targeting చిన్న masses ra. You are understanding? Masses of protons, electrons and how they behave, if they are moving, what they do, and how are they behaving in different conditions. Ade ide kada? Yes, sir. Now let us talk about your atoms. Atoms గురించి మాట్లాడతాం అందరికి. So first of all, మొదటిగా రా, the name of the chapter is atoms. వినండి అందరికి. Let us talk about history. Physics class లో history గురించి మాట్లాడతాం సార్. Yes, we will take it. Semiconductors will be taken separately. If the time is there, we will take now only. Kani, I don't think the time will be sufficient. You are understanding? And what, I only have 10 hours of flexibility, 10 to 12, 10 to 11. Okay. I only have about 10 to 11 hours of flexibility. Dantlo, if possible, we will take your semiconductors here itself. If not possible, we will take it in another session. Sorry. So when you are talking about your atoms, andariki, I want everybody's attention, ra. Okay? Let us go to history. History ante enti ra? There are almost no people before 1600. Chuskondi. You are understanding? Ante 1600s of time ra. Idigo. Okay, India what was happening in 1600? Sir, British India company was there. That was, fighting with these Mughals and all. Okay. 1600s low, there was this East India Company in India, and the British versus Indians fight was going on. India, but in Europe, there was a scientist, Newton. What did he do? He invented laws of gravitation. Discovered. He discovered laws of gravitation, and he invented calculus. Oh my God. You understand? Ante, if you're talking about history ra, chuskondi, before 1600s, there was almost nobody to talk about atoms. You are understanding? Yes, there was an Indian scientist, Maharshi Kanad. Okay? Maharshi Kanad. You might have heard it in your school names. Okay? So Maharshi Kanad stated, what? Every single thing is made of tiniest particle. Ade. You are understanding? And he named that tiniest particle as Kern. Okay. Okay. So after Maharshi Ganan, ante somewhere around BC era, thousands of years ago, okay, after him, nobody talk about your atoms. Atoms ante what the universe లేదా what each and every single thing is made up of. Nobody talked. Nobody. Mari, there was a scientist who hey, Dalton, hey, all these things there, you know it kada, it's there in your class 9th and 10th syllabus, చూసుకోండి. So Dalton was the first scientist, చూసుకోండి. In your scientific world, ఒకసారి ఒక scientist says something రా, that's it, the chain starts. You're understanding? Yes. దాని తర్వాత Dalton said something about the universe. అంటే ఏంటి? He said that each and every single thing that you see, అందరికి చూడండి, Dalton said everything is made up of a tiny indivisible particle and he named it as atoms. Okay? Yes. So Dalton, hi, good evening, good afternoon. So Dalton said that every single thing is made up of atoms, okay? Mari, he was unable to explain the structure of atom. చూసుకోండి. Even now in 2026, we certainly do have the most advanced technology, ఇదే కదా? But still, we don't have the exact లేదా the actual image of atom. We don't know much about your atoms, andariki. You are understanding? Yes. So Dalton stated that every single thing, every single object is made of smallest indivisible particles. పేరేంటిరా? Atoms. That's it. Okay? What did he say? He said that an atom are like spheres, solid spheres. Not, I should not say solid hollow. Understand? Yes. Atoms are like spheres. So he said that this is your atom. Finished. Kani, this was a very big breakthrough. Due to Dalton only, every scientist, the scientific world started focusing on something known as atom. Andariki. You are understanding? Yes. So he did not say anything, he did not give much about atom. The only thing that he said was smallest particle ante your atom, and spherical. Finished. Not cubical, not cuboid, not cube, not prism. Spherical. Ade. Finished. దాని తర్వాత he's a student. పేరు చెప్పండి ఒకసారి. Do you know the name? The next scientist the next scientist in the series. Who was he? ఎవడ్రా చెప్పండి, పేరు చెప్పండి. డాల్టన్ తర్వాత ఎవరు వచ్చిందిరా? The name of the scientist is Thomson. ఇదే కదా? Yes. The scientist that came after the doctor was Thomson. He is own student. So ఇప్పుడు చూడండి, Thomson's atomic model ఇదే కదా? Yes. So Thomson atomic model. అందరికి the discussion is starting from very simple topics. కానీ it is definitely going to get too much complicated. Okay, yes, Thomson. Hey, not Thomas. It should be Thomson. Okay, Thomson. Okay. What did he say? He said he actually చూసుకోండి, no scientist has denied the previous discussions. Ante Thomas did not say Dalton is wrong. You are understanding? What did he say? He only said that sare na teacher Dalton na teacher, whatever he said is correct. Kani I will add some increments, లేదా some extra information. Extra information అంటే ఏంటి? He said that an atom has positive and a negative charges. ఇదిగో, you are understanding, this was a very huge observation actually, to be honest. Try to understand. Okay, hey, did I say Thomas? No, Thomson. Okay, Thomson. Sorry. So he said that your atom has positive and negative charges. Kani position. So position gurinchi he explained his model using a watermelon. Watermelon telusa andariki? Yes. So ee watermelon lo the black seeds they are there kada? Black seeds. Yes. So the black seeds they are like the negative charge. You are understanding? And the red part is like a positive charge. Try to visualize. Okay. Kabatti watermelon model kuda antaru. Watermelon model లేదా plum pudding model రా. Okay, you remember the names only. Theoretical discussion. ఈ మొత్తం it's a theoretical discussion. Okay, sir. No. So this was all ra. He said that your black seeds they are like a negative charge and your red part is like a positive charge. ఇదే కదా? Yes. What was the time, sir? Somewhere around 1800s రా. చూడండి టైం పీరియడ్ చూడండి అందరికి. 1800s అంటే mid 18s రా, mid 80s. Okay, so you can simply say ఆ టైంలో there were already a lot of scientists రా, a lot of scientists. అంటే న్యూటన్ already came. You are understanding? Yes. Okay. So now the next scientist, చెప్పండి, next scientist in the series, correct? Raising model లేదా plum pudding model లేదా watermelon model, ఇదే కదా? Yes. The next scientist that came into the scenario was Nobel Prize winner ra. Okay, they are all the Nobel Prize winners, the masters in their respective fields. చూసుకోండి, your Rutherford is not restricted up to your atoms only ra. In your radioactivity, Rutherford contributed a lot actually. Try to understand. Okay, Rutherford, sorry 1898. Correct. 1898 అంటే ఈ టైంలో you try to understand. Okay, it's not chemistry, right? It's physics. It's pure physics. You understand Schrodinger wave equation? You remember that in your chemistry you listen about, but it's physics. Okay, correct. The goats. Try to understand. Ee time lo Rutherford was doing his experiments, his own experiments ra. Student, at the same time Maxwell electromagnetic induction gurundunda. Maxwell equation, sir, EMI lo displacement current, Maxwell ampere equation. You remembering something like that? Ante all those things were done already. You are understanding? Your EM electromagnetic induction ra, dan tarvata everything about the wave nature of light, ante your X-rays, your gamma rays and all these things. You are understanding? The work was already done. Maxwell's equation were already completed. After that, he came into the scenario, Rutherford. Okay, yes. So what did he say? He actually performed an experiment. Okay, me andariki telusu kada, alpha scattering experiment. I'm not going into the depths. It has already been covered in your chemistry. Ante kada, or do you want me to go into the details ra? I'm skipping it. Okay, I'm skipping the details. He performed some experiments. Jagrataga vinandi andariki. He actually performed some experiments. Ante he took the gold foil, helium nucleus, alpha particle, scattered into them, some particles straight, some particles deviated, and one out of 20,000 particles nunchi a single particle was there that came 180-degree deviation. Ante went and came 1 out of 20,000. Ante you can easily estimate the size of nucleus and the size of atom. Okay, so what did he say? Chuskondi. I'm just writing the conclusions of your Rutherford's model. Chuskondi. Number 1, positive charge. at the center. ఇదే కదా? Yes. అంటే protons రా. Your protons, they are in the center. Next. Negative charge around the nucleus. ఇదే కదా? Yes. Around the nucleus. Next. Size of nucleus. ఇదే కదా? Yes. He said also about the size of nucleus. అందరికి size of nucleus అంటే ఏంటిరా? They do some comparative comparisons. Some comparative comparison అంటే ఏంటిరా? If your atom is like a football ground రా, your entire atom is like a football ground. ఆ football ground లో ఒక football పెట్టండి. That football is nothing but the size of your nucleus. ఇదే కదా? This is your nucleus. Very small. You are understanding? అంటే 99.9% of the space in atom is empty space. You are understanding? అంటే 99.9% is empty space రా మీ atom లో. Try to understand. Finished. That means you take Burj Khalifa, okay? Burj Khalifa, the building. You take every single atom of it. You take not Burj Khalifa, take pyramids. Take entire pyramids. And you take every single atom of that pyramid and shrink it. Shrink ante this extra space, either this empty space, you remove it. You are understanding? Yes. So when you remove this 99.9% extra space andariki from each and every single atom of your pyramids, you know what size you get? అంటే your entire pyramid can be shrink to a wheat grain size. అంటే this much. You understand? కానీ the mass of this will be equal to the mass of entire pyramid. అంటే you have a grain of wheat, you can never lift. Not even the grains, they can never lift. You are understanding? Try to visualize. అంటే this was the prime conclusions that were seen from Rutherford's experiment. Andariki. You are understanding? Sir. Next. So Rutherford model ni they also called it as solar system model. Ide kada? So what did he say? Andariki jagrataga vinandi. Okay, I want all of you attention. All of you. He said this is the nucleus. Nucleus lo mee daggara protons and neutrons are there. Ide kada? Yes. What about electrons ra? Your electrons are actually rotating around this nucleus. Idigo. In a circular motion. Andariki. You are understanding? Yes. So he said that these things are there and your negative charge rotates around the nucleus in circular manner. You are understanding? Sir. Circular manner ante there were a group of scientists. Try to understand. If you are a scientist and you have discovered something new, kani you have to tell it to the people kada. So what you do ra? You go to the committee of scientists. In today's age, and they are Nobel Prize committee kada. Yes, you go there, you present all your theories over there ra. Okay? They'll ask you some questions. Hey, how did you do this? How did you do that? Oh, all these things they'll ask. Okay? They'll ask you. Sorry. Okay? They will ask you something about how did you do that? Oh, they'll do something. Okay? They'll do something. So you will have to answer each and every single question. Ra. You are understanding? You will have to answer each and every question of them. If you are not able to answer, and they will say, hey, you are copied. Ra. Huh? You are copied. You don't know this also. Huh? Don't not rascal. So Rutherford, ra, hey, this guy, poor guy, he went in front of the scientists, and there were masters, goat of all times. Hey, Einstein was sitting there, all these scientists were there. So he said, Rashus, he said, hey, sir, listen to me, sir, I have electron. This electron is moving in a circle. Okay. So scientists asked him one thing. Hey, Rutherford, hey, picture, you tell me one thing. If this electron is moving in circle, చూసుకోండి. ఇప్పుడు I want all of you to link the things, okay? Link up the things. అందరికి జాగ్రత్తగా వినండి. for every single object to move in a circular motion. For every single object to move in a circular motion. Circular motion ante there is a mandatory condition. What is that mandatory condition, Ra? For a circular motion to happen, there must be a mandatory condition. There must be a mandatory condition. Enti Ra? Centripetal force. Centripetal force undali Ra. You are understanding? Ante this electron must have the centripetal force. Then and only then it can move in a circular way. Ide kada? Yes. So they asked Rutherford. Hey, Rutherford Ra, cheppu, is this moving in circular motion? Rutherford said, yes, it is. Mari, it should have centripetal force. Does it have? He said, yes. If it has a centripetal force, F is equals to ma kada? Yes. So F is equals to ma ante force unte compulsory la kachitanga acceleration kuda undali. Ide kada? Yes. So they asked him, so this electron has force, Rutherford? He said, yes. It has acceleration also? Yes. Let us go to Maxwell. They called Maxwell. So Maxwell, they said, Maxwell, chudara, this idiot, he is saying something. He is saying that this electron is revolving around the nucleus. You understand? So Maxwell said, Rutherford came now only. 10 years ago, I gave you 4 laws. What are the 4 laws, Ra? Your entire electromagnetic waves are standing on a single support. What is that? Every charged accelerated particle, chuskondi, every accelerating charged particle, ide kada, every accelerating charged particle chudandi emits radiation. Now Rutherford, he was speechless. Ante they asked him, hey Rutherford, cheppu, is this moving in circle? He said, yes. Is it have force? Yes. Is it have acceleration? Yes. Mari, acceleration unte should emit radiation. So if they are emitting radiation, its energy should be gone. You're understanding? Yes. Whenever there is a circular motion, there must be a centripetal force. Chudandi. So if it is emitting radiation ante, it should lose energy, Ra. Energy ante, your energy is gone. What energy, sir? Kinetic energy. You're understanding? Kinetic energy should decrease, Ra. You're understanding? Ante, I ate full, but I'm wasting my energy. That means whatever I ate, it should affect. The same thing, it has energy in the form of kinetic energy, mv square upon r kada. Hey, formula student here. Yes. So it is emitting the radiation and his kinetic energy should decrease. And it has only single energy, kinetic energy. If kinetic energy decreasing and V decreasing, speed. If speed decreasing and sometime it should stop. If it is stopping, here is positive charge, here is negative charge. Attract ante the electron should go and collide into the nucleus. You understand? And this entire process, this entire process should happen in 10 to the power minus 9 seconds, nanoseconds. Ante in a nanosecond of time, every single atom on this universe should be gone. Ante you and I are made up of atoms, kada? So every atom should be gone and you and I should not exist. But we are here. Understanding? Yes. But we are here. Ante cheppu. They asked Rutherford, if you and I are there, hey Rutherford, you and I are there, kada? Yes. Ante atoms are there. If atoms are there, ante electron is rotating. If electron is rotating, ante it is not falling. It is not falling, ante it is not emitting radiation. If it is not emitting radiation, ante it is not accelerated. You are understanding? If it is not accelerated, ante it is not having force. If it is not having force, ante it is not having centripetal force. It's not having centrifugal force. It is not moving in a circle. Gone. Entire theory gone. Understanding? So Rutherford could not say anything. He was speechless. Sad face. He went back to his home. Gone. Then there came a masterpiece. Masterpiece of physics, I would say. Simply masterpiece. Cheppandi ra. Peru cheppandi okkasari. What is the name? I want all of you to tell me his name, ra. Yes. The next scientist, the genius. Peru cheppandi okkasari. The name was okay, yes. So Niels Bohr. And this entire discussion was going on. There was a scientific community. There was Rutherford. Rutherford got, humiliated. Rutherford cried a lot in front of them. So Niels Bohr was watching everything from a corner. Okay, yes. So okaroju he went to Rutherford and he said, hey, it did not happen. I'm telling you the story. Okay, I'm making up the story. So he went up to Rutherford and he said, give me your theories, Ra. He was the theories. Okay, yeah, these are the mistakes. Okay, you cannot answer this. Kada? Yes. So Niels Bohr kept an eye, started observing every single scientist in the community. He got every secret of them, every secret of the scientists. And one day he invited all of them. Hey, come, I have theory. I will explain you something. So all the communities, they came together. Okay, separate ga prati oka scientist ki he showed that blackmailing video. Hey, I have your secret now. Now you understand whatever I'm telling to you. You're understanding? Yes. So he showed a blackmailing video. Hey, you are speaking. Your wife does not know it. Okay. He blackmailed everybody separately. Okay, one by one. One by one, he blackmailed everybody. He told all of them to sit in front of me. Sit, I'll tell you something. Okay, sit. Hey, it's a story. Okay, I'm making up, right? It's not true. Hey, it's not true. Okay, I'm telling you so that you understand. Hey, okay, sorry. So he said, hey, my dear scientists, my close friend Rutherford invented something, but you humiliated him. No, it's my turn. Now, I will tell you something. Hey, no. It's not true. It's not true. I'm telling you so that you get interest. I want to build your interest. Kabatti, story chapter, it's not true. Okay, it's not true. It does not work like this. Just good. So he said that. Sit. I'll tell you something. Okay? Scientist said, what do you want to tell us? He said, I will tell you a story. I will tell you a story. Believe it. Believe it. They all were surprised. So he started saying his story. Okay? Yes. He said, all of you, my dear scientists, my prominent scientists, I'm going to tell you something. Vinandi. He said it to the scientists. Hey, scientists, listen to me. Okay, just listen to me. Whatever I'm telling, don't ask for questions. Don't ask. Okay, don't ask. But listen. Just listen. So he gave us 2-3 postulates. 3 postulates he gave. He said that the entire problem in Rutherford, what the problem? Radiation and energy loss. You are understanding? Yes. The entire problem in Rutherford's model and energy loss. Yes. So Bohr said to the scientists, hey, you don't assume it. Okay? And if this is your nucleus and your electron, this electron is rotating in circles, right? Speed v, rotating in circles. Kani, it is not emitting the radiation. What are you telling? It is against Maxwell's law. Yes, I know. But believe. Believe me, okay? Believe me, I have some magic. I'm hiding a masterpiece, ra. Believe me. So scientists say, okay, tell. What do you want to tell, ra? Tell. He said, చూసుకోండి అందరికి. He said, if an electron is rotating in a given orbit, if an electron is rotating in a given orbit, point number one, he said everybody to believe. Nobody was believing. He showed that blackmailing video, okay? He said, now believe, okay? Now you will believe. Believe, okay? Believe. So he said, for a lather, he simply said, electrons revolve, okay? Electrons revolve around nucleus in circular orbits. ఇదే కదా? Yes. Point number one. He stated this, ra. దాని తర్వాత next thing, each orbit corresponds to a energy level. ఇదిగో అంటే ఏంటి? They asked him. He said, hey, listen to me, I'll tell you something, okay? Scientists said, yes, tell me. First thing, electron revolves around nucleus in circle. Hey, you gone mad rascal. Rutherford also said the same thing. Why are you wasting our time, ra? Why are you wasting? He said, hey, listen. I'll tell you. Listen. Each orbit corresponding to an energy level. Ante scientists ask, what do you want to say now, ra? You are blackmailing us. Also, you are telling this nonsense things, ra. Choose one. Scientists asked him. He said, hey, listen. So I will tell you, okay? I will tell you. So he said, if the electron is rotating in this orbit, it has different energy. Adhe same electron, if it rotates on another orbit, same electron, same speed, కానీ ఇప్పుడు the energies are different. అంటే ఒక్కసారి orbits change చేస్తే your energy level also changes. అర్థమైంది? Yes. So this was the second point. You change the orbits, your energy level also changes, ra. Finished? Yes. So scientists asked, what else, ra? Ante kada? He said, no. Hey, it just started, ra. Choose third point. Cheppandi. What third point, ra? Third point. This is chala important. Andariki. Electron cannot revolve anywhere, ra. Idigo. This is the biggest breakthrough. Anywhere. Randomly. Ide kada? Yes. Electron cannot revolve anywhere randomly. Ante he is not revolving here now. Koncham time tarvata he said, no, I don't want to revolve here, I want to revolve here. Then he said, no, I don't want to revolve here, I want to revolve here. He said, no, I don't want to revolve here, then I'll have to. No, does not work like that. Mari scientist asked, what else then, ra? Then he said that, చూసుకోండి, he said that orbits are quantized, ra. Oh my goodness. Orbits are quantized. Ante enti? Quantized ante enti, ra? Quantized ante enti? He said, let's shoot. Everybody. Okay, yes. Everybody. He said that. Ide mi nucleus kada? Yes. So this is your nucleus. Let us say this is an orbit, ra. It is an orbit. Orbit unte radius cheppandi. Sir, this is the radius. Ide kada? Radius is r. Andariki. Yes. Sir, where, what is it? Electron unte it should have some speed. Ide kada? And moving with some speed v, ra. Idigo. Circular motion already completed. ఆ circular motion lonchi, what is the formula for angular momentum, ra? Angular momentum cheppandi okasari. Your angular momentum is r bar cross p bar. Ante mvr, ra. Simply, your angular momentum is mvr. Idigo. This mvr, ante what is variable? Mass of electron fixed. Speed fixed. R ante variable. Ide kada? You can change the value of r. Kani cannot take any random values. Ante if your r1 is there, లేదా mv r2 is there, r3 is there, ఈ మొత్తం r1 r2 r3 r4 కోసం your angular momentum must be h over 2 pi, లేదా 2h over 2 pi, లేదా 3h over 2 pi, లేదా 4h over 2 pi. Idigo. You are understanding? Ante take any distance. I don't have any problem ra. Kani our distance kosame your angular momentum mvr ee mottam value it should be either h over 2 pi leda 2h over 2 pi leda 3h over 2 pi and so on so forth. What about 1.3h over 2 pi, sir? Sir, mvr is equals to rn. Let us say rn ra. This is rn. ern kosam your mvr value is 1.3h over 2 pi. Got? Not. Reject. Electron can never rotate in this orbit. You are understanding? Yes. Electron can never rotate, revolve in orbits. Okay. Electron can never rotate in orbits for which your angular momentum 1.3h over 2 pi, 1.2h over 2 pi, sir, 0.7h. No, not points. Nagu points. I hate points. I don't want points. Perfect number kavali kada, integer. Idigo. Ante your mvr should be equals to nh over 2 pi. Ante you put only the values of r for which this entire quantity should be perfectly multiplied by h over 2 pi. Idigo. You're understanding? Sorry. So this is his quantization. Ante endira quantization of angular momentum. Ide kada? Yes. So he said that your mvr should be nh over 2 pi. Finished. And one last postulate. Andariki last postulate. Last postulate enti sir? Your last postulate has chuskondi excitation and de-excitation of electron. Andariki excitation and de-excitation of electron. Ardhamaindi? Yes. Hey, I don't know ra. Naku teliyadu if you have been good at all of this in your chemistry, okay? Endukante every single thing is there in your chemistry. Same to same, ditto same. Atomic structure chapter, okay? The only thing is that there you study about your Schrodinger wave equation. Here we don't have that, right? For your syllabus, we don't have a Schrodinger wave equation. Just one. Kani, I want all of you to be very good, extremely good at these calculations. Endukante NEET 2025 lo they have asked a simple derivation based question. Andariki. Okay. Chuskondi. Now, excitation and de-excitation of electron ante enti? Bohr said, ide me nucleus. This is your first shell. Ante R1 values తీసుకోండి. Right. R1 values. Ide kada? R1 values. I should rather comment on values first. చూసుకోండి. Your MVR should be equals to NH over 2 pi kada? చూసుకోండి అందరికి. R ante what ra? Radius of orbit. Idigo. If your R1 ante let us say your MVR1 should be equals to n place to 1 pettandi. Sir, 1h by 2 pi. Idigo. Similarly, your MVR2 is equals to 2h over 2 pi. Lastly, your MVR3 is 3h over 2 pi. And MVR4 is 4h over 2 pi. Idigo. Ekkadi nunchi your R1 value ra. Your R1 ante it's a specified value kada? Specified ante first shell ra. First shell. Andariki first orbit. Leda, yes, I'll give the notes. Don't worry, okay? The notes will be provided. R1 ante the first radius ra. First radius ante చూసుకోండి. N value 1 kada? N value 1 unte R1 ante radius చూసుకోండి all of you. Radius of first shell లేదా first orbit. ఈ orbit పేరు ఏంటిరా? N equal to 1 kada? That means it is K shell. You understanding? Here n equal to 2 kada, so it is L shell. Then R2 ante entira? R2 is radius of సెకండ్ షెల్ ఇదే కదా. చెప్పండి R3 అంటే ఏంటిరా? R3 is radius of your third shell. ఇదిగో థర్డ్ షెల్ అంటే ఏంటిరా? n equal to 3 అంటే your m షెల్ అందరికి. I hope you are understood the names రా. KLMN shells ఉంటుంది కదా. Yes, KLMN shells. R4 అంటే ఏంటిరా? It is your radius of fourth shell. ఫోర్త్ షెల్ అంటే ఏంటి సార్? మీ ఫోర్త్ షెల్ కోసం n వాల్యూ 4 ఉంటుంది అంటే ఇట్ ఈస్ n షెల్ రా. ఇదిగో n షెల్. సరే, mostly we need only these 4 shells to write all 118 elements in your periodic table. You are understanding? All 118 elements could successfully be written using these 4 shells only ra. Sare. Okay, so excitation and de-excitation gurinchi chuddam andariki. So let us say ide na k shell kada, k shell unte r1 distance ra, radius is r1. Next, this is my L shell ante r2 distance. Idigo what did Bohr said ra? Hey, he is still in the conference room, okay, blackmailing the scientist. He is telling on gunpoint, he is telling to accept. So scientists are accepting. Andariki chuskondi ide kada. Yes, so he said if electron is in k shell, chuskondi, as we go away from nucleus, idigo ide kada. Yes, as we go away from nucleus, చెప్పండి రా, energy of electron ఇదే కదా. yes, energy of revolving electron increases. Finished. This is the statement. If you understood this, well and good. Not understood ante I will explain. చూసుకోండి. Away from nucleus ante L shell more away, చాలా distance కదా. So this has more energy, this has less energy. అంటే ఈ shell లో energy ఎక్కువ, ఈ shell లో energy అంటే తక్కువ. ఇదే కదా. yes, so let us say if you want to send this electron from this to this shell ra, energies match ఉండాలి. ఇదే కదా. yes, your energy should match for the given shell. That is the first postulate ra. Bohr has the first postulate. And if you want to send the electron in this, you give energy. ఇదిగో, you give energy to electron. You are understanding? Yes, give energy to electron like this. Leda, this is known as excitation. Okay, excitation ante enti ra? Lower to higher orbits ante excitation of electron. And in the second case, if you want to do the reverse ante your electron is here coming to the k shell ante electron releases the energy. Idigo, you are understanding? Yes. So from a higher to lower ante higher shell nunchi lower shell, electron releases the energy. Okay, lower shell to higher shell, electron needs the energy. Ide, you are understanding? Sir, now with all of that being said, okay, with all of that being said, Bohr said, hey scientist, all of you agree to me kada? Scientist said, yes, we agree. So now Bohr took the gun, kept in the pocket, mobiles kept in the pocket. He said, hey, chudundira, now I will tell you something, okay, and your brains will get disturbed completely. Idigo, he started showing the mathematical results. Ante ippudu we are going to do some mathematics andariki. Okay, so the students who are weak at maths, I don't know what to do, but whoever is understanding, hey, listen to me, okay. So now Bohr was ready with all of his postulates ra. Jagattaga vinandi. Bohr was ready with all of his postulates, and ippudu, okay, no, for innermost shell the energy is the lowest energy. Your innermost shell, as you are going away, energy of the shell increases. Not at all. Your energy for the innermost shell is the lowest. Kabatti we write your electronic configuration kada, 1s2, 2s2, 2p6, 3s2a. Why ra? Increasing order of energy. 1 first shell lowest energy, 2 second shell little high, 2 second shell little high, 3 third shell, energy increasing. You remember, okay, if you have any misunderstandings, clear it now itself, ra. Don't keep it in your examinations. Just go. Now let us talk about the maths. So weak-hearted students, don't say it, okay? Weak-hearted students, లేదా ignore. Okay, I want all of you to remember the results only. ఎందుకంటే the physics we are studying it in physics kada, so physics కోసం your formulas and your derivations it must be by hearted ra. Okay, so ఈ మొత్తం derivation it must be by hearted to all of you. జాగ్రత్తగా వినండి. So Bohr stated, చూసుకోండి, let me again revise the postulate ra. Point number 1, rotates around circular nucleus. Energy అంటే fixed shell, ఒక షెల్ లో ఒకటే లెవెల్ ఆఫ్ ఎనర్జీ ఉంటుంది. థర్డ్ పాయింట్, cannot revolve in any shell అంటే your MVR should be equals to NH by 2pi. ఇదే కదా? Yes. So for now let us only consider these three things and let us see here. అందరికి చెప్పండి. So I'm doing maths now, okay, all of you. What clarity you want, Ishu? Yes, Parimala, I'll be doing it. Don't worry. Okay, don't worry. Chusko. So if this is your nucleus, andariki ide mee nucleus kana? Yes. Okay, right. Now let us say andariki jagrataga vinandi. So this is the shell. Okay, shell. First shell ante K shell, second ante L shell, third ante M shell, fourth ante N shell kada? Yes. కానీ let us say it is nth shell రా. ఒక జనరల్ షెల్ తీసుకోండి. nth షెల్ ఉంటే చెప్పండి, what do you say? nth షెల్ ఉంటే ఈ షెల్ లో the angular momentum of electron should be MVR equals to NH over 2pi. ఇదే కదా? ఎందుకంటే it's the nth షెల్ రా. nth షెల్ ఉంటే NH. First shell 1H over 2pi, second shell 2H over all this thing. I think అర్థమైంది అందరికి. Now what I want all of you to understand is, ఇప్పుడు చూడండి, if this is your electron, all of you ఇదే అంటే this is mass m. Mass of electron అంటే m కదా? Yes. Energy is more in higher orbits. The basic understanding is this only ra. చూసుకోండి, you're understanding whatever I have written, you read it. As we go away from nucleus, energy increases. Ante shell energy simply increases. Try to understand it. Okay? Yes. You're understanding the shell energy increases as we go away from nucleus. Ante higher orbits kosam. Me higher orbits kosam energy is also high. Idigo. Try to understand it. Ide kada? Yes. Now next. చూసుకోండి. If mass is m, your speed of rotation is v, radius is r. Andariki correct kada? You're understanding? Yes. Sir, now let us do some physics ra. Physics cheppandi. Hey, before that let us go into some chemistry. Okay, what is the symbol for atomic mass ra? Atomic number, sorry. What is the symbol for atomic number, sir? Atomic number ante Z. What is your atomic number ra? Can you tell me the definition? What is your atomic number? I want to know. Let us see how many of you are having the clarity. What is atomic number? Number of? What is atomic number? What is atomic number? Hey, atomic number ain't ra. You don't even know what is atomic number. You'll search on Google and tell me. Correct. Number of protons, not electrons. Not electrons. Chusko. Number of protons. Sorry, very good. Andariki. So if this is your nucleus, andariki jagrataga vinandi, okay? If this is your nucleus, atomic number is 1. Cheppandi, how many protons are there? 1 proton. Ide kada? Yes. Very good, sir. Very good. Ardhamaindi. Sorry, chuskondi. Now. Atomic number 2 ra. Tell me, how many protons are there in the nucleus? 2 protons. Ide kada? Yes. Okay. ఇప్పుడు ప్రోటాన్స్ అంటే ఏంటి సార్? ఇట్స్ అ పాజిటివ్లీ చార్జ్డ్ పార్టికల్. వాట్ ఈస్ ద చార్జ్ ఆన్ ప్రోటాన్ రా? వాట్ ఈస్ ద చార్జ్ ఆన్ ప్రోటాన్? ప్లస్ ఈ ప్లస్ ఈ ప్లస్ ఈ. ఈ అంటే చార్జ్ 1.6 into the power minus 9. ఆల్ దిస్ థింగ్స్. సో చార్జ్, నాకు చార్జ్ గురించి చెప్పండి రా. చార్జ్ ఆఫ్ ప్రోటాన్ అంటే ఏంటి సార్? ఐ హ్యావ్ టు టీచ్ బేసిక్స్ ఆఫ్ కెమిస్ట్రీ, ఇదే కదా? ఎస్. అంటే సింగిల్ ప్రోటాన్ సింగిల్ చార్జ్ ప్లస్ ఈ. సింగిల్ ప్రోటాన్ కదా, 1 ప్రోటాన్ అంటే ప్లస్ ఈ చార్జ్. 2 ప్రోటాన్స్ చెప్పండి రా, 2e చార్జ్. అటామిక్ నెంబర్ 3, Z equals to 3 అంటే 3 ప్రోటాన్స్ అంటే 3e చార్జ్. అర్థమైంది? ఎస్ సార్. అటామిక్ నెంబర్ Z ఓన్లీ అంటే Z protons and Ze is the charge at the center. అర్థమైంది అందరికి? yes. So if at all you have a random atom అంటే ఏంటిరా? అటామిక్ నెంబర్ Z అనుకోండి. సో అటామిక్ నెంబర్ Z అంటే మీ న్యూక్లియస్ లో టోటల్ పాజిటివ్ చార్జ్ చెప్పండి సార్. యువర్ న్యూక్లియస్ హ్యాస్ అ టోటల్ పాజిటివ్ చార్జ్ ఆఫ్ Z into E. Z అంటే అటామిక్ నెంబర్, E అంటే చార్జ్ ఆన్ సింగిల్ ప్రోటాన్. ఇదిగో అర్థమైంది? రైట్. వాట్ అబౌట్ ఎలక్ట్రాన్ రా? దిస్ ఇడియట్ ఎలక్ట్రాన్, ఇట్ ఈస్ రొటేటింగ్ అరౌండ్ ద న్యూక్లియస్. చార్జ్ చెప్పండి రా. మైనస్ ఈ. ఎస్, minus E is the charge of electron. Okay sir. Ze అంటే ఫస్ట్ చార్జ్, minus E అంటే నెగటివ్ చార్జ్. న్యూక్లియస్ లో పాజిటివ్ చార్జ్ ఇస్ దేర్, ఎలక్ట్రాన్ నెగటివ్ చార్జ్ ఇస్ దేర్. అంటే ఈ ఎలక్ట్రాన్ పై దేర్ ఇస్ ఫోర్స్ ఆఫ్ అట్రాక్షన్. రేడియస్ లేదా డిస్టెన్స్ r ఉంటే వాట్ ఈస్ దట్ ఫోర్స్ ఆఫ్ అట్రాక్షన్ రా? ఎలక్ట్రోస్టాటిక్స్ సార్. ఫోర్స్ ఇస్ ఈక్వల్స్ టు సంథింగ్ లైక్ k q1 q2 upon r square. The same. That is the force of attraction. Hey sir, your force of attraction is equals to k into q1 into q2 divided by r square. ఇదిగో k value అంటే 1/4π అంట అందరికి. I want all of you to be very clear at values. k అంటే 1 upon 4π. We'll keep it. I am going to replace. కానీ ఇప్పుడు I don't want this conclusion. ఓకే, చూసుకోండి. q1 అంటే ఏంటిరా? ఫస్ట్ చార్జ్. వేర్ ఇస్ యువర్ ఫస్ట్ చార్జ్? ఇదే ఈ మొత్తం. వాట్ ఈస్ ద వాల్యూ ఆఫ్ q1 సార్? Ze. What is second charge ra? Divided by r square అంటే r square. ఇదే కదా? yes. So this is your attractive force. ఇదిగో అంటే సింప్లిఫై చేసుకోండి ఒకసారి. your attractive force comes out to be k z e square upon r square. సరే, this is attractive force. all of you, this is attractive force కదా? సరే, now చూడండి. ఎలక్ట్రాన్ circular motion, centripetal force. What is centripetal force sir? So centripetal force should be equals to m into v square upon r. This should be the value. Ante if your electron is rotating with speed v in radius r, a case lo you must say that this should be the condition. Ante value ra, value చూసుకోండి all of you. This value of force should always act to the center. కానీ in what form is it acting ra? You understanding? If it is rotating in circle, there must be a force in the center. Always. Mottam times kosam ra. Always there should be a force to the center, and the value of that force should be this centripetal force. Kani, we have seen just now. What is the force to the center? Electrostatics. Ante your electrostatic force of attraction is keeping the electron in circular motion. You are understanding? Ante your attractive force between this nucleus and electron, electrostatic attraction kada, this attractive force is keeping the electron in a circular motion. Andariki ante entira, the forces should be equal. Chuskondi. That means your centripetal force should be equals to your attractive force. Then and only then it can rotate in a circle. Bohr was doing all this calculation in front of the scientists. Okay, he was explaining this to the scientists. Cheppandi, centripetal force ante enti sir? mv square upon r. Ide kada? Should be equals to attractive force. Cheppandi okasari. k z e square upon r square. Ide kada? Sir, what you can do now is you can cancel out this r and r. Ardhamaindi andariki? Leda, you keep it, right? You keep it. Okay, you keep it. And the second thing is, he said this, చూసుకోండి, this, ఈ మొత్తం. He said he said his equation 1. Ide. Bohr was doing this mathematics. Okay, he was doing this mathematics. He said, sir, this is first equation. Hey, that is my equation, kada. That is my second equation. I told you on gunpoint. On gunpoint. Bring it here. Bring it here. Ante here MVR should be NH over 2 pi. Idigo. It should be H, kada. Yes. This is equation number 2. Ipudu, what you do is in JE, okay, for JE students, I tell them to simplify usually the MV value తీసుకోండి ఎక్కడ నుంచి substitute all. But I am telling you to divide. Divide. What divide, sir? What divide, sir? Divide equation 1 by equation 2 అందరికి. Understanding? Are you understanding? Divide equation 1 by equation 2. లేదా. You square the first equation. చెప్పండి. M square, V square, R square, N square, H square. 2 square is 4 kada? Yes. So ikkada I will be writing. Hey, I am squaring it ra. Hey, 4 pi square. Idigo. Ante kada? Now divide. Ante your numerator M V square divided by R into M square V square R square should be equals to divide. Sir, K Z E square divided by R square into N square H square divided by 4 pi square. Idigo. Understanding? Pure maths ra. Pure maths. Okay? Pure maths. Kabatti I have told you, the students weak at mathematics will not be understanding much. చూసుకోండి. Let me write the equation again. Okay, mv square by r into mv square divided by r into m square v square r square should be equal to kz e square upon r square. Yes, kz e square divided by r square into n square h square divided by 4 pi square. You take it up, inverted kada? Yes. And simplify. Idigo. V square got. Point number 1. Do you think you can cancel out something? No. Reverse it. Hey, m kuda gone kada? Yes. So 1 divided by, cheppandi here m is remaining, r into r square ante r cube. Idigo. This r square also gone ra. Ante 1 upon r multiplied by n. It is only remaining kada? That should be equals to 4 pi square k z e square divided by n square h square. Sorry, this m is there. Send it that side. Multiplication. Ante 1 upon r equals to m into 4 pi square k z e square divided by n square h square. Invertendo తీసుకోండి. Your invertendo is n square h square divided by m into 4 pi square into k into z into e square. K value ra. K ante 1 upon 4 pi epsilon naught. Ide kada? Substitute. Ante your radius value comes out as n square h square divided by m multiplied by 4 pi square. Hey, m into 4 pi square kada? Yes. Multiplied by k. 1 upon epsilon naught multiplied by z e square. Idigo. Ardhamaindi? 4 gone. 1 pi gone. Ee epsilon naught it will shift up ra. So ekkada nunchi r is equals to n square h square epsilon naught divided by pi is remaining. Okay? Pi m z e square. Idigo. This is the value of your radius of nth shell. Okay, this is the radius of nth shell. Okay. చూసుకోండి. అంటే ఏంటిరా? You write, okay, rewrite it. H అంటే ఏంటి సార్? ఈ ఫార్ములాలో I did not tell you about H కదా? Hey, H అంటే Planck's constant రా. Okay, H అంటే it is your Planck's constant. Value చెప్పండి ఒకసారి. Do you know H value రా? Do you know H value? Hey, do you know H value? రే అందరికి Yes, correct. So your H is equals to 6.6 10 to the power minus 34 approximate. Finished. So let us rearrange the terminologies. Ante your H value, I'll write something like this. Choose and it is H square epsilon naught divided by pi m e square. Ide kada pi m e square. M ante entira? M ante mass of electron. Okay, idigo mass of electron 3.14. E ante charge of electron 1.6 into 10 to the power minus 19. H 6.6 10 to the power minus 34. Epsilon naught 8.85 10 to the power minus 12. Constants ఈ మొత్తం దే ఆర్ కాన్స్టెంట్ క్వాంటిటీస్. ఇప్పుడు రిమైనింగ్ థింగ్ చూసుకోండి, న్యూమరేటర్ నుంచి h స్క్వేర్ ఎప్సిలాన్ వచ్చింది కదా, n స్క్వేర్ ఇస్ రిమైనింగ్ అండ్ డినామినేటర్ లో z ఇస్ రిమైనింగ్. z అంటే అటామిక్ నంబర్. యూ చేంజ్ ద ఆటమ్, z విల్ చేంజ్. యూ చేంజ్ ఆర్బిట్స్, n విల్ చేంజ్. అంటే ఈ మొత్తం దే ఆర్ వేరియబుల్స్ అండ్ రిమైనింగ్ మిగతా ఎవ్రీథింగ్ ఇస్ కాన్స్టెంట్. సబ్స్టిట్యూట్ చేసిన తర్వాత 6.6 into 10 to the power minus 34 whole square epsilon naught value రా divided by pi value, m value చెప్పండి ఒకసారి. I think 9.1 into 10 to the power minus 31 kgs ఇదే కదా. Yes, e square 1.6 into 10 to the power minus 19 whole square రా multiplied by n square upon z. ఇదిగో these are numbers only. సింప్లిఫై చేసుకోండి. సింప్లిఫై చేసిన తర్వాత you are left with r is equals to, can you tell me ra, can any one of you tell me what is the value of r, sir? This comes out as 529 idigo into n square upon z. Now the biggest problem is with units ante telusa, units. Sir, if I am talking about picometer leda I am talking about angstroms. So if you are talking about your angstrom ra, angstrom ante telusa. So if you are talking about angstrom, it is 0.529 angstrom. Leda if you want to talk about picometers, r is equals to 52.9 n square upon z picometers. ఇదిగో picometer అంటే 10 to the power minus 12. అర్థమైంది? 0.529 angstroms. Remember the units, okay? Units అంటే చాలా important. I'll write something, the simplification over here రా. ఇదిగో. So you can simply say, sir, your r is equals to 0.529 n square upon z angstrom. 1 angstrom equals to 10 to the power minus 10 meters ra. Leda 52.9 n square upon z picometers. 1 picometer equals to 10 to the power minus 12 meters. అర్థమైంది అందరికీ? సరే, you are understanding? Right. Correct. Next radius గురించి వచ్చింది కదా. Let us talk something about your velocity లేదా speed కదా. Yes. So speed కోసం you can simply say, sir, మళ్ళీ ఒకసారి mvr equals to nh over 2pi ఇదే కదా. Yes. Your Bohr's formula ra, angular momentum quantization చూసుకోండి. ఎక్కడ నుంచి your v comes out to be nh divided by 2 pi mr. ఇదిగో అర్థమైంది? Yes. So you can simply say n value is n only, h only, 2 pi only, m only, r value చెప్పండి రా ఒకసారి. ఇప్పుడు my expectation from all of you, physics law, I'm not talking about chemistry, okay? Physics law, my expectation from all of you is this. You must be remembering this formula. R equals to n square h square epsilon naught divided by pi m z e square. I want all of you to remember this formula, okay? Directly remember this formula. No. This derivation is required. For sure required. ఎందుకంటే I'll tell you something. చూసుకో. Can you see it? Hey, can you see it? This question, can you see this? 2025 కదా. See, you need derivation. You can't do it. Understanding? You can't do it. You will skip this question, ra. Yeah, understanding? If you know derivation, it's done. Okay. You read this question, okay, and then you read this question. A particle of mass m moving around origin with a constant force F, centripetal force. If Bohr model is used, the radius of nth orbit. And mv square upon r should be the centripetal force. You are understanding? Used. Okay, used, it's used. Increase your quality, ra. Okay. Sorry. Next. Hey, nothing could be said. I want all of you to, be good with the derivations also. It's not difficult. Andariki. You do this, okay, for now. Only for sincere students. Sincere students question. I want all of you to keep this on your number one priority. Number one priority. If you are taking my word seriously, I am guaranteeing you 4 marks, all of you. I'm guaranteeing you 4 marks. Aim cheyali. You watch the video again ante entira, right from this part, okay? Right from this part. I don't know where the time duration, choose by yourself, okay? From this part, you watch it again and take a pen and paper, do everything, try to do everything by yourself. You'll not understand. Malli okkasari video pai vellandi. See the video, again do it. If you're not understanding, again do it. It will hardly take somewhere around 30 minutes andariki. Ee 30 minutes lo come back to the video, again do it, again understand, come back to the video, again do it. And once your entire results are completed, you do them by yourself, all of you. You do them by yourself without a video. You're understanding? I guarantee you. My guarantee. This is my guarantee, okay? You will love this topic now. Simply love it. Anyways, so this is your value for speed. Yes. So this is not required. This derivation is not required. I'm just doing mathematics. Right? It's just a mathematics. And n square, h square, epsilon naught by pi m z square. Simple maths, kada? Yes. Pi m z square. And your velocity comes out to be z e square divided by 2 epsilon naught nh. This is your velocity formula. I want you to remember these two formulas also. You're understanding? Kani. When there is a conceptual application ante entira. Choose this centripetal force should be equals to attractive force. You are understanding this equation. Migita, everything it's mathematics only. The concept is this only. You understand? I want all of you to be good at concepts, not at simplifications. I know it will be more difficult for you to simplify. Okay. Yes. Sorry, 37 minutes. Whatever it is there. Okay. Whatever it is there. 37, 40 minutes. Instead of 30, you will give 1 hour. Let it be. It is clearing 2 subjects. Me chemistry and your physics also. Understand? Sir. So, in case those NTA people, if they get crazy, if they take a difficult paper, you will not hesitate. You understand? Sir. No, not about you. There might be students that are weak at maths, kada? Science. So choose andariki. So your entire simplification could be written as e square divided by 2 epsilon naught into h multiplied by z upon n. Idigo. Ee mottam ante constant quantities ra. E square 1.6 into 10 to the power minus 19 coulomb whole square divided by 2 into epsilon naught 8.85 10 to the power minus 12 into h value 6.6 10 to the power minus 34. Idigo. Multiplied by z upon n kada. You simplify this. Units kuda teeskondi. Units keep huge significance. This is the speed. Ide kada? Yes. Sir. No, it's not from 154. Hey, you're telling that I just did time pass for that 154 minutes, huh? Sir. So this was the result, sir. And to be honest, okay, jokes apart. These results were accurate, very accurate. Ante, what did I say? Bohr's did he give blackmail and all this? These were the results. Ante, they explained the phenomena very beautifully. Trust me. Kabatti, I've told you. The masterpiece. Niels Bohr ante, that is the very huge breakthrough. Niels Bohr is a masterpiece. You are understanding? Niels Bohr is a masterpiece. Andariki, student. Now, let us talk something about your energy of electron. Andariki. Let's talk about your energy of electron. Ante, if this is your nucleus, okay, hey, give me a minute, okay, give me a minute. Let's search something on it. Where is it? Twitter ka? I don't know Twitter. Can you see it? Can you see this picture, all of you? Is it visible? Hey, you don't want it. Remove. Choose continue. This is a list of the scientists. And these were responsible for your entire modern physics. Choose continue. You know him? You know him? Hey, this guy, hey, this guy. Schrodinger. Hey, where did it go? It's there. It's there. Choose continue. This guy is Schrodinger. Hey, Einstein, Einstein. Hey, yes. Hey, this guy. Hey, am I confusing you too much, Yes, in one frame. This is Einstein. Where is your Bohr, Hey, Bohr not visible, Hey, this image is cropped only. Hey. Yes, this one. Choose continue. Hey, this one, Re. I think this one, okay, this one. Where is Bohr? Can you identify Bohr? Where is he? Hey, where is he? Niels Bohr. Hey, this one. See, this guy. He's Bohr. He's Bohr. This idiot. You're understanding? This is Bohr. Hey, Max Planck. Where is it? Bald person. Hey, where's your bald person? Hey, Max Planck. Okay, this is Max Planck. Choose one. Hey, this is Max Planck. Okay, your Madame Curie. And all these things, okay, try to understand. Everybody, scientists, group of scientists. Okay. Anyways, let us come back to the discussion. Wasting time. Choose one. So, energy of electron, kida? Yes. Energy of electron. Ante, let us talk about the total energy. Yes, they are all looking same only. Yes. Choose one. So there were these elite meetings that used to happen. Kabatti, your 1850 to 1960 time, very highly crucial time for your scientific discoveries. Yes. So energy of electron, choose one. This is your nucleus. Yes. In this nucleus, hey, did you observe one thing in this picture? Did you observe one thing? Who is sitting in the center, you know? Who is sitting in the center? Who is sitting in the center? Can you tell me who is sitting in the center? Yes. If they are not there, no need to study physics. Okay? If they are not there, no TV, no internet, nothing at all. Yes. He is at the center. Choose one. This guy. Genius of the centuries. You are understanding? Ante, out of all these, genius of the centuries, this one. This. Okay? If Newton was alive, I would have said Newton. Obvious. Understanding? Sorry. Anyways. All these things have their own significance. There is that guy also. I'm not finding him. He's there. For sure he's there. Okay, he's there. Not there. This is Schrodinger, I know for sure. Not. Hey, you see this? Hey, can you see this? Charlie Chaplin. ఏ చార్లీ చాప్లిన్ రా, ఇదే కదా రే, ఏ చార్లీ చాప్లిన్. దిస్ ఈజ్ యువర్ de Broglie hypothesis కదా. yes your de Broglie. ఏ this one చూసుకోండి, ఏ ఈజ్ హైడింగ్ కదా, ఏ హైడింగ్ ఇన్ ద బ్యాక్. దిస్ ఈజ్ de Broglie, de Broglie hypothesis. సరే, yes, so let us talk about your energy of electron andariki. So if you have an electron, చూసుకోండి, I'm directly writing, okay, I'm skipping the formulas. It's not Charlie Chaplin, right? He is looking like Charlie Chaplin. I've just told you, okay. Anyways, చూసుకోండి. So the electron has both type of energies, ante the total energy of electron, it is equals to, చూడండి, let me just rotate it here. Yes, the total energy of electron is in two forms ra, two forms. Cheppandi, what are the forms? Number first is your kinetic energy plus your potential energy. Andariki ardhamaindi? Yes, so your kinetic energy is half mv square plus your potential energy, చూసుకోండి, charge అంటే నెగటివ్ ఈ కదా, and here it is z into e రా అందరికి. Electrostatics లో if you have negative and positive charge, the potential energy is minus k q1 q2 upon r. ఇదిగో negative k q1 q2 upon r, ఇదే కదా. yes, minus k వాల్యూ చెప్పండి, q1 వాల్యూ చెప్పండి రా ఒకసారి. q1 is ze, q2 వాల్యూ e divided by r, ఇదే కదా. yes, so this is your total energy andariki. Try to understand. Now you must be good at all these derivations. Your understanding, you must be extremely good. Nothing could be said ra. So let us do this analysis separately ante మొదటిగా మీ kinetic energy కోసం. So let us say kinetic energy అంటే half mv square. half is half, m is m, v square చెప్పండి, z e square divided by 2 epsilon naught nh కదా. yes, whole square అంటే it is half m z square e to the power 4 divided by 2 epsilon naught n h. Simplify చేసుకోండి, it is coming out as 1 upon 4 into m into e to the power 4 divided by epsilon naught into h multiplied by z square upon n, ఇదే కదా. and directly writing ra, so it is 1 upon 4 multiplied by, you simplify everything, understand, you simplify everything. So this, yes, so your kinetic energy is m e to the power 4 divided by epsilon naught h into z square upon n. చెప్పండి ఇప్పుడు let us talk something about your potential energy ra. Can anyone of you tell me the formula for potential energy, sir? minus k q1 q2 upon r, ఇదిగో minus k అంటే minus 1 upon 4 pi epsilon naught అందరికి. q1 value ze, q1 value ze into q2 value e, proton electrons kada, r value ra n square h square epsilon naught by pi m z e square, idigo. Therefore I told you, not compulsory, I'm not telling you to do all the derivations, but at least understand the concept ante enti ra. This is your concept. Total energy is kinetic plus potential. You are understanding? Kinetic formula, potential formula. Even if you are good at this, sufficient. I don't want mathematics to be done, ra. You are understanding? Sir, I don't want all of you to do all these tedious calculations. No, I'm doing it by myself. So any interested student is there, remember these results also. Okay? Let us take a break after an hour. Okay, once this entire theory gets completed, because I have to discuss a lot of things also. So energy and all these things. Okasari your chapter has been completed, we'll take a break. 3 o'clock class starts. It's kada. So let us end. Let's take a break at 5:10 or 5:20, something like that. Okay, choose good. So your potential energy is coming out something like this: minus 1 upon 4 pi epsilon naught into z e square multiplied by pi m z e square divided by n square h square epsilon naught. Understand? Do you think something cancels out? Yes. Pi gone. Mari, do you think some gets cancelled out? No. Ide kada? Yes. Cheppandi. Hey, correct? Not correct, ara? Oh, I'm sorry, I'm doing a mistake. Try to understand, okay? Try to understand. That's a mistake. That's what I'm telling you. You're understanding? That's what I'm telling you. If your derivations are not good, I don't remember these things, okay? You do half m instead of z e square and z square e to the power 4 divided by, it should be 4 epsilon naught square n square h square and half into 1 by 4 into m z square e to the power 4 divided by epsilon naught square n square h square. So 1 by 2 into 1 by 4 and 1 by 8 into m z square e to the power 4 divided by epsilon naught square n square h square. Here, did I do something? No. So here, pi gone kada. So you are left with minus 1 upon 4. Andariki. I want all of you to observe now. Okay. I want all of you to observe. Chuskondi. So, idigo epsilon naught is remaining in the denominator. Ante e epsilon naught squared. Megida sir, it is n square h square epsilon naught square numerator cheppandi okasari. Sir, z into z ante z square kada? Yes. Sir, m is only m. What about this ra? E square into e square. Cheppandi. E to the power 4. Idigo. Now, all of you. Rewrite ra. Minus 1 upon 4 into m z square e to the power 4 divided by n square h square epsilon naught square. Idigo. Not required. These simplification not required for you, but application is required. You are understanding? Sorry. So when it comes to this, can I simply say, చూసుకోండి అందరికి all of you. This is my kinetic energy. This is my potential energy. ఇదే కదా? Yes. So now focus. If you call this entire quantity as x ra, hey, అందరికి, now we are going to a result, okay? చూసుకోండి, same quantity కదా? ఎక్కడ కూడా, and here also same quantity. ఇదిగో this x, so this also becomes equal to x. Fine. Sir, అర్థమైంది. అంటే if your kinetic energy is 1 upon 8 into x ra and your potential energy is minus 1 upon 4 into x. ఇదిగో take the ratio, sir. Tell me the ratio, sir. Can I simply say, చూసుకోండి, your kinetic energy is nothing but, I want to express in 1 by 4 kada, so I'll do one thing. చూసుకోండి అందరికి. Can I simply say half into 1 by 4 into x. ఇదే కదా? చూసుకోండి, 1 by 4 1 by 2 అంటే 1 by 8. This value అందరికి, this value 1 by 4 into x, 1 by 4 into x. Sign కూడా గుర్తుపెట్టుకోండి. అంటే if your u is minus 1 by 4 into x, your negative u becomes 1 by 4 into x. ఇదే కదా? So ఈ place of 1 by 4 into x minus u పెట్టండి. So your kinetic energy is minus half times of potential energy. అంటే send this to that side. Sir, your potential energy is minus 2 times the kinetic energy. Ante your potential energy is negative. Point number 1. Good pettukondi. You are understanding? Yes. Your potential energy is negative. Okay. Your potential energy is negative and double that of kinetic energy. Ardhamaindi? Sir. So this is an important relationship. You are understanding relationship between potential energy of electron and kinetic energy of electron. Try to understand. Andariki. Okay. Ante your total energy, ఇప్పుడు చెప్పండి అందరికి, your total energy E total should be equals to potential plus kinetic కదా? Hey, potential అంటే ఏంటిరా? minus 2 times kinetic energy. Okay, plus kinetic energy. అంటే your total energy should be equals to negative of kinetic energy. ఇప్పుడు చూడండి. So the total energy of electron is negative. Negative అంటే ఏంటిరా? The electron is in loan. Borrow, okay? Borrow. It is in loan. You are understanding? Sorry. So your total energy is negative అంటే minus k అంటే minus kinetic energy, negative of kinetic energy. లేదా చూసుకోండి. So can I simply say, sir, ఎక్కడి నుంచి చూసుకోండి, this 2 is in multiplication, division లో పంపిండి. So you can simply say, sir, potential energy by 2 is minus kinetic energy. Substitute minus kinetic energy అంటే it is simply equals to potential energy by 2. ఇదిగో this is the star of the show. Ante your total energy of electron is potential energy by 2 లేదా negative of kinetic energy. Finished. You are understanding? Sir. Okay. Yes. No. Kinetic energy is not minus. Kinetic energy is plus only. Half mv square kada. So independently it's positive. Kani relation చూసి it's negative with respect to your potential energy. అర్థమైంది? సరే. So ఇప్పుడు try to understand, okay? It's negative. Your total energy is negative. I am writing this statement. గుర్తుపెట్టుకోండి. Your total energy of electron is negative. అర్థమైంది? Yes. So what is negative, sir? Negative unte the things change. Ante entira? Your 5 is greater than 3. Kani minus 5 is less than minus 3. You are understanding? So this rule will be applied. High energy, low energy will be reversed in your negative side. ఇప్పుడు చెప్పండి. So what is total energy ra? Minus kinetic energy kada. Kinetic energy formula ఏంటి sir? Hey, ఇదే. You are understanding? Sir. So sir, your total energy ante your total energy, sir, E total is equals to 1/8 into చెప్పండి mz e to the power 4 divided by n square h square epsilon naught square. ఇదే కదా? Am I correct? Correct. చూసుకోండి. mz square e to the power 4 by n square h square epsilon naught square. ఇదే. Now if you want you can do some simplifications రా. చూసుకోండి. నెగటివ్ కదా? నెగటివ్ సైన్ కూడా గుర్తుపెట్టుకోండి. సార్ మాస్ అంటే మాస్ ఆఫ్ ఎలక్ట్రాన్ m e is to the power 4 constant quantities. I'm separating ra. N ante number of shell. It's not constant. Shell change chesi your n also changes. H square Planck's constant. Epsilon naught square. Idi kuda constant. Ide kada? Yes. Multiplied by cheppandi. What is the remaining, sir? You are remaining the values ante z square upon n square. Ide kada? Yes. Sir, minus 1/8 into mass of electron 9.1 10 to the power minus 31 e to the power 4, sir, 1.6 10 to the power minus 19 to the power 4, sir, divided by h square 6.6 into 10 to the power minus 34 whole square multiplied by epsilon naught square, sir, 8.85 into 10 to the power minus 12 whole square multiplied by z square upon n square. Idigo ee mottam quantity when they calculated, not as scientists did it, okay? They did it. They got this value is something else, minus 13.6 idigo into z square upon n square. And this is the total energy of electron rotating in the nth shell. Correct. Okay, sir. So this is the energy unit kuda gutpeట్టుకోండి. This is electron volt, okay? Electron volt. What is the relationship between electron volt and joule, sir? You must be good at it. You are understanding? Yes, you must be good at it. Your relationship between electron volt and joule. Anyways, what I was telling? Okay. So ఇప్పుడు let us talk something about your excitation and de-excitation of electrons andariki. Okay? Sorry. So now 23, right? Good. Hey, like the video, all of you. 23 students and only 30 likes. This does not matter, right? Yeah, it's a shameful act for me. You know? Choose. So there are some more terminologies, all of you. I want you to remember, okay? I want all of you to remember these values only, okay? Choose. Sorry. We'll do it. Don't worry. Choose. I want all of you to remember the relationship. Relationship. Choose. So this is a table of a relation of some quantities. You can derive it, okay? But I don't want to derive it. So I have made a list. I have made a list. So I'm just directly writing that list. With n and z. This is the list. I want all of you to remember it. Okay? So let us say this is your quantity. Okay. and this is directly proportional to ఇదే కదా yes. Let us make a table now. Hey, this is only for your exam purpose, okay? So good peట్టుకోండి to save the time and to save the. Hey, you gotta remember the stuff in biology. What is this for you, Ram? It's a piece of cake, kada. First thing, right? I'll not include in the table అందరికి చూడండి. Radius of orbit kada. Radius. చెప్పండి. Your radius is directly proportional to n square upon z. ఇదే కదా. Your speed రా చెప్పండి. Speed is directly proportional to z upon n. Energy చెప్పండి sir. It is directly proportional to z square upon n square. These are the three values we have seen. Okay, we have seen. ఇదే కదా. Yes, we have seen it. Anyways, sir, so let us talk something about angular frequency లేదా angular speed omega ఇదిగో frequency, then time period. Okay, time period directly proportional to n cube upon z square. Okay, your frequency directly proportional to z square upon n cube. Okay, your speed directly proportional to z square upon n cube. Same ra, okay, same. Next, current I kada. Yes, hey, charge is flowing, electron moving ra. Electron moving ante electron flowing ante charge is flowing ante current. You understand? Sorry, your current is directly proportional to z square upon n cube. ఇదిగో same. మ్యాగ్నెటిక్ మూమెంట్ ఇదిగో మ్యాగ్నెటిక్ మూమెంట్ తీసుకోండి. మ్యాగ్నెటిక్ మూమెంట్ గుర్తుందా సార్? యువర్ మ్యాగ్నెటిజం లో వి టాక్ సంథింగ్ అబౌట్ యువర్ మ్యాగ్నెటిక్ మూమెంట్ అండ్ you take formula only ra. Your magnetic moment is four pi m. You want to remember? I can't prove it. Okay, I don't have to remember all this ra. I can do the calculation, I can prove these things, but I want you to remember it. Choose one. So when it comes to magnetic moment andariki, I want to tell you one more thing. Okay, magnetic moment. How many quantities we discussed, right? 1, 2, 3, 4, 5 kada? Yes, 5. And those 3 also, under total 8 quantities. Total 8 quantities are there, okay? So magnetic moment is ENH divided by 4 pi m. If your n equals to 1, you are understanding? If your n equals to 1, ante first stereo, minimum, lowest. Ante lowest value of your magnetic moment andariki. It is the lowest value for your magnetic moment. It is written as E into H upon 4 pi m. This is known as one Bohr magneton, BM. In your complex compounds, are you understanding? You have to calculate the magnetic moments kada. Formula is there. BM, Bohr magneton. Ante this is known as one Bohr, smallest quantity in your magnetic moment. Ante ide. Understanding? Sorry. If you understood this, let us go towards the excitation and de-excitation of electron. And it's the last topic, all of you. Okay? Let us talk about your excitation and de-excitation of electron. Andariki chudandi. No problem. It's completely all right. Okay? Even if you finish it in 1 hour, 5:30, everything is going with the plan. Sorry. So let us talk something about excitation and de-excitation of electron. Hey, before that, hey, before that, I'm forgetting something. Okay, I'm forgetting something. Choose one. Energy formula cheppandi andariki. So your energy is equals to minus 13.6 into z square upon s. It is the total energy andariki. Ardhamaindi total energy. If I put z equals to 1, ante endira, the atom is hydrogen. Ide kada? Substitute. Sir, E1 లేదా En కదా, En రా, En formula equals to minus 13.6 divided by n square. Point number 1 అందరికి. If your n equals to 1 అంటే first shell కదా, చెప్పండి రా, energy of first shell sir E1 is equals to minus 13.6 divided by 1 square అంటే minus 13.6 electron volt. ఇదిగో. So this is your first energy value రా. ఇప్పుడు చెప్పండి, what about the second energy sir? Number 2 అంటే n equals to 2 రా, అంటే your second energy becomes minus 13.6 divided by 4. I want all of you to remember the values. Okay, ఇది చాలా చాలా ఇంపార్టెంట్ అందరికి. సరే, the value comes out directly as E2 is equals to minus 3.4 electron volts. ఇదిగో, you are understanding? Third అంటే n equals to 3 రా, your energy E3 is equals to minus 13.6 divided by n square kada, n square అంటే 3 square అంటే minus 13.6 divided by 9. The value simply comes out E3 is equals to minus 1.51 electron volt. ఇదిగో. And lastly, am I correct? Yes, right. And lastly, your n equals to 4 అంటే your fourth shell, your energy 4 comes out as minus 13.6 divided by 4 square అంటే minus 13.6 divided by 16. ఇది కూడా గుర్తుండాలిరా. E4 is equals to minus 0.85 electron volt. Remember the values, okay? Remember. ఎందుకంటే these will save tremendous amount of time. All of you try to understand, okay? These are very important values, very important values. Try to understand రా. Also one more thing అందరికి చూడండి. How we represent is, try to understand, okay? We represent the shells లేదా the energy levels on y-axis. అందరికి చూడండి. అంటే if this is your y-axis, if this is your x-axis, try to visualize, okay? X is equals to 0 and your energy value is 0. ఇదే కదా? Yes. Try to understand. Hey, not 0, right? Should not be 0. I'll not say y and x-axis. Okay, the first shell అంటే this is your nucleus అందరికి. ఇదే మీ nucleus కదా. Let us say this is your first shell రా. First shell. Energy చెప్పండి. Your energy is equals to minus 13.6 electron volt. ఇదిగో. లేదా let us take one more case. Your E1 value for hydrogen రాస్తున్నాం అందరికి చూడండి. Your E1 is minus 13.6 electron volts. చెప్పండి, your E2 value రా, it is minus 3.4 electron volt. E3 value చెప్పండి సార్. E3 value is minus 1.51 electron volt. E4 value చెప్పండి. E4 value minus 0.85 electron volt. I want gaps రా. చెప్పండి, what is the difference? What is the difference sir? 10.2 electron volt. ఇదే కదా. Hey, try to do it రా. How will you calculate the energy difference రా? Hey, all of you, these are the very crucial things, okay? You skip it, you ignore it, and these will compulsorily encounter you in the exam. Try to understand. చూడండి. So your change in energy అంటే delta E అంటే EF రా minus EI అంటే minus 3.4 negative of minus 13.6. ఇదే కదా? Yes. So that comes out as 10.2 electron volt. ఇదిగో. Value చూడండి. Values. Correct. What about the second case రా? మీ second case లో చెప్పండి. What is it going to be? చెప్పండి. Your delta E is equals to E2 minus E1 అంటే minus 1.51 minus of 3.4 electron volt. Can you tell me? Hey, I think it is somewhere around 1.89, okay? Electron volt. Correct? Not correct. Sorry, 1.89 electron volts ra. Next, చెప్పండి, your delta E value ra. Your delta E is nothing but E2 minus E1 అంటే minus 0.85 minus of minus 1.51. ఇదే కదా? Yes. You are not seeing it all ra. .66 electron volts. ఇదే కదా? సరే. Now I want you to see the gap, right? It is gap kada, gap ఉంటుంది కదా, చూసుకో. Your E1 and E2, the gap between E1 and E2 is 10.2, very high, chala high. But when you see the gap between E2 and E3, it is very less and it is decreasing ra. You're understanding? Ante gap is decreasing, that means your energy is here, your gap will be high for first and second kada, so your E2 value will be somewhere here. Andariki చూడండి, ఇదే మీ E2 value ra, minus 3.4 electron volt for a hydrogen atom. Okay, now the gap decreasing అంటే the line will be very close, so something like this. చూసుకోండి, the gap ra, gap గుర్తుపెట్టుకోండి. This is your E3 value. అందరికి E3 value is minus 1.51 electron volt, ఇదే కదా. And lastly again the gap is decreasing, చూసుకోండి. So that means this is your gap ra, ఇదిగో, this is delta E1, this gap is delta E2, this gap is delta E3. As you go up, the gap decreases. You are understanding? The gap keeps on decreasing ante something like this. Hey, not like this ra. Visualizing. Keeps on decreasing. Okay, so the gap keeps on decreasing. Now let us talk about excitation and de-excitation of electron. Andariki జాగ్రత్తగా వినండి. Now first let us talk about excitation. ఇదిగో, అంటే ఏంటిరా, you have a general atom. అందరికి, this is the nucleus of the general atom. n equals to 1, ఇదే n equals to 2, n equals to 3 and so on so forth. You are understanding? And so on so forth. These are the shells. Shells ante imaginary energy levels ra. You are understanding? Imaginary energy levels are. Now what you do is you take a general shell. General shell ante enti ra? Let us say this value is n1. Andari n1 nunchi I am going to excite the electron to n2 level. Okay, చూడండి, n2 level ante it has risen up from low energy to high energy. ఇదే కదా? Yes, you are understanding? Yes, sorry. So your electron has been risen from your low energy to high energy. Can you tell me the energy difference, sir? ఈ n1 shell లో your energy E1 చెప్పండి అందరికి. Your energy E1 was minus 13.6 into z square upon n1 square. ఇదే కదా? Yes, very good. Try to understand ra. Okay, what about the second shell andariki? Your second shell E2 is minus 13.6 into z square upon n2 square. Idigo, what do I want ra? Hey, let me focus re. What are you doing in the chat section? Hey, anyways ra, you try, tell me your change in energy delta E ante enti ra? It is E2 minus E1 kada? Yes, E2 minus E1 ante enti ra? This is your E2. Sir, hey, this is very important discussion. Okay, I want all of you to understand. So see, so this is minus 13.6 into z square upon n2 square andariki minus of again minus sign వచ్చింది కదా. E1 value చెప్పండి ఒకసారి. E1 is again negative 13.6 into z square upon n1 square. ఇప్పుడు what to do, sir? You take some common అంటే ఏంటిరా? See, this negative becomes positive. Point number 1. ఇదే కదా? Yes. So, you'll simply say, sir, your delta E value is, చూసుకోండి. First, I'll say this minus becomes plus. Plus kada? Yes. So, I'll write plus first. So, 13.6 Z square upon N1 square. ఇదిగో. N1 square. Positive ఉంది కదా? So, your remaining is this. So, you'll simply say negative of 13.6 into Z square divided by N2 square. What you do now? Take 13.6 Z square common run. What you are left with? 1 upon N1 square minus 1 upon N2 square. This is your change in energy. Ante endira? That means, it simply means, andariki, jagrataga virandi. That simply means, you need this much amount of energy andariki to excite leda de-excite. Try to understand. You're understanding? Sir. Now, the same energy, delta ide kada? Yes. So, if the electron is exciting, if the electron is exciting from N1, idigo, N1 ante lower shell ra, N1 ante lower shell kada? Yes. To N2, N2 ante enti ra? N2 ante your higher shell. Delta E ante this much ra. Delta E energy is required. Ade అర్థమైంది అందరికీ. You need this much amount of energy. You need this much amount of energy to excite the electron. ఇప్పుడు if you want to understand this, ra, how should I tell? Yes. Understand. There are two methods only. Andariki jagrataga vinandi. Number one, method number 1 is by photon, okay? By photon projection. I'll say photon projection. Ade. And the second method you have is your particle collision. In your photon projection, what do you do is, చూసుకోండి అందరికి, this is your nucleus, this is your N1 shell, okay? N1 shell, N1 అంటే this is your electron. అందరికి జాగ్రత్తగా వినండి. So what you are doing, this is your N2 shell అంటే higher shell కదా? Yes. For example, this is first shell for hydrogen. ఇదిగో first shell for hydrogen కదా? And this is second shell for hydrogen. Difference చెప్పండి అందరికి. What is the difference between your first? Yes. Just a minute. What is the difference between your first shell and second shell, ra? 10.2 electron volt. Gurtunda andariki? Gurtunda? This is the energy difference. Ippudu chudandi. The biggest property that I want to write over here is, చూసుకోండి అందరికి a photon ఇదే కదా? Photon can not be broken, ra. You cannot break a photon. Ante if the photon is having, చూసుకోండి, if the photon is having 12 joule of energy, ఇదే కదా? Yes. So what you are doing is, you are throwing a photon on it. ఇదిగో, you are throwing a photon on it. This is your photon. What it will do? It will give the energy. అదే, only energy imparting is the work. Photon kada? Yes. So what it will do, ra? It will simply give the energy to the electron. But there is a condition. Condition ఏంటి, sir? If the energy is 12 joules, ఇదిగో. If the energy, how many required? ఎంత energy required? 10.2 is required కదా? ఇది కావాలి. How much is there? 12 joule is there. So మరి ఏం చేయాలి ఇప్పుడు, sir? Is it that the electron only absorbs the 10.2 and remaining? No. Photon cannot be broken. You are understanding? Photon cannot be broken. Ante you cannot take half energy and half leave it. Nothing like that. Ante ee case lo, if you are throwing the photon whose energy is 12 joules, hey, energy 12 joules kada? Kani how much required, ra? You only need 10.2 electron volt of energy. How much is there? 12. It will not accept. You are understanding? Ante this electron, it will not accept this photon at all. You are understanding? Ante this photon will be rejected. Idigo. Why, sir? Because 12 joule is there. You cannot cut it. You cannot cut it and take 10.2, ra. You are understanding? What will happen, ra? Then you need another one. another one ante your electron leda your energy should be equals to 10.2 electron volts. Idigo. So if you have a photon of that energy, then and only then it will absorb and jump to the higher shells. Idigo. This is the basic property. But what about particle collisions? In your particle collisions, చూసుకోండి. Last theory we'll discuss and then we will go to the calculation. Okay? In your particle collision, ide na n1 level, this is my n2 level kada. Yes, so this is my n1 level, this is my n2 level. Andariki. What will happen now? So we take another electron. Okay? We take another electron and we hit it. Hit it. Collision kada. Collision. Due to this collision, the energy is received. Due to this collision, energy is received. Okay? This energy will be transferring the electron to the higher level. Choose finished. Okay? Now let us talk something about your spectral series. Andariki. Leda, you take this same quantity. Now I'm talking about de-excitation. Okay? Andariki. Chudandi. If it is a de-excitation of electron, me de-excitation low, your electron jumps from higher level to lower level. Andariki. Electron jumps from higher level to lower level. Kada? Yes. So it is your higher level. Let us say N2. Always remember. N2 ante higher level. What is N1, sir? N1 ante lower level. N1 kada? Yes. So electron is there in higher level. It wants to come to lower. It cannot come. Why, sir? Because it has energy. You understand? It has energy. So what it will do? It will release the energy. Ade, you are understanding? It will release the energy in the form of electromagnetic waves, leda photons. Okay? It will emit, leda it will release the energy in form of photons. How much energy, sir? For example, చూసుకోండి మీ హైడ్రోజన్ ఆటమ్ కోసం -13.6 minus 3.4 kada n2 value ra electron volt, n1 చెప్పండి -13.6 ఇదే కదా. yes, how much energy it will release అంటే difference అదే కదా. yes, so energy of released photon ra, energy of released photon is equals to చెప్పండి change in the energy levels. ఇదే కదా. yes, change in the energy level. Change in the energy level ante entira E2 minus E1. Idigo. You understand? We did all the calculations. I'm directly writing the formula. Choose. So this is 13.6 into z square. Z square into 1 upon n1 square minus 1 upon n2 square. Ide kada. Energy of photon ante entira. Photon ante, sir, it's the EM wave ra. Light ante your light has wavelength, sir. That means energy should be equals to hc by lambda ra. Idigo ante your hc will go that side ra, and you are left with 1 upon lambda is equals to 13.6 into z square divided by h into c, 1 upon n1 square minus 1 upon n2 square. Ide kada. yes, ఈ మొత్తం క్వాంటిటీని to this entire quantity 13.6 upon hc, I call it as r అంటే Rydberg's constant. అందరికి చూడండి ఇదే కదా. yes, I call it equals to r అంటే ఏంటిరా? r is the Rydberg's constant. sir, so you will simply say that your 1 upon lambda should be equals to r into z square multiplied by 1 upon n1 square and 2 square. What is r, sir? R ante Rydberg's constant ra. You are understanding? R ante enti, sir? R ante Rydberg's constant. Value enti ra? Value enti? See, strictly speaking, you don't have to remember the value of r. It's a complicated value also. You don't need it. Mari, you need 1 upon r value. Oh, 1 upon r value good petkondi. That is 911 angstrom. Idigo. Hey, kavalante raskondi ra. The Rydberg value is 109677. Hey, ide kada. You can take it that also. If you want to do it, do it. You don't want to do it, keep it, whatever you want. But this is the important value I want you to understand. Okay, student. Now. Let us talk something about your spectral series. Okay, spectral series. Here you go. This is the last topic and then we will be finishing. Okay, we will take a break. And your chapter is completed. Atoms chapter is completed. Okay, sorry. 4:59 and 5. Am I forgetting something, Ra? I don't want to teach extra, okay? Kabatti. Sir, so there are some things, okay, that I want to teach. Andari, student. Spectral series ante entira. Your electron is there at different energy level. Ante this is N1. Let us ide. This is your N2. Hey, this is your N3. Gap chudandi. Gap. Decreasing kada? Yes. So let us say this is your N4th, or let us say, let me do it properly, systematically. Choose. Let us say this is your N1 value, ra. Rather, I should just draw a line. N1. Okay, right. Next is your N2 value. Ra, idigo. I want to keep decreasing the gaps. Okay, the N3 value. Then you have your N4 value. Then you have your N5 value. Okay, try to understand all of you. Okay? And then you have N6 value. And then you have N7 value. There you go. And so on and so forth. Gap should be decreasing. Okay, gap good. Sorry. So let me write it quickly. Andariki. So this is my N1 shell, ante first shell, N2, N3, N4, N5, N6 and N7. Ide kada? Yes, student. Eppudu if your electron is in higher state ante 2, 3, 4, 5, 6. They gone cross. I know. Okay, I know. Yes. Student, ultimately at the end of the day, electron, when you are exciting it, it's in higher state, it's not happy. All these things are going in Bohr's model only. Okay, you're understanding? In Bohr's model only, student. So electron is not happy in the upper state. So what it will do, it will directly come from upper to lower. It will directly come from upper to lower. Choose code. If it's 7, directly from 7 to 1. Directly from 6th to 1th. Ledante directly from 5th to 1th. Okay. 7, n equals to 8. Okay, 8 shells are. 1, 2, 3, 4, 5, 6, 7. 7, yes, sorry. Then directly 4th to 1th, or 3rd to 1th, or 2nd to 1th. All these lines, final destination cheppandi, N1 kada, 1. Final destination ante 1. Ee series ni you call it as Lyman series. Andariki. Ide kada? Yes. You call it as Lyman series. Dan tarvata, next, if your electron is directly jumping on second level, like this, student, 1, or from here, or from here, or from here, or from here, you will say Balmer series. Okay, if it is jumping into third series under this one, right? Here, Leda. In this case, 3, 4. Fashion series. What is this, sir? We see the transition, right? The electron directly jumps from 7th to 3rd one. There you go, 7th to 3rd. Whatever wavelength you got, you got a wavelength. Our wavelength we will classify into partial series. And it has directly jumped from to 3rd. Lyman, Balmer, partial. What is 4th one, Ra? Hey, Chappandi andariki. 4th one ante from n equals to n to n equals to 4. Ide kada? Yes. దాని తర్వాత yes, there is ionization also. There is ionization also అందరికి. And you remember the names, okay? Remaining names. 5 కోసం you will simply say that it is P-Font series. And 6 కోసం it is Humphrey series, okay? ఎందుకు సరే now చూడండి. Ionization energy అంటే ఏంటిరా? If this is your nucleus, this is your electron moving in nth shell కదా, moving in nth shell. What will happen, sir? What will happen ante this electron will leave the atom forever ante n equals to infinity. It tends to n as infinity. Okay, you say this is going to infinity, n tending to infinity. ఇదిగో ఎనర్జీ వాల్యూ చెప్పండి సార్. ఎనర్జీ is minus 13 point లేదా r z square కదా. You remember the values? Yes sir, r into z square లేదా you do whatever you want to do ra, minus 13.6 into z square into 1 upon n1 square minus 1 upon n2 square. Remember, always remember ఈ ఫార్ములాలో n1 అంటే always your lower orbit రా, and n2 అంటే always your higher orbit. కానీ ionization కోసం చెప్పండి, for your ionization కోసం n2 should be infinity కదా. Yes, so sir, your ionization energy minus 13.6 z square into 1 upon n1 square, 1 upon infinity, it is 0 ra, gone. So it is minus 13.6 to z square, not minus, plus, it should be plus kada. Yes, plus 13. I'm sorry. It should be 1 upon n square ra. N square and enti the current shell number. Idigo, this is your ionization energy. You are understanding, sir? So this was all about this session andariki. So let us take a break. Okay, sir. Hey, before that, I don't know if it has been added or not, but I had this PYQs andariki. I had the PDF of PYQs. I was thinking like to take a mock test. ఈ PYQs లో there are all last year NEET examinations. చూసుకోండి. ఇదిగో, these are your exams, okay? Some energy levels of molecule are given with their wavelengths. Then something like this. This was the option. Okay, if possible, I will make you available by the end of this session, andariki. Okay, it's there with me only, but I don't know how will you be accessing it, ra. Okay. Anyways, let us see after break. Okay, sir. So let us take a break now. You know. Your chapter is completed, okay? Your atoms chapter has been completed. Yes, friction mock test is pinned, but I will tell them to pin the PDF also. Mostly. Sir, we'll meet at 5:40, okay, everybody? Yes. Bharat Mata ki jai. Bye-bye. What a timing, sir. Correct time కదా. Sir. Hi. Good evening. Good. Energy level 100%. Good. అదే కావాలి ఈ లెక్చర్స్ కోసమే. యువర్ ఎనర్జీ అంటే చాలా హై ఉండాలి. నెక్స్ట్ నౌ ఐ వాంట్ యువర్ ఒపీనియన్ రా. ఏం చేయాలి? షాల్ వి డిస్కస్ PYQ? If you are spamming again, okay, I will block you. I can't see the messages of the students, huh? Don't spam, I'm telling you, don't spam. Yes. So what do you want me to do, Ra? PYQs are leda. Let us proceed to the further discussion. It's all up to you. You tell me, I'll do that. If you tell me to take PYQs, we'll jump to PYQs. If you tell me to take the next topic, we'll take next topic. Next topic ante majorly your PYQs. Hi. PYQ. Okay. PYQs. Sorry. Can you read it, Ra? Can you read it? Is it visible andariki? Just read the question. A particle of mass m moving around the origin with a constant force F pulling towards the origin. Ide kada? Bohr's model is used to describe the motion, radius of nth orbit and speed v in the orbit depends on n as dash. Okay. Read it, okay? Read it. Do you need options? I don't think you need the options. Can you just read the question, okay? M particle moving with speed v, ade kada? Force, what do you want, Ra? Describe radius and speed as a function of n. Ide kada? Yes. Radius and speed as a function of n. Chuskondi andariki. So this is my particle, Ra. Ide kada? Yes. This is my particle. Andariki chudandi. This is your particle. Ide kada? Yes. Centripetal force F is there, Ra. Point number 1. F ante enti sir? Your F is equals to mass into V square upon R. Point number 1. Ide kada? Centripetal force, Ra. Bohr's model applied. Bohr's model applied into enti sir? Your MVR should be equals to NaH upon 2 pi. Ide kada? Just a minute. I was planning, I was trying to do something. What I was going to do. Hey, we will not take semiconductors, okay? Sorry. No, why the energy levels are dropping, drastically dropping. Just continue. Okay, sorry. What is the difference between your normal question? Andariki chudandi. Where 25 NEET 2025 కదా అంటే క్వశ్చన్ ఇస్ డిఫికల్ట్ ఫర్ షూర్, నాట్ డిఫికల్ట్, ఐ వుడ్ నాట్ సే డిఫికల్ట్ ఫర్ యూ, మీ అందరి కోసం ద క్వశ్చన్ ఇస్ డిఫికల్ట్, ట్రై టు అండర్స్టాండ్. ఇన్ అవర్ రెగ్యులర్ కన్వెన్షన్ రా చూసుకోండి, రెగ్యులర్ కన్వెన్షన్ అంటే ఏంటి సార్, వెన్ వీఆర్ డిస్కసింగ్ అబౌట్ అవర్ బోర్స్ మోడల్, సో దాట్ ఫోర్స్ చూసుకోండి ఇన్ దిస్ క్వశ్చన్ కెన్ యూ రీడ్ దిస్ టర్మినాలజీ రా, వేర్ ఇస్ ఇట్ రా, వేర్ ఇస్ ఇట్, ఎస్ చూసుకోండి, విత్ అ constant force F. This is the biggest change that you had to see it ra చూసుకోండి around the origin with a constant force F, constant కానీ in this case చూడండి your force constant అంటే ఏంటి సార్, mass of electron constant కదా, that means your speed square upon radius is also constant ra చూసుకో, you are understanding. That means your v square upon r should be equals to some constant k. ఇక్కడ నుంచి your v square is equals to k into r ఇదే కదా, that means your v square is directly proportional to r. Oh my goodness, you are understanding, you are understanding, right? Now you take this formula andariki, what can you say sir, ee formula nunchi we can simply say, hey, what you can see? Yes. So your v square is directly proportional to r kada, ante v square is equals to k into r. Ippudu em cheyali sir? Sir, this k into r లేదా can I simply say sir r is equals to v square upon k, చూడండి put it, so you will get sir m into v into r is r kada, r is nothing but v square upon k should be equals to nh over 2 pi. ఇదిగో that's why I've told you that the derivations ante the proofs is disturbing a lot, is disturbing me a lot. Anyways, so m into v cube divided by k is equals to nh over 2 pi idigo andariki, that means constant, that means your v cube is directly proportional to n, ante your speed is directly proportional to n to the power 1 by 3 idigo ఇదే కదా. what about r sir, what about r, your r square, your r is directly proportional to v square, okay, v square kada, yes, v square ante n to the power 1 by 3 whole square ra idigo, that means your r is directly proportional to n to the power 1 by 3 andariki, n to the power 1 by 3 whole square, ante your r is directly proportional to n to the power 2 by 3. Finished. Are these the options? చూడండి ఒక్కసారి options. What are your options రా? Your r is directly proportional to n to the power 2 by 3, v directly proportional to n to the power 1 by 3. ఇదే కదా? Yes. చూసుకోండి. This is your answer. Okay. Next question అందరికి. Your question number 2. It's a simple question ra, 2024 kada, spectral line series corresponding to 5 6 7 8 to n equals to 4 ra, Lyman, Balmer, Paschen, bracket pair gurtundali ade bracket series ra, is it the option b చూసుకోండి, your option is b ఇదే కదా. Last next, hey, it's not the useful question అందరికి. Yes, I think this is a good question. Hey, can you read it? Can you read the question? Andariki, can you read the question? Some energy levels of a molecule are shown. The wavelength of transitions are these ra. Idigo. Minus 4e, minus 3e, minus 5 by 2e, minus 2e. Ide kada, these are the energy levels. Particle jumping from minus 2e to minus 4e. Minus 2e to minus 3e. And minus 5 by 2e to minus 4e. Ade. I want to talk about the wavelengths. Give me 5 minutes, okay? I will try blocking this guy. Just a minute. Sorry. Let us discuss. Okay, Andari. Yes. So, hey, you have the electron at minus 4e level, minus 3e, minus 5 by 2e, and minus 2e. We'll just solve 5 questions. What is the question number? 4. We'll solve more 2 and then we'll move towards the next topic. Choose koni andariki. So, this is your energy levels. Yes. Question please. No, he will be blocked. He will be blocked. Okay. Sorry. Got it. Got it. Anyways. So these are the energy levels, right? Minus 4e. Okay. Dan tarvata you have something known as minus 3e. And then you have something known as minus 5 by 20, 2.5 kada? Yes. And then you have something known as minus 2e. Nikhil, Ray, koncham punch cheyira. You're understanding? You have your exam in 90 days. 90 days, no, your exam is there. You are doing all these things. Sir. So, yes. Okay. Hey, everybody. You leave the chat box, okay? You leave it. You leave it. For now, you leave it. No wonder. You will be getting it. Hey, choose Kondira. Let us discuss and I have to finish the syllabus. What is the time? It's 5:54. Okay, 5:54. Anyways. Yes. So, wavelength student yokasari. This wavelength is lambda 3, lambda 2, lambda 1 kada. Lambda 1, lambda 2, lambda 3 andariki. Is it correct? Is it correct? Is it correct? And this is your lambda 1. All of you. What about lambda 2? This is your lambda 2. And what about lambda 3, sir? This is your lambda 3. Energy ante enti ra? Energy is hc by lambda. Chudandi. Leda, you will simply say, sir, delta E should be equals to hc upon lambda kada. That means your delta E is inversely proportional to lambda. You understand? So, for every single lambda, calculate delta E ra. For lambda 1, ante lambda 1 kosam delta E value cheppandi sir. Delta E1 ante EF minus EI. EF minus EI kada? Yes, cheppandi. What is EF value ra? What is EF value andariki? What is EF value? Okay. We will take this question and then not nuclei. Nuclei will be the end topic. End ante we will discuss it in the last. It requires some knowledge. We will start dual nature of matter after this. Okay. Then we will go to nuclei. Just good. So delta E1 and change in the energy level first. What is delta E1 value, sir? Your minus 2.5 E, negative of minus 4 E. What I can take nuclei also, but okay. So you will simply say 1.5 E. Andari. This is your delta E1. Eppudu cheppandi delta E2 gurinchi cheppandi okasari. Your delta E2 is minus 2E minus E. Ide kada? Ante should be something like this. Student, minus E minus of minus 2E. Ide kada? Yes. So it comes out to be simply E ra. What about last option? Third option, student. So your delta E3 value cheppandi andariki. Delta E3 is equals to final minus initial kada? Yes. So minus 2E minus of minus 4E. You understanding? So you will simply say that your E3 greater than E2 greater than E1. అంటే రివర్స్ చేసుకోండి. lambda 3 less than lambda 2 less than lambda 1. Finished. Hey. No. E3 is greater than E1 రా. ఇదిగో. And it is greater than E2 కదా. Yes. రివర్స్ చేసుకోండి. అంటే lambda 3 less than lambda 1 less than lambda 2. Whatever the options. Okay. Sorry. No. E2 is how? E2 అంటే this కదా. So minus 2E minus of minus 3E. Minus 2E minus 3E. E2 అంటే this. ఎక్కడి నుంచి ఎక్కడి వరకు కదా. So it should be minus 2E minus of minus 3. అంటే గ్యాప్ చూసుకోండి. Gap is simply equals to E. E2 is E. Here also gap is 2E. Here the gap is 1.5E. Right. Next. Sorry. Let us jump to the next topic now. Andariki. I think we are good to go, right? We are good to go, right? Sir. Now let us move to the next topic. And it will not end. Even if I give you 10-20 hours, the questions will not end. They will keep on coming and coming. Okay. So student, the title of the next chapter is dual nature of matter. Yes. So now I want all to understand and answer my questions. Okay, I want all to understand and answer my questions. Just you imagine, sir. The Bohr's model was working very fine, okay? The Bohr's model was working very fine until he got Nobel Prize. Last chapter that we've seen. Okay, let me continue the story. He got the Nobel Prize. There came two scientists. Okay, two scientists. Number one, choose code. Heisenberg. Hey, you remember the name Heisenberg? And everywhere Bohr was, considered as the biggest scientist. Hey, he has invented a lot of things, right? He gave us the energy equations, the transitions, the velocity of electrons, kinetic energy of electron, the radius of nth orbit, momentum of electron. He gave everything. Current due to the electron, magnetic moment, and all these things, you are understanding? Ante Bohr the Great. So Bohr was like, hey, I am the boss of this modern physics. Nobody comes in front of me. These two guys, they came. Okay, they came. First one, Heisenberg. He broke half. Okay, and this one, he broke the remaining half. You are understanding? Ante, I'm not considered about this Heisenberg. Okay, we are not talking about Heisenberg principle. Sir, de Broglie. What he said? He said that, hey, Bohr, listen to me. Bohr, Mr. Bohr, you are assuming electron as point mass. It's not mass. You are understanding? Electron is not point. Electron is not a particle. He said that You are thinking electron is like this. This basic understanding itself is wrong. Ante the base itself is wrong. Mari enti sir, he said that your electron is a wave ra. Idigo wave. So if it's a wave ante telusa kada, this is a wave ra. Your understanding, if it's going in a straight line, looks like this. Going in a circle ante looks like this kada. Try to understand, all of you. He said that electron is a wave itself. Oh my goodness, you're understanding. So that was complete shattering of your Bohr's model. Ante that's wrong. You're understanding. Your entire Bohr's model does not work. Then we need new theories, but that is the topic of your atomic structure chapter. So we are parting our ways. We are going on a different way. The chapter goes on a different way. Your atomic structure, okay? There you talk something about your Schrodinger wave equation, quantum numbers and all these things. Sorry. So you imagine, okay? Let us start our discussion from a fresh topic. Let us say this is your source of light, point source. Now I want all of you to remember the formulas. This is a point source of light. Yes. This is a point source of light. Can you tell me, all of you, can any one of you tell me what will be the number of, not say number of, yes. So if it's a point source of light, andariki cheppandi. Okay, try to understand. Okay, try to understand. What is it doing, ra? Emitting photons. Ide kada? Emitting photons, andariki. It is emitting photons, ra. Idigo. Emitting photons. All of you, try to understand. Try to understand. The power of light source. Idigo. Your power of light source, let us say the power is equals to P. Ide kada? Your power of light source is P. Point number 1. Ante power of this bulb, 10 watt, 20 watt, 30 watt, something like this. Chudandi. Let us say the energy kada? Yes. Energy of a photon. Cheppedi, what can you say about energy andariki? Energy is equals to hc by lambda. Ante h mu kada? H mu leda hc by lambda is the energy. Now let's talk about 1 second. Time is equals to 1 second. Ante enti ra? Ante in 1 second of interval. Cheppandi andariki. 1 second lo, can I simply say power is equals to energy upon time ra? You're understanding? You're understanding? Right. But this is valid for only single photon ra. Single photon. Cheppandi. If there are n photons andariki. Hey. There are n photons. For n photons, power is P ra. Ide kada? Light source. Chuskondi. Power of light source ante power of n photons that are coming out of it. Yes. Yes. I think the PYQs, hey, all of you, it has been attached, okay? Please check the pinned comment, andariki. Please check the pinned comment, okay? So the links have been attached. Links ante for your mock tests, ra. For your mock tests, the links are attached. So go and watch, okay? Yes, sorry. So for n number of photons that are emitting, total power entara? Total power is P. Ante for n photons, idigo, for n photons, cheppandi, for n photons, your power equals to P. Ide kada? That means what, sir? Sir, n multiplied by power of 1 photon is equals to P. Idigo. Time enta, sir? 1 second kada? 1 second. Cheppandi. N multiplied by power ante enti, sir? Energy upon time. Energy of photon, hc upon lambda. Time enta na? 1 second should be equals to P. Can you find the value of n ra? Yes, you can. Sir, your n value should be equals to P into lambda divided by hc. Idigo. So this is your number of photons emitted per second from the light bulb. Formula gurtupettukondi. This formula is important. Andariki. Okay. What error? The links are having error, right? Okay, it will be resolved. Okay, focus here. It will be resolved. Andariki. So number of photons of wavelength lambda and is given. C అంటే ఏంటి? స్పీడ్ ఆఫ్ లైట్ కదా. ఇది ఒక క్వశ్చన్ తీసుకోండి అందరికి. తీసుకోండి. Getting it? Not getting it, Ra? Try it, all of you. I want all of you to attempt these questions, okay? I hope it is understandable, Ra. Let us see. Formulas cheppandi. I am telling you again and again. Remember the formulas, Ra. So, number of చూసుకోండి ఎందరికి. ఇదే కదా. పవర్ ఎంత సార్? 100. లాంబ్డా వాల్యూ చెప్పండి. 2 నానోమీటర్ అంటే 2 × 10⁻⁹ meters డివైడెడ్ బై హెచ్ వాల్యూ. into speed. ఇదే కదా సరే రైట్ సార్ -34 plus 8 -26 -26 becomes +26 ra, so it is 100 into 2 into 10 to the power -9 into 10 to the power 26 divided by 6.6 into 3 ఇదే కదా yes. So -9 plus 26 అంటే 17 అంటే 10 to the power 17 multiplied by 200 divided by approximate values తీసుకోండి ఓకే 19.6 అంటే approximate 20 కదా 20 approximately 20 it should not be approximate actually you do it approximately okay 33.3 ఇదే కదా yes 2 ones are 2 this is 3.3 రా ఇదిగో 3.3 or you can simply say sir that is equals to 33.3 divided by 3.3 right this is the answer. If you want you can say approximately equals to 10 under 10 to the power 18 rough it. 1.2 how 1.2 are you doing it using a calculator? Sorry. Now photon flux ante entira try to understand all of it. Photon flux is nothing but number of finished ante entira your photon flux is nothing but number of photons per unit area ide kada number of photons formula enti sir P lambda by hc divided by area ante P lambda by hca idigo you can write something like this Pa into lambda divided by hc P upon A pressure upon area okay pressure upon area is intensity ide kada yes intensity into lambda divided by hc is your net flux okay sorry try to understand andariki now let us talk something about your theory of relativity okay relativity theory of relativity yeah I అంటే intensity okay ఈ ఫార్ములాలో your I is intensity we have done in waves actually intensity అంటే ఏంటిరా try to understand okay I will give you the feel of intensity okay చూసుకోండి because it's required in your photoelectric effect also అందరి intensity అంటే ఏంటి sir simply speaking intensity is nothing but number of light rays finished okay I don't know anything just so try to understand all of you if this is my light source okay ide na light source unte it is emitting light particles kada yes let us imagine two different observers ra This is my first observer, ante first I, first I. And let us say this distance is small r, ante chinna r, small distance kada. Yes. And at the same time, let us say another observer is sitting somewhere here, idigo. And this distance, let us call this distance as capital R. Can you tell me, andariki, what, like which observer, right? Ide first observer, idena second observer kada. So ee rendu nunchi which will see the light as brighter light, and which will see a bright one spot ra. The brightness, where do you think is the brightness maximum, andariki? At this point or at this point? Can you tell me where is the brightness maximum? Ante if at all you have a source of light ante telusa, see, try to understand, okay, try to understand. I'll tell you the example of intensity. As I am bringing this source close to myself, what's happening ra? What's happening? What is happening, sir? Choose code. Yeah, you see my hand, okay? You see my hand, all of you. As I am bringing the light source close, what's happening is, you're understanding, this is the intensity, andariki. This is the intensity. Ide kada? Yes. Try to visualize. Okay? As I am bringing the source close, the intensity decreases. Ante that is your intensity. Ardhamaindi ippudu? You understood? Yes. Brightness increasing, decreasing. Ide kada? Ante this observer will see it as a bright light. Kani, when it goes to this observer, it will see it as dim light. Ide kada? Why, sir? Why? Enduku? Why is this happening? The reason is simple. Chuskondi andari. The reason is this source is emitting light rays in all the directions. Andariki chuskondi. Ide kada? Yes. In all the directions. But as you are increasing the distance, chuskondi, here, and at the same time here, and at the same time here, you try to understand, as the line rays are going, their distance is increasing. You are understanding? Distance increasing ante from a given place, only single light ray is falling ra. Chuskondi. Ide kada? Yes, if this is your loop, how many lines are passing? Only one. But if I increase the loop over here, how many lines are passing ra? 3. You are understanding? Ante, what is intensity? Intensity is nothing but number of light rays that are falling on the surface. Ide kada? Yes. So how would you define it, ra? How would you define it? So, hey, all of you try to visualize, okay? It is emitting in all directions, kada? All directions on the end, sir. In all 360 degrees. 360 degrees. So it's a point source. And it is emitting the directions in all the 360 degrees. And a sphere. Spherical surface, kada? Yes. So do one thing. Construct a spherical surface having radius equals to r. Ide kada? Yes. So your intensity is defined as total power divided by area. It is the definition of intensity. Ante 4 pi r square. Ikkada nunchi you can simply say, sir, intensity is inversely proportional to r square. Ante enti ra? If your r is low, your intensity is high. Leda your I is high, your intensity is low. Ardhamaindi andariki? Sir. Anyways, so this was all about intensity. Okay, it's required ra. We will be encountering it in photoelectric effect. Chuskondi. Ippudu let us talk about light nature. Andariki. Okay? Light. Your light resembles both the natures. Both the natures ante enti, sir? The first nature is your particle nature. All of you visualize. Ide kada? And the second nature that the light resembles is your wave nature. Finished. You're understanding? So Albert Einstein, in his theory of relativity, he gave a formula. What formula, sir? He gave a formula that the energy of the light square is equals to P square C square plus m naught C to the power 4. Just for the name sake, good petkondira. C to the power 4. C ante speed of light, P ante momentum, and E ante energy. ఇదే కదా, ఎస్. బట్ ద వాల్యూ m నాట్ అంటే ఏంటిరా, m నాట్ అంటే మాస్ లేదా రెస్ట్ మాస్. యూ టేక్ ఇట్ రెస్ట్ మాస్. రెస్ట్ మాస్ అంటే ఏంటిరా, వెన్ ద object is at rest, whatever mass it has is known as the rest mass. Try to understand. According to theory of relativity, if the object is moving, mass changes, mass decreases. You're understanding? Sorry. But for a photon, choose for a photon. Hey, this all was given as Einstein, okay? This all was given by Albert Einstein. Andariki, try to understand. It is not called as the genius. Just like this, he gave the formulas. For rest mass of photon is 0 ra. So substitute cheskondi ante your energy square is equals to only p square c square kada. Energy ante enti sir, energy of photon. Can you tell me the formula for energy? Square root teeskondi. So ekkada nunchi you can simply say E is equals to p into c. Idigo energy ante enti ra, hc by lambda should be equals to p into c. cc gone ante your momentum should be equals to cheppandi, your momentum is equals to h upon lambda. Idigo లేదా your lambda is equals to h upon p or h upon mv. అందరికి this observation, this formula, this entire result, they are only valid for your light ante photons kada, photons. So this is something given by Albert Einstein, not MC. PC ante momentum into speed, okay? Not MC. Hey, there are two equations ra, chuskondi. E is equals to mc square. It's a different equation. We'll study it in mass defect, okay? This is another formula, that is another formula. Andariki chuskondi. So this was given by Albert Einstein. You are understanding, and only applicable for photons. Kani. There was a scientist. Scientist ante enti? The name is Louis de Broglie. I don't know, okay? De Broglie. Just remember the name. I told you, I showed you the photo kada? Yes. De Broglie hypothesis. So I'll tell you the story, okay? Oh my goodness. Correct. I was not expecting that the NEET student remembers this formula, but very good. Correct. Anyway, choose one. But not required for you, okay? Not required. Sorry. This scientist, no, I would not say he was a student, ra. He was preparing for his PhD. So PhD kosam you must bring some thesis ante you must bring some research work of yourself, ra. You're understanding? And it does not matter, it's small or big or something like that. So this was the person, he wanted to complete his PhD, okay? He wanted to complete his PhD. So what did he do? He saw the equation of Albert Einstein. Hey, this is for light kada. Hey, light. If this is for light, hey, let us do one thing, okay? I will apply this for every single object. Every single object ante for electron, proton, atom, ball, pen, hey, myself also. Every single object. You are understanding? Hey, Albert Einstein only gave this for light. Kani de Broglie, he extended the entire version for any general object. Ante if a car is moving, leda if a pen has been thrown, leda ball has been thrown, he applied that for every single thing, and he said that every particle is a wave. Idigo crazy statement ra, chala crazy statement. You are understanding? Every particle is a wave. Huh? Every particle is a wave. Ante am I also a wave? Yes, according to him, I am also a wave. You are also a wave. You are understanding? According to de Broglie, every particle is a wave. Until this human being is also a wave. You are also a wave. You are understanding? Kani, if we are waves, we must have wavelengths kada. What is the formula for our wavelength, sir? H upon P ante H upon mv. Idigo same ra. Lift, shift, copy, paste. Ade, you are understanding? So he was a PhD student. He wrote entire hypothesis and he presented in front of scientists. మళ్ళీ ఒకసారి scientist said, hey, gone mad rascal, do you think we are mad or something or what? Scientist said, what is the proof? He said, no proof. Okay. Scientist asked him, what is the proof? He said, no proof. A discussion started and it went to Albert Einstein. You are understanding? Albert Einstein. One crazy person, he said something, this news gone to another crazy person. You are understanding? So, Albert Einstein said, hey, baat mein dam to hai yaar. Matlab, whatever he said looks interesting. Hey, give him PhD, give him PhD. Albert Einstein said that. You understand? Sorry, sir. Correct. So Albert Einstein said, hey, give him PhD, give him PhD. Gone, finished. You understanding? Scientifically speaking, చూసుకోండి. This formula helps us understand a lot of unknown phenomena in atoms, okay, in atoms and the structure of atom. This formula helps a lot of things for us to understand. So this was the same assumption of de Broglie. Kabatti, this is still a hypothesis. Hypothesis ante enti, right? It's just a presentation, no fact, no proof, nothing at all. Just a theory. You're understanding? Sorry. So this formula helps us understand a lot of phenomena that were unanswerable. You're understanding? Sorry. Chuskondi. Now, let us discuss some more about this formula. Kada. You try to understand, everybody. Your momentum is equals to mass into speed. Leda mass into velocity. Energy gurinchi cheppandi, kinetic energy half mv square. Ratio తీసుకోండి అందరికి. So kinetic energy upon momentum is equals to half mv square upon mv. ఇదే కదా? మరి let us do one thing. Hey, v square is there, it is v here. So let us match it. Square, gone. 1m gone. You're understanding? Ante 1 upon 2. ఇదిగో. So ikkada nunchi you can simply say your kinetic energy is p square upon 2m. Leda your momentum is root of 2m into kinetic energy. Lift it, shift it. Lambda is equals to h upon p kada. That means h upon root of 2mk. Sir, k ante kinetic energy, not potential. You understand, okay? Your concepts must be extremely clear. Okay? Sir. So this was your theory. Now, simple formula kada. So you simply say your lambda is equals to h upon p ra, లేదా h upon mv. Good. So your lambda should be equals to h upon mv. Value substitute చేసుకోండి. 6.6 10 to the power minus 34 divided by mass is 6.6 into 10 to the power minus 3 grams కిదా, grams kg లో కన్వర్ట్ చేసుకోండి. Multiplied by speed is equals to 2 into 10 to the power minus 4. ఇదిగో. Able to understand? So you'll simply say, sir, 1 upon 2 into 6.6 is gone. Minus 3, minus 4, minus 7 becomes plus 7. 34 minus 7 is 10 to the power minus 20 meters. The problem is, మీ దగ్గర high weight objects అంటే 0.2 gram is also huge. You are understanding? If you try the same wavelength for an electron, అందరికి చూసుకోండి. So if you compare the same thing for an electron, చెప్పండి, what is the mass, sir? 9.1 into 10 to the power minus 31 kgs. ఇదే కదా? ఇప్పుడు క్యాల్కులేట్ చేసుకోండి. And the speed of electron, what is it approximately, sir? 2.18 into 10 to the power 6 కదా? Yes. Let us say first orbit, first shell only. Atomic number 1. Orbit కూడా 1. ఇప్పుడు క్యాల్కులేటర్ h is equals to lambda is equals to h value 6.6 10 to the power minus 34 divided by mv. చెప్పండి సార్, 9.1 into 10 to the power minus 31 into 2.18 into 10 to the power 6. ఇదే కదా? జస్ట్ టెల్ మీ ద ఆర్డర్ చూసుకోండి. minus 34 minus 31 అంటే minus 3 minus 6 అంటే 10 to the power minus 9. It is approximately 6.6 by 9.1 into 2.18. ఇదే కదా? You can approximately say that it is in the order of 10 to the power minus 10 meters అంటే 1 angstrom. We can see it. Instruments కదా, we can see it. కానీ పెద్ద masses కోసం wavelength అంటే చాలా small రా, very small. You cannot see it. I hope it is understandable. Okay, ఇప్పుడు talk something about your radiation pressure. అందరికి చూసుకోండి. Radiation pressure. Now you have to understand. Visible, huh? Hope it's visible. Okay. Radiation pressure. Sir, you try to understand, everybody. Let us talk about radiation pressure. Radiation pressure ante enti ra? You see, okay? Should I tell you? Okay. So if this is a light ray ante enti, sir? Your beam of light from a torch. Okay, it's a torch. Yes, it's a torch kada? Yes. So a torch nunchi the light rays are falling. Try to understand. Ide kada? Yes. If I say the power of this torch is P, andariki. What is power? Power is P. Hey, do you remember in the beginning of the chapter we said number of photons per unit second? What is it? Number of photons is equals to P lambda by H. Gurtunda? Hey, ఇప్పుడు we discuss it, Ray. P lambda by H అంటే number of photons in 1 second. In 1 second, this many photons are there that are emitting. ఇదే కదా? Yes. ఇప్పుడు what we'll do is we will put an object. Object అంటే ఏంటి, sir? This is the object. చూసుకోండి. This is the object. So what's happening, the photons will hit kada? Yes, they will hit. They will hit. Try to understand. They will hit. They are hitting at enti. What do you mean by they are hitting? If you assume that this area in which the photons are falling is A, andariki. Area A kada? Yes, your area is A. Try to understand. Now I want the force. How, sir? Why, sir? Because photon is a particle. How will you describe, చూసుకోండి. Your lambda is equals to h upon p కదా? ఎక్కడి నుంచి your p అంటే momentum h upon lambda. That means the momentum of these photons is h upon lambda. Lambda అంటే the wavelength of the photons. అర్థమైంది అందరికీ? You are understanding? Here h upon lambda అంటే the momentum at which the photons are falling. If it is a perfect black body. Perfect black body అంటే ఏంటిరా? Perfect black body ante it is absorbing all the photons. Ante no photon is reflected. Ante all the photons coming, sticking, something like this. Try to visualize. All the photons are getting absorbed kada. Cheppandi, what is change of momentum? Force kavali kada. Your force is nothing but Newton's second law. Cheppandi, what is force ra? F is equals to dp upon dt ra. Idigo leda delta p upon delta t. Ide kada. For simplicity purpose andariki నేను delta t value I'm assuming it as 1 second. అంటే in 1 second ఒక సెకండ్ లో how much photons are hitting it. ఇదే కదా. చెప్పండి, how many photons రా? ఇదే this much photons are there. Every photon has a momentum of this. Can you tell me total momentum, sir? Total momentum చెప్పండి. ఒక్క ఫోటాన్ కోసం this is the momentum. ఇదే కదా. For n photons, n into p will be total momentum కదా. అంటే n into h is upon lambda. N value ఏంటిరా? p lambda upon h. Substitute, sir, p lambda upon hc multiplied by h upon lambda. ఇదిగో lambda cancel, h cancel. Here force is equals to p upon c. అర్థం వచ్చింది అందరికి? You are understanding? This is your force ra. Hey, you are understanding? Not understanding? So if your area is 1 meter square, pressure is force upon area kada. Yes. If your area is 1 meter square, andariki, if your area is equals to 1 meter square, your pressure is force upon area ante force upon 1 ante p upon c. Idigo this is your pressure ra. Hey, this p is for pressure, this p is for power, and this p is for momentum ray. Hey, you are understanding? What should I say? Pressure equals to power upon c. C ante what, sir? It is speed of light, guru. This is your pressure on 1 unit area is given as p upon c. Idigo next. It was a black body andariki. Perfect black body kada. Perfect black body unte it is absorbing. Let us take the opposite case. Opposite case ante enti ra? Perfectly reflecting. Ide kada. Yes, we will say perfectly reflecting surface. Idigo ante enti, sir? If this is your torch, okay, if this is your torch, all of you, the light rays are falling kada. Yes, perfectly reflecting surface ante mirror, right? Yes, it's a mirror. Ante let us say mass of the mirror is small m kada. Yes, cheppandi, ippudu cheppandi, what will happen ra? They will come with a momentum p. Momentum of the photon is p in the right side kada. As soon as they hit it, they go back. Ide kada andariki. As soon as they hit it, they will be reflected back. What is the momentum? Here also momentum is p. Cheppandi, initial momentum pi is equals to h upon lambda kada in the right side I cap. Your final momentum pf is equals to h upon lambda, same but in the minus I cap. Cheppandi, what is your change in momentum ra? Your change in momentum is 2h upon lambda. Idigo this is the change of momentum. Kani it is for a single photon. If a single photon goes away, this formula ra. What about for n photons? What about for n photons ra? Chuskondi. For n photons, what can you say, sir? Me n photons kosam you will simply say total change of momentum for n photons is n multiplied by delta momentum. Let us change in momentum for single photon. Ide kada. n ante enti ra? p lambda by hc into 2h upon c. Idigo lambda, hey, 2h upon lambda, I'm sorry. Idigo lambda gone, h gone. Ide kada. What you are left ra? You are left with 2p upon c. Idigo this is your net change in momentum. If you are talking about 1 second, for 1 second and 1 meter square of area, you can directly say, sir, radiation pressure is equals to cheppandi, pressure is equals to 2p upon c. Finished. Try to understand this andariki. Okay, but But right, right, right. Right. If area is 1, if area is not 1, right? If you have random areas, hey, thank God you made me realize. Choose code. If area is not equal to 1, let us say area is equals to area. In case lo, you are a black body. What was the formula, sir? Your pressure is equals to, Cheppandi, your pressure is equals to P upon C kada. Now, what do you want? Force. I'm sorry. It is a force. It's a force expression. Ide kada? Yes. Cheppandi. Your pressure is equals to force upon area. అంటే P by C upon area. ఇప్పుడు చూసుకోండి. PC upon area. Pressure upon area is intensity. ఇదే కదా? I upon C. And ఈ కేసులో if your area is not 1, if area is not 1, and the area is equals to area, that means 2P upon AC and 2I upon C. This is the radiation pressure. Intensity. Good petkondi. Now, let us talk about a case where the object is neither a black body nor a reflecting surface. And yes. Flashcards, not flashcards, mind maps I have created. Don't worry, okay? I have created all the mind maps. You will be getting it. Now, what if for a general object, for a general body, I should say, what do we talk about? The general body kosam we talk about absorptivity and reflectivity. Ide kada? Yes. We talk about your absorptivity and your reflectivity. Idigo. Your absorptivity is, what is your absorptivity? How many lines it absorbed out of how many incidents kada? Sorry, same thing. Leda power absorbed, you can take that also. What about reflectivity, Cheppandi. Reflectivity is light reflected divided by total incident light. Ide kada? Yes. Hey, sadharanga mamuluga your A plus R should equals to 1. Idigo. Try to understand this. You're understanding? Sir. So if you have a general object, it is your general object. For this, absorptivity is 0.4. Let us say your reflectivity is 0.6. For reflectivity, what is the formula for radiation pressure? Your reflectivity, you have the formula 2I upon C. Yes. What about the absorptivity? Your power is simply equals to I upon C. Finished. So if you are throwing the lights, okay, if you are throwing the light rays, Cheppandi, what will be the radiation pressure? Directly చూసుకోండి అందరికి. So you can simply say your pressure total is equals to absorptivity into P upon C లేదా I upon C. ఇదే కదా? Yes. Absorptivity into I upon C plus reflectivity into 2I upon C. So you can simply say, sir, I upon C common తీసుకోండి. You are left with A plus 2R. అంటే I upon C, A plus R is R1 కదా? So 1 plus R కూడా తీసుకో. If you want, you can take that also. అర్థమైంది? Yes. This is your formula for your radiation pressure. Okay. Now let us take a question. Andariki. తీసుకోండి. You can do it. Okay, I'll be back in 2 minutes. Just I'll be back. You're not getting the answer, ra. I came, okay. ఉన్నాను, ఎక్కడ ఉన్నాను చెప్పండి. So, your radiation pressure, okay, చెప్పండి the formula ra. Sir, a 0.3 కదా. What about R ra? Your R must be 0.7. ఇదిగో, you're understanding? Okay. So, what do you say now? You will say simply that here, what do you want, ra? What do you want? Force kada. Force kosame we need pressure first. ఆ pressure ki formula ఏంటంటే A into చెప్పండి absorption kada. Absorption ఉంటే you will simply say upon C. Plus B into substitute చేసుకోండి. A value అంటే 0.3. Intensity how much, sir? Divided by C is 7, right? ఇప్పుడు చూసుకోండి. If A is 0.3, your R will become 0.7 కదా. A plus R is 1 ra. Okay. Substitute చేసుకోండి values. So 2 into 10 divided by 3 into finished. ఇదే కదా. లేదా you can also say, sir, P is equals to simply A upon C into 1 plus R. ఇదే కదా. Centimeter kada. Yes. So if your radius is in centimeter, idigo. What are you writing, sir? You are not telling anything. You are not understanding anything. You must understand, ra. You must understand. 22 by 7 into R square. R square ante 7 square. 7 square ante directly into 10 to the power minus 4. Gone. So it is 1.7 upon 3 into 154 multiplied by 10 to the power minus 11 Newton. Idigo. This is a force, ra. I want all of you to visualize this. Andariki. Try to understand. Approximate values తీసుకోండి. Okay, 17 into 150 కదా. Okay, sir, okay. How will you do? 6 plus 4, 10, not divisible by 3 ra. Now let us divide it. 51, okay, 51. Try to visualize them. Andariki. So if you have a torch, okay, minus 10, huh? Yes, correct. And approximate 86 into 10 to the power minus 11 Newton. If you have a torch, Andariki, if you have a torch, you turn it on, it will hit your hands kada. It is exerting force. How much? Minus 11 Newton. Negligible force ra. Ide kada. The force is, చూసుకోండి, all the values that I have taken, they are almost real life values only. Intensity value, your absorptivity. See your hand, that's a white hand, almost your hand surface, the palm of your hand is white only. Yes, so it is reflecting a major part of it. And kabatti, your absorption is very less. Major part is getting reflected. So that is the pressure, that is the force experienced by your hand. You understand? Negligible. Kani, the same force, if you are talking about on a single electron, it becomes massive. You are understanding how, sir? How? Choose. If the same amount of force F is equals to, what is the force, Ra? What is the force? 86 into 10 to the power minus 11 Newton. Idigo, I'm just talking about terminologies, okay? Comparison. We are not doing the question. Andariki. This comparison purpose, I'm telling you. So, mass of electron M is equals to 9.1 into 10 to the power minus 31 kgs, Ra. Force is this. Can you tell me, sir, acceleration is force upon mass? Ante force is 86, 10 to the power minus 11, 9 into 10 to the power minus 31. Choose. The acceleration comes out to be 86 upon 9.1 into 10 to the power 20 meter per second. You're understanding? So huge acceleration. Huge. You're understanding? That's the reason why the laws or the rules of physics, they change when your mass is changing. You're understanding? On a microscopic level, things are very different, Ra. And on the macroscopic level, things are, we don't know anything. Okay? We are fools. We are stupids. We don't know anything of this universe at all. Anyways, choose one. Okay? Sorry. So with that being said, Ra, let us attempt some PYQs. Okay? Let us quickly go to some PYQs, all of you. 2-3 PYQs solve chedam. Ade. What is it? Dual nature of matter, kada? Sorry. Try to understand, all of you. Is it visible? Is it visible, all of you? Is it visible to you? Visible? Visible, not visible? I think it's visible. Choose one. A photon and an electron. Photon and chudandi. Your photon is different. Your electron is different. You're understanding? Sorry. Have same energy E. The ratio lambda photon, lambda electron is dash. Sorry. You are given information that energy of photon is equals to energy of electron is equals to E. Kani nagu lambda of photon and lambda of electron kavali. Idigo chudandi. The same year 2025. One question from your atoms. One question from your. Understand? Two questions. And again, we are about to discuss a lot of chapters. Chapters in the photoelectric effect is there. Okay. Half an hour, more. This chapter is completed actually. It's completed now. We are doing PYQs just to have a grip. Okay, sir. Now, this value kavali kada? Yes. Energy of photon. Cheppandi, what is the energy of photon, Ra? Your energy of photon is simply equals to h by lambda of photon. Finished. ఎందుకంటే mass of photon is negligible, Ra. Zero తీసుకోండి. Almost zero. Kani, when you talk about your energy of electron, you cannot say hc by lambda. You are understanding? You cannot say the energy is hc by lambda. ఎందుకంటే you will have to calculate. You are understanding? Sir. So how will you do it, sir? Your energy of electron is half mv square. ఇదే కదా? చెప్పండి. So ఇక్కడ నుంచి what you can say, Ra? Can you tell me? Hey, మొదటిగా tell me about the lambda of photon. Can I simply say, sir, h upon momentum of, I'm sorry. H upon momentum of photon. ఇదిగో. Say upon lambda. Lambda is equals to, లేదా you can simply say from this equation, చూడండి ఎందుకు. Your lambda of photon is equals to hsc upon E kada? Tell me about your correcta, not correct. ఇదిగో E is equals to p square upon 2m. So ఇక్కడ నుంచి p square is equals to 2 into m into E. ఇదే కదా? అంటే p is equals to root of 2m E. That means lambda is h upon p. అంటే h upon root of 2m E. 2m E. ఇదే కదా? Yes. It is electron, it is photon. What do you want, Ra? What do you want? మీకు photon and electron కావాలి కదా? చూసుకోండి. సరే, substitute lambda of photon, lambda of electron అంటే hc divided by E whole divided by, చెప్పండి, h divided by root of 2me. ఇదే h gone. Send it that side. అంటే c by E root of 2me. ఇదే కదా? That means c into root of 2m divided by E. ఇదిగో. So this is the ratio. రైట్. సేమ్ ఫార్ములా కదా, ఆప్షన్ ఏ చూసుకోండి రా, ఆన్సర్ ఇస్ సేమ్. సి రూట్ 2m/e కదా, సి రూట్ 2m/e, సి రూట్ సి రూట్ 2m/e, దిస్ ఇస్ ద ఆన్సర్. విజువల్. వాట్ ఆర్ యూ టాకింగ్ రా? This is for your photoelectric effect. We will ignore it. ఎందుకంటే graphs and all that there. I don't want anything to be, completely. ఇదిగో థర్డ్ క్వశ్చన్ తీసుకోండి. అటెంప్ట్ ఇట్ రా, అటెంప్ట్ చేసుకోండి అందరికి. ఐఎమ్ గివింగ్ యూ 2-3 minutes ఆఫ్ టైం, టెల్ మీ ద ఆన్సర్. ఓకే, ఆప్షన్ కూడా తీసుకోండి. ఇది కూడా 2025 రా, చూసుకోండి. 3 questions ఓన్లీ. వీ హ్యావ్ ఓన్లీ కవర్ 2 chapters కదా. ఈ 2 chapters నుంచి ఒకటే సింగిల్ క్వశ్చన్ పేపర్లో యూ హ్యావ్ 3 questions. 3 questions, 1 from atomic structure and 2 from your dual nature of matter. You are understanding? Try to do it carefully ra. Okay, I think this is also for 2025 ra. ఇది కూడా 2025 అంటే 4 questions. అండర్స్టాండింగ్ మోడర్న్ ఫిజిక్స్ రా. ఐఎమ్ టాకింగ్ ఓన్లీ అబౌట్ యువర్ మోడర్న్ ఫిజిక్స్. ఇట్స్ కంప్లీటెడ్ కదా. 4 questions directly from your modern physics. It is the minimum 4 questions minimum. That's what I told you. 20 to 30 marks ra. What is the question? I did not read. Lambda కావాలి కదా, n equals to 2. Finished. ఈ లాంబ్డా కోసం v కావాలి. You understand? How will you find v, sir? Do you have formula? Do you have the formula? Directly do it. V formula ra. What is the formula for v, sir? Ide kada. Atoms. Did he say something about the atom ra? Hydrogen atom. Idigo. Hydrogen atom unte z equals to 1, n equals to 1. Ide kada. Substitute. Sir, it is equals to 2.18 into 10 to the power 6 into z value 1, n value 2. Idigo. You are understanding 1.09 10 to the power 6. Mass entara. Your mass of electron. You have 2 different methods to do it. మీకు ఈ మొత్తం క్యాలిక్యులేషన్స్ ఇఫ్ యు ఆర్ నాట్ కంఫర్టబుల్ ఇన్ డూయింగ్ ఇట్ యూ కెన్ గో విత్ అదర్ వే ఐ టెల్ యూ దాట్ ఆల్సో చూసుకో. సో మాస్ ఆఫ్ ఎలక్ట్రాన్ అంటే 9.1 ఇంటూ 10 to the power -31 సబ్స్టిట్యూట్ చేసుకోండి, యు ఆర్ డన్ విత్ యువర్ వాల్యూస్. లాంబ్డా అంటే ఏంటిరా, హెచ్ వాల్యూ 6.63 ఇంటూ 10 to the power -34 డివైడెడ్ బై చెప్పండి మాస్ అంటే 9.1 ఇంటూ 10 to the power -31 multiplied by speed అంటే 1.09 into 10 to the power 6. ఇదిగో if you are done with this calculation, well and good. Okay. మరి what sir, what about what if your calculation is weak calculation అంటే you do something like this. చూసుకోండి అందరికి, your MVR is equals to NH over 2pi కదా. yes, NH over 2pi ఇదిగో. సో ఇక్కడ నుంచి your MV comes out as NH divided by 2πr. అదే what do you want? lambda is h over mv కదా, సబ్స్టిట్యూట్ చేసుకోండి. h divided by mv value nh divided by 2πr. h gone, substitute up అంటే 2πr upon n కదా. n వాల్యూ ఏంటిరా, సెకండ్ దిశలు ఉంటే 2πr upon 2 gone, pi into r is the only option. ఇప్పుడు r క్యాలిక్యులేట్ చేసుకోండి. your r value is simply given as 52.9 into n square upon z. ఇదిగో n square is to 4 అంటే 52.9 into 4, this is going to be angstrom. అర్థమైంది? Okay. I will take care. సరే, substitute చేసుకోండి and then you can calculate it. I think the units are given in your question itself. చూసుకోండి, your nanometers given కదా, and answer లో కూడా you only have nanometers, so nanometers లో substitute చేసుకోండి. ఇదిగో, so you can simply say that is equals to 0.052 into n square upon z nanometer. ఇదే కదా. yes, that means 0.052 into 4 nanometers రా, అంటే 0.052 into 4 is 8 and something like this, I guess. ఇదే కదా. yes, nanometers. ఇదిగో, and multiply it with pi. Here also you have to do the calculation అందరికి. okay, చేసుకోండి. your calculation is must. You are understanding, you are attending physics questions without calculation, not possible. Forget. Next, do you have to take one more PYQ? Okay, let us take one more PYQ. It is 2024. okay, do it. Options kavali. Yeah, I think you have the options also. You don't have. Hey, the options are too scattered. okay, just చేసుకోండి. Tell me the relationship between lambda electron and other. That's it. Lambda theta, lambda alpha. Electron and alpha particle are accelerated by same potential difference. Lambda theta, lambda de Broglie wavelengths of the electron and the alpha particle respectively. అదిగో అంటే ఏంటిరా, you need to understand what is alpha particle. What is alpha particle, sir? What is alpha particle? మీ alpha particle అంటే it is helium nucleus రా. ఈ alpha particle you are having, చెప్పండి, you are having 2 protons and 2 neutrons. yes, in alpha particle you have 2 protons and 2 neutrons. What is the mass of alpha particle? 4 AMU. అర్థమైంది? సరే, you must be good with masses of them రా. okay sir, okay. So mass of proton divided by mass of electron is approximately equals to 1000. ఇదే కదా. 1000 రా, 10,000. You understand, even if you are able to visualize this, చూసుకోండి అందరికి, your mass of alpha particle లేదా it is much more than mass of electron, gone, finished. Your lambda is inversely proportional to mass, ఇదే కదా. What about speed, sir? You remember these things, these are all basic terminologies, okay? And full nonsense is going on in the chat box. Sir, so you can simply say, sir, velocity is equals to root of 2qv upon m. There you go. Correct. And v1 upon v2 is equals to, can I simply say, sir, root of q1 upon m1 divided by root of q2 upon m2. This is the relationship between v1 and v2. And you can simply say speeds. Okay, if you want the relationship between P1 and P2, P1 is to P2 is equals to M1 V1 divided by M2 V2. ఇదే కదా, అంటే M1 by M2 into V1 by V2. V1 by V2 చెప్పండి ఒక్కసారి. It is Q1 M2 divided by Q2 M1. You are understanding? Finished. అంటే V1 by V2 is equals to try to understand when they are applied at the same potential difference. Now it is, yes, tell me, you're saying something. You're saying something. Done with the chapter, okay? Andariki. We'll now shift on the next chapter. Next chapter ante enti ra? ఏదైనా డౌట్స్ ఉంటే అడగండి. Okay? So no doubts kada. Someone is telling some doubts. Okay, wavelength and charge relationship. Wavelength and charge relationship. For what? For what? Let us take some questions, okay? Because I have to take a break at 8 p.m. Okay? And I know it's not possible to complete this photoelectric effect at 8. Sorry. Let us do some experiments, Andariki. Okay? Let us do some experiments based on your dual radiation. Choose code. Question is, a photon mass అని తీసుకోండి. Second relation. Do it. If you want, we'll take some PIQs from JE also. Just a minute. Right. Correct. Answer C is there. There you go. Same question. It's same question. Okay. Only the wording has been changed. I will not solve it. I will not solve it. See the same question. Same question and enti ra. This is same question. There you go. Understanding. Your mains first 25. Sorry, your NEET 25. NEET 25. Question this one. There you go. When it says surface అంటే part of the sphere తీసుకో ఇదే కదా. Yes. You must be very good at understanding the difference between pressure and intensity ra. Okay. Sorry, power and intensity. Correct. Very good question. Very good question. Particle of mass m at rest disintegrates into two particles of masses m and 3m. The ratio of their wavelengths. If this is your particle m, 4m, it is breaking into two parts, mass m and mass 3m. Let us say V2 and let us say V1. What is the relationship? The conservation of center of mass. Rest lo untundi kada. So their center of mass should also be at rest. And M1 V1 should be equals to M2 V2 after collision. M1 value M, V1 value V should be equals to M2 V2. And the momentums are same kada. So if momentum P1 should be equals to P2, that means lambda is equals to h upon p. Lambda 1 p1, lambda 2 is equals to h upon p2. Take the ratios, h gone, p1 p2 same unte, lambda 1 lambda 2 1 vastundi, ekkada nunchi our lambda 1 should be equals to lambda 2. They should be same. Lambda 1 is to lambda 2 1, it should be 1. You are understanding? The ratio should be 1 basically. Next, you take this question, all of you. It is oh. If you understood, well and good. If you did not understand, see the video again. Okay, it's a good question actually. Not good question, but yeah, it's there in the range of NEET. The remaining questions are very difficult for you. I'm scared to give you those questions. Mains lunchi. You can ask me your questions also, okay, everybody. Sir, let us see. Radiation pressure 450 watt light kada. Yes, so idemi power is equals to 450 watt, right? Perfectly reflecting surface ante enti ra, R value is 1. Ide kada? Yes. So perfectly reflecting surface kosame, what you can say, for a perfectly reflecting surface, you will simply say, sir, radiation pressure Rp is equals to 2I upon C. Idigo. This is the formula for your radiation pressure. Ippudu naku I value kavalira. I have power, I want intensity. How will you find it? Same thing. If you have a point source, ekkada nunchi, if you have a surface placed at 2 centimeter, 2 meters ra, 2 meters, చూసుకోండి 2 meters ఉంటుంది కదా. So you do one thing, intensity at this point అంటే complete the sphere. ఎందుకంటే it's emitting radiations in all directions కదా. Yes, it is emitting the radiations in all directions. So you'll simply say, sir, your intensity is equals to me pressure, power divided by area ra. Power అంటే ఏంటి sir? 450 divided by area ఎంత sir? Pi r square. Pi అంటే 3.14 తీసుకోండి, multiplied by r square అంటే 4. ఇదిగో. So this is your intensity. Substitute చేసిన తర్వాత you are having 2 into 450 divided by 3.14 into 4 into speed of light, 3 into 10 to the power 8. 2 ones are 2, 2 to the power, 2 are 2. Hey, 225 కదా? Yes. So you are left with 225 divided by 3.14 into 3 into 10 to the power 8. Idigo. This is the beauty of the GE questions. They don't make the complications much difficult. Okay, 3 ones are 3, 3 sevens are 21, 75. So it is approximately 75 divided by 3.14 into 10 to the power minus 8. Okay, so 3 and 75 are there. Okay, am I correct? Am I doing correct? No mistakes, kada? Yes. 75 upon 3. 75 upon 3 అంటే ఏంటిరా? Yes, you can do it. Right? It's a very simple question. Right. Right. Hi. You can do it by yourself. Okay. Next. Let us talk about next question. You want me to frame more questions by myself? I can frame more questions by myself also. Okay, sorry. Let us say a question, Andariki, all of you. I want to understand this question. Okay, now I'm making a question by myself. Let us see how it makes. Leda, you see, an electron should I say force or should I say torque? Ah, torque, T. Okay? If you want to complicate it, take torque. Leda, you want to keep it simple, take force F. Idigo. Idi chalu. Okay? Finished. Now, తీసుకోండి. Sufficient. And we are doing mistakes, right? It should be 4 into something now. 4 pi r square kada. You can do it. Next. Yes, tell me Andariki. Moving in a circle of radius r kada. Constant of centripetal force F or idigo. So this is your constant force F acting on the electron. Ide kada? Yes, sir. Centripetal force F is equals to mv square upon r. Chuskondi. This is the formula for your centripetal force. Ide kada? So let us do one thing, let us multiply with m both sides. Mf is equals to m square v square upon r. Ikkada nunchi your mfr is equals to m square v square. Take the square roots. Square roots తీసుకోండి అందరికి. So you can simply say, sir, m into v is equals to misbehaving, man. Yeah. So you can simply say, sir, m into f into r root is equals to mv. M into ఏంటి రా momentum అంటే your lambda is equals to h upon mv అంటే h upon root of M, F, R. ఇదిగో whenever the question is given to you in whatever variables అందరికి చూసుకోండి. Okay, what is it? What is the kinetic energy gained by electron due to acceleration through potential difference of 1 volt? Kinetic energy E. Okay, E electron volt is the kinetic energy gained. Sir, చూసుకోండి. In the question, whatever variable was given to you, your answer must be in the same terms. M అంటే mass of electron, Fr చూసుకోండి. F అంటే force, R అంటే radius. అర్థమైంది ఇందరికి? Very good, very good, very good. If you got the same answer, correct. So, J mains nunchi, there is one more question. Electron initial speed, magnetic field. Hey. Sir, let us see a few more questions now, okay? Let us see a few more questions. Class duration will be somewhere around your 12 in the night. 4 more hours are. More hours are left. 4 hours more. Photoelectric effect will be after the break. Okay, we will take a break at 8 o'clock. Okay, your break at 8 o'clock. Then tarvata we will talk about your photoelectric effect. Correct. Correct answers, everybody. Congratulations. Very good. Very good. Very good. Very good. Choose good. Your lambda is equals to h upon p. Ide kada? H upon mv. mv. Until lambda is equals to h upon m into v. V ante entira if the object is released from a tower of height h. Chuskondi. Kabatti I've told you that the results of kinematics keep huge significance. Huge significance. Huge significance. What is the speed as a function of hydra? Do you remember V is equals to root 2gh? There you go. Finished. Finished. Gone. Leda V square equals to u square plus 2s. Just you do it that. You do it that way. V is equals to root 2gh kada? Substitute h divided by m into root 2gh. Chuskondi. Hey, h ante Planck's constant. This h ante height, don't get confused. Hey, I'm telling you, sir, h is gone ante gone. Understanding? You understand, everybody, you understand. If you are cancelling this h, you will get something like root of h over 2g into 1 upon m. If you are cancelling it, it's wrong. So equation you choose, some students will say, sir, directly proportional to root h, sir. Directly proportional, and option A should be correct, sir. No, wrong. You are understanding. This h and h are different. H and height, this is Planck's constant. And this is constant, this is constant, this is constant. That means V is inversely proportional to root h. And if your root h is maximum, your V should become 0. If your root h is 0, your V should become maximum. Velocity is 0. Velocity is 0, momentum 0, momentum 0, and wavelength infinite. If h is more, lambda less. H is less, lambda more. No, inversely proportional. Correct. B is the correct answer. Okay, right. If possible, we'll take one more question and then we'll take a break. Okay, let us take. I'm framing all this question by myself. So, jagrataga cheskondi. Correct. Okay. Andariki, I'm telling you the electric field. If you are interested, ante the students who have already solved this question, ante the good students, I should say, Leda. The students who are already doing this question, they can replace it with magnetic field also. Okay, electric field. I'm telling you, electric field E. మీకు కావాలంటే magnetic field B తీసుకోండి. I'm giving you electric field E. Okay, that's true. ఆప్షన్ కూడా కావాలంటే ఇస్తాను, చూసుకోండి. ఆప్షన్ ఫస్ట్ ఇస్ One more question తీసుకో. Radius r, okay, moving in a circle of radius r. ఇది circle లేదా should just say ఆప్షన్ కావాలంటే ఆప్షన్ కూడా ఐ విల్ గివ్ యూ. ఓకే, ఐ విల్ గివ్ యూ ఆప్షన్స్ ఆల్సో. Want to frame a difficult one, Ra, but let it be. Okay, given magnetic field. Finished. Okay. Sir, your lambda is equals to సరే తీసుకోండి. సో లెట్ us solve this all, okay? Let us solve. అందరికి జాగ్రత్తగా చూసుకోండి. I am solving it. Listen to me everybody. Particle charge M mass M kada. Particle charge Q mass M ra. Placed in external electric field. Force చెప్పండి sir. F is equals to Q into E. గుర్తుపెట్టుకోండి. Your electrostatics ra. You're understanding combinations of different chapters. ఇదిగో. So force is Q into E ra. Acceleration చెప్పండి sir. Acceleration is force upon mass. అంటే force is QE divided by mass M. ఇదే నా acceleration రా. ఇప్పుడు స్పీడ్ చెప్పండి అందరికి. Sir, V is equals to U plus ET. ఇదే కదా. U value 0 రా. A value is Q E by M into T. This is your speed. ఇదే కదా. Substitute. What do you want రా? Lambda కావాలంటే lambda is H upon M into V. ఇదే కదా. H value ఏంటి? H. What about it? రా? Hey. Yes, చెప్పండి. Your H value is equals to, sorry, M into V చెప్పండి. V is equals to Q into E into T divided by M. ఇదే కదా. M gone రా. What is there? Finished. Okay. Next. Correct. ఈ కేసులో కూడా your magnetic field రా. ఇదిగో. You must be knowing the formula. R is equals to mv by qv. Sir, ఎక్కడి నుంచి వచ్చింది సార్? We have seen it in magnetism. Okay, we have seen this formula రా. So from here you can simply say V is equals to QBR upon M. Finished. Lambda H by mv అంటే H by mass into QBR by V. M gone అంటే H by QBR is the answer. Finished కదా. Sorry. Now we have two more chapters left రా. Okay, two more అంటే photoelectric effect, and దాని తర్వాత we are left with your nuclear physics and radiation. Same. Okay, thank you so much. Like the video అందరికి. I have to go and have a dinner ra. Let it be 8:40 p.m. Yeah, and our chapter is complete. Okay. Yeah, guys. Sir, let us continue, everybody. Good to go, Gada? Yes. Hey, 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 hey. So, after break, we will be talking about your photoelectric effect. Andariki chudandi. So, modatiga, let me talk something about what is this, Ra? What is this photoelectric effect and why are we talking about it? Ide kada? Sir. I did not have dinner, but I have something, because of some works. Choose one. So now, let us talk about the next chapter, Andariki. Photoelectric effect. Try to understand. Hi. It's correct. You see, actually, in the scientific world, Ra, chala politics unnai. You are understanding? Ante enti Ra? Hi. Einstein gave theory of relativity. Kani, nobody recognizes in scientific world, okay? So, to give him Nobel Prize, okay, Einstein actually got Nobel Prize for this photoelectric effect explanation. Okay, yes. So, Albert Einstein got the Nobel Prize for this photoelectric effect. Student, he explained it. Okay, let us talk about it. Choose what. What is the general statement, Ra? Andariki, what is the general statement? Can any one of you tell me? సో మీ దగ్గర ఒక మెటలిక్ ప్లేట్ లేదా మెటలిక్ సర్ఫేస్ అంటే కంపల్సరీ మీకు మెటలిక్ సర్ఫేస్ కావాలి. సో ఇఫ్ యూ హ్యావ్ అ మెటలిక్ సర్ఫేస్, ఆ సర్ఫేస్ లో ఫర్ షూర్ దేర్ ఆర్ మొబైల్ ఎలక్ట్రాన్స్ అంటే బ్యాలెన్స్ ఎలక్ట్రాన్, ఇదే కదా? ఎస్. సో దేర్ ఆర్ ఎలక్ట్రాన్స్ రా, ఎలక్ట్రాన్స్ ఇన్ టు ద సర్ఫేస్. ఎలక్ట్రాన్స్ అందరికి ఎలక్ట్రాన్స్ ఆర్ దేర్ ఇన్ ద సర్ఫేస్ ఆఫ్ ద మెటల్, ఇదే కదా? రైట్. ఇప్పుడు if at all you give them energy, andariki, if at all you give them energy, what will happen is they will leave the surface, ide kada? Yes. If you give them the energy, they will simply leave the surface. Ee process ni photoelectric effect. Hey, I am not late. I came exactly at 8:40, okay? Exactly at 8:40. Anyways, sorry. Did I come at 8:42? I think I came at 8:40. Did I? Anyways, student. Hey, 2 minutes only. Even if I came at 8:42. The question is, how do we give the energy to the electron? Ide kada? Okkasari electrons ni energy iste, they will come out of the surface. But my question is, how will you give the energy? Sir, you have 4 different ways. Choose one. Number 1, you have thermionic exposure. You will say something like this, okay? Next, you have radiation, okay? Next, you have electric field application. Let us discuss all of this one by one. Hi. Good evening. Okay. Sir. So, చూడండి, థర్మయోనిక్ ఎక్స్పోజర్ అంటే ఏంటిరా? in thermionic exposure, we basically take our metal surface. Chuskondi. If at all this is your metal surface, what you do is you heat it. You're understanding? Heat cheskondi. Ade. If you are heating the surface, automatically what happens is the electrons are getting the kinetic and thermal energy. Thermal energy. Thermal energy. Hi. Hello. Automatically, electrons, they are getting your thermal energy. This is your thermal energy. Due to thermal energy, they start vibrating. Due to thermal energy, electrons are vibrating. Yes. So vibration increases a lot. So and so at one point, andariki, the electron leaves the surface. Finished. The first way, heat it. Heat chasing this electron will leave the surface. The first one is thermionic process of photoelectric effect. You're understanding? Next case chepandi. Next case lo we'll talk something about your external electric field application. External electric field application ante entira, you place your metal in an external electric field. Andariki మీ అందరికి తెలుసా కదా? If this is your external electric field, ante if this is your surface, this is your surface, and ide మీ external electric field, it is acting vertically downwards. E bar. Ippudu, what do you think, Ra? What do you think will be the flow of electrons? Cheppandi. What do you think will be the flow of electrons? Can I simply say, chuskondi. If at all you have the electric field, andariki, electric field E bar unte, what will you say, Ra? You will simply say, this electric field, మీ దగ్గర ఒక positive charge plus Q ఉంటే, it will simply start flowing in the direction of electric field. అందరికి ఇదే కదా? Hey, tell me, if you have a charged particle in an electric field, it will simply go along the direction of field. ఇదే కదా? What about negative charge, Ra? అదే, the same charge, if it's negative, then it will move away ante opposite direction of electric field. Andariki. So this charged particle, it will start moving to the left. Idigo. A field to the right, motion to the left. Okay. Sorry. Now if at all you are having the electric field ante electrons ante negatively charged particles kada? Yes. Electrons ante negatively charged particles. Idigo. What will happen, sir? If you apply field, the electrons will start moving to the opposite direction. Ante field kindagi untundi kada? So the particles, they may start moving in the upward direction. At appropriate field, an electron may leave the surface. Ante here also the photoelectric effect is happening. Okay, sorry. Next method ఏంటంటే, you are having your atomic collisions రా. ఇదిగో, లేదా పార్టికల్ కొలిజన్ తీసుకోండి రా. ఇట్ షుడ్ బెటర్ బి పార్టికల్ కొలిజన్. ఇదే కదా పార్టికల్ కొలిజన్. ఈ పార్టికల్ కొలిజన్ కేసులో we actually throw some particles like electrons only. Okay, better you take the electron only. చూసుకోండి. There are electrons. ఇదే కదా? Yes. Hey, you have electrons. Right. Now, what we are doing is, now, can X-rays cause photoelectric effect? Depends on the metallic surface. If the work function of the metal is less than the energy of your X-rays, then then for sure photoelectric effect will be taking place. If no, it will not take place. Simple application kada. Yes. So what you are doing, you have some gun, ante electron gun leda any helium alpha particle gun, whatever you want to take. Okay, you can take whatever particle you want. The only necessary condition is that your particle must be ejected with some speed, and it will hit the electron, and ఒక్కసారి హిట్ చేసిన తర్వాత it will impart some energy to the electron. అర్థమైంది అందరికి? Yes. So this electron, it will come out, digo, something like this. We are only talking to just understand. Okay, my entire work will be going in the last process. Last process ante enti ra? You will simply say, sir, electromagnetic radiation ante photon ra, photons. You are understanding? You are hitting the photons. Yes, it's all right. Sir, so if this is your surface, చూడండి అందరికి ఈ surface లో you have electrons కదా. Yes. So let us say these are your electrons, అంటే negatively charged particles రా. అందరికి జాగ్రత్తగా వినండి. And I will ask you a question also. Okay, I will also ask you a question. Let us see how many of you are conceptually strong. అందరికి. What I'm doing now is I'm actually throwing a photon. ఇదిగో photon kada. Yes. So this is a packet of energy. Photon ante packet of energy. Photon. Idigo. This is your photon, all of you. Ide kada. Yes. If this is your photon, it is hitting the electron, and you will simply say electron will come out. Ide kada. Yes. This is known as your EM radiation. Leda your Sorry. Okay, right. Now, what I want to discuss is, you try to understand. Okay, you try to understand this scenario. This is metallic surface. Let us say these are all the electrons. Yes. Good. Hey, this is your photon. Okay, all of you try to visualize. This is your photon coming, hitting the electron. Then tarvata electron also came out and gone. Electron came out and gone. The question is, hey, my question, andariki, jagrataga. Let us say who can answer it. My question is, sir, it's a metal surface kada? Yes, it is a metal surface. For sure, it's a metal surface. This surface lonchi you have taken an electron. Ante charge imbalance aindi kada? Yes. So what? If the charge is imbalanced, don't you think atom becomes unstable? Don't you think if the charge becomes, hey, if the electron has been removed, don't you think that electrons will be less, protons will be more, atoms becomes unstable? You are understanding? If the atom is unstable, how to deal with it? You are understanding? How to deal with it? You are understanding? Ante, if you have an unstable atom, you imagine something like this. Try to understand, everybody. Okay, you are having some millions of particles, millions and billions of particles. In metal surface lo, you are having millions and billions of particles. Okay, yes, you are having millions and X-rays, gamma rays, and UV rays, visible rays can cause, but the work function of the metal should be low, less than the energy of those light rays. Then and only then it will be possible. Ledante your photoelectric effect will not be possible. Yes. The question is, if your electron is gone, millions and billions atoms you are removing one electron. Okay, and let us say, hey, you understand something like this, eh? Right go. It's a metal kada? Yes, it's a metal. In metal you are removing all the electrons. What will happen? If you touch it, what will it do? It will absorb your electrons of your hands. You are understanding? And the charge is flowing. And the current is flowing. And you will get a shock. You're understanding? You're understanding? Yes. So, sir, is it possible to leave the metal surface unbalanced? This is my question. Let us see how many of you can answer. You're understanding? You're understanding? Hey, if you are hitting electron coming out and charge imbalance and atom unstable and do you think such condition will be existing? Do you think that the atom will stay unstable itself? Huh? Do you think the atom will stay unstable only? No. You cannot, understand, you cannot keep the surfaces like this only. In most cases, when you are doing photoelectric effect, you will have to connect the surface to the ground. Here you go. You are understanding? What will happen, sir? As soon as your electron has come out, there will be an imbalance. Some positive charge will be acquired. So, this positive charge ni balance cheyadaniki, this rod, this surface, whatever it's there, it will receive some extra electrons from the ground. Earth is an absolute absorber of charge kada? Yes. Kabatti, you will simply say that the electrons will be balanced by the earthing. You understand? You never do. Hey, if someone is telling you that he has a metallic piece, open metallic piece, if someone says he has an open metallic piece, it never works like that. You are understanding? You are throwing some particle, later some waves, later some radiation and electron. No, you are understanding? You must close the circuit. Close the circuit and endira. You must arrange the exit points first. You are killing a person, make a plan. You are understanding? Yes. What will happen, right? If you are doing normally ide me metal surface kada. So if this is your metal surface, chudandi andariki. What will happen? You are hitting a photon, leda radiation. This radiation tarvata electron has just come out of the surface. Chudandi andariki. Electron came out kada? Yes. Electron actually came out of the surface and it is just here andariki. Chudandi, this is your electron. Immediately within a fraction of second ante 10 to the power minus 8 seconds low, you will see that there is a positive charge, there is a negative charge, and they will attract and the electron will stick to the atom once again. Malli okkasari, to avoid this condition, what we do is earthing. Ade, finished. You do earthing. Ide. You are understanding? Gone. If your earthing is done, that's it. Then the extra electron will be provided by the earth and this will go. Gone. Ardhavayindi andariki? Right. It is because this effect is the evidence for particle nature of light. Because this experiment shows us that light is in the form of photons. Chuskondi andariki. Light is in the form of photons and photons cannot be divided. You are understanding? Photon ante quantized state ra. You cannot have half photon. You cannot have 1.5 photon. You are understanding? So if I say that this is a pen, it's a single pen ra. You are understanding? Single pen ante single photon unte it must be a particle. Number untindi kada ade. You are understanding? You cannot divide photons. We told in the atoms also. Atoms lo kuda. You remember excitation of electron? We were giving photons to the electron in the atom also. So what was happening, sir? So as soon as you were giving the excited state, we were checking if the photon is sufficient or not. If the photon is sufficient or not. Understanding? If the photon is having sufficient information, energy, it will take it. Leda, it will not take it. It will not accept it. Try to understand. Okay, the biggest statement of this experiment is a photon is quantized. Idigo. Quantized ante entira. Quantized ante it is the minimum. Leda, it is the least energy state. Leda, it's the smallest state of the packet. You cannot cut it. Ante entira. Ante you cannot divide the photon further. Idigo, you are understanding? Finished. Now, let us talk something about your energies, energy conditions. Okay, మీ energy conditions గురించి మాట్లాడతాం. సో ఇప్పుడు ఎనర్జీ కండిషన్స్ గురించి మాట్లాడాలంటే చూసుకోండి, there are some terminologies. Okay, there are some terminologies. అందరికి there are some terminologies. Number one, ఇదిగో we talk something about your work function. ఇదే కదా, we talk something about your work function. What is work function, sir? What is work function? What is work function? Student, your work function is solely the property of the metallic surface itself. లేదా the property of the metal itself. అందరికి చూడండి, every metal has different work functions. Work function అంటే ఏంటిరా? The minimum energy required లేదా threshold కదా, yes, required to remove the electron. ఇదే కదా, to remove the electron from the surface. అర్థమైంది? వర్క్ ఫంక్షన్ అంటే 5 ఇది. యూజువల్లీ వి రిప్రజెంట్ వర్క్ ఫంక్షన్ విత్ ద లెటర్ 5. అంటే if usually it's in electron volt, it's in electron volt మామూలుగా. సరే, now if you say చూసుకోండి, you are talking about photons కదా. what is the energy of photon రా? hc by lambda అంటే h mu లేదా hf or h mu, whatever you want to say, you can say it. Okay, చూడండి అందరికి. So let us say your phi అంటే work function of this metal. అంటే ఈ metal surface లో you have some electrons over here. ఇదే కదా, yes. What you are doing now is you are throwing a photon. అందరికి చూడండి, you are throwing a photon. Okay, having frequency f లేదా you should say mu రా, mu ఇదిగో mu. Okay, your frequency of the photon is mu. అందరికి what is the energy it is carrying? What is the energy it is carrying? అందరికి what is the energy it is carrying? Sir, energy is equals to h into mu. ఇదిగో, this is the energy కదా, energy of a photon. energy of a photon. ఇప్పుడు కేసెస్ ఉన్నాయిరా. ఫస్ట్ కేస్ చూడండి అందరికి. మీ ఫస్ట్ కేసులో కేస్ నెంబర్ 1 ట్రై టు అండర్స్టాండ్. ఓకే, మీ ఫస్ట్ కేసులో ఇఫ్ ద వాల్యూ ఆఫ్ h into mu, h mu అంటే ఏంటిరా? ఇన్సిడెంట్ ఎనర్జీ ఆఫ్ ద photon. Okay, incident energy of the photon, it is greater than work function. ఇదిగో ఫస్ట్ కేస్. if h mu is greater than work function, what do you think రా? ఏమైతుంది? ఈ కేసులో you will say that photoelectric effect లేదా electron will be ejected. will be రా? no చూడండి, electron can be ejected రా. Sir, you're teaching English, theory, concept is this. Student, I'll explain everything, everything, okay, everything, don't worry. Second case lo, if it is greater than or equal to, kani me second case lo, if you say your h into mu is less than your work function, no photoelectron ra, idigo, no photoelectron, idigo. Enduku sir? Because your surface, example, me surface ni, you need at least 100 electron volt. I'm giving an example, okay? 100 electron volt of energy to remove this electron. Kani, you are providing only 80 ra, idigo. You are only giving it 80 electron volt. Mari, do you think it will possible? No. What will happen, sir? In case, no, what do you think will happen in this case? Can you tell me? What do you think will happen in this case? Andariki, what do you think will happen in this case? Can I simply say that, hey, I'm asking you theoretical topics, okay? Theoretical topics and conceptual things, ra. What will happen in this case? 80 electron volt of photon has been emitted. Will it be absorbed? Okay, sir. So what will happen, ra? The photon is, chudandi andariki, photon is absorbed. Ide kada? Yes. Photon is absorbed and electron waits. Ide kada? Yes. For next 20 electron volt to appear. Ide kada? Understanding? Yes, circular motion, okay? Accelerated motion can happen with zero work done by that force is circular motion. Okay, work done by the force is zero. Hey, this is wrong, ra. Hey, it's wrong. No, it will not accept. It will not accept. No, sir, because your only condition is either yes or no, no partiality, ra. If it is 80 electron volt, it will simply reject. I don't want, ra. Understanding? Why? Because what do you think, Ray? Do you think that it will receive 80 first, dan tarvata malli okasari 80 electron volt vachina tarvata it will cut into 4, it will then take 20 electron volt. Yeah, understand? 80 20, it does not work with that. It will simply reject it. Yeah, understanding? Yes. So that means photon is not absorbed. So that means surface, lay the electron, it will not absorb the photon at all. Won't absorb the photon at all. Yeah, understanding? It will not do cutting. Cutting photon ante it is the quantized state kada. You cannot cut it. You cannot break it. Yeah, understanding? Yes, it does not absorb the photon. Finished. No photoelectric effect. No photoelectric effect. Gone. Finished. E case lo chuddam andariki. In this case, there are two different cases. Student, andariki. What did I say? Electron can be ejected. Not sure. You are understanding? Not sure. Not sure. Try to understand. Andariki. Okay. Sorry. You're telling to me, am I confusing you? Okay. Sir. E case lo, if this is your metal surface, andariki chudandi. And these are the negative charges. And electrons. You understand? These are the electrons. Here also electrons kada? Yes, sir. Now, there are two different cases. My first case, your h mu is just equal to phi, leda greater than phi. Yes. If your h mu ante the energy of the photon that you are emitting, chudandi andariki h into mu. If it is just equal to the work function, you can say electron is ejected, but andariki chudandi. To talk practically, choosy, you will simply say that there are less chances. Enduku less chances, sir? If you are saying that you are hitting the energy at the same value as the work function, and your h mu is equals to 5. In case low, you will say that it will be ejected. It will not. It can be ejected. Kani chances are less. Why less chances, sir? Because student, if your particle, if your photon hits this electron, right? This electron, what will it do? There are chances that this electron will do collision first. You are understanding? Do collisions. If it is doing collisions, then you will simply say that the electron will be gone. Energy. If it is doing collisions, its energy will be gone. In collisions, so if energy is gone, chudandi, 100 electron volt received, 100 electron volt ide kavali. Ee 100 nunchi, it has already lost 30 electron volt in collisions. Enta remaining 70. Do you think 70 is enough to accept? No, can't understand. The chances are less. If there is no loss of energy, then you can say that electron will be ejected. You understand? Sorry. The last case look, your phi value leda your h mu ante energy of photon, it is more than work function. Chudandi. In case lo kuda there are chances. You cannot say exactly that it will be. You cannot say that exactly it will be ejected. You are understanding? Hey, am I audible, all of you? Am I audible? Hello. Sir, if your h mu is greater than work function, if this is your metallic surface, electron, electron. There you go. Now, if I tell you that your work function is more, okay? Your energy is more, okay? Your energy is more, but let us say you had 100, not 100, let us say you have 200 electron volt of energy. I'm giving you an example, okay? Again, I'm giving an example. This electron, you need 100 electron volt to remove. 200 received, as soon as you receive it, you are doing collision. This electron is doing collision. In collisions low, it lost almost 120 electron volt of energy. Student, how many gone? 120 gone. How much left, sir? 80 left. Is it sufficient? Not sufficient. You understand? 80 electron volt, not sufficient. Okay, 80 electron volt is not sufficient. 120 gone. Where, sir? Gone in collisions. Ardhamindi, sir. How much left, Left. Is it sufficient? Not sufficient. No effect. Good. Now, let us take the best case scenario. Best case scenario ante enti me best case scenario lo you have a metal surface. Chudandi andariki. You have a metal surface, something like this, okay? Something like this. Hey, something like this. There you go. So, now, what you're doing is, మీ దగ్గర ఒక photon అంటే h mu energy is there. You have thrown it, hit it. Let us say h mu అంటే 200 electron volt of energy is there. అందరి జాగ్రత్తగా వినండి, జాగ్రత్తగా. It needs 100. What sort of voice is coming, Gurr voice is coming up. Clear now? Clear now, all of you? Is it clear? Is it clear? What is it coming, Ra? Good. Sorry. So clear కదా సరే చూడండి ఈ ఆర్ గివెన్ ఎనర్జీ అంటే 200 ఎలక్ట్రాన్ వోల్ట్ ఎంత కావాలి how much do you need it okay you need 100 electron volt ఇదే కదా yes మీకు 100 electron volt కావాలిరా కానీ you have given 200 electron volt how much difference sir 100 electron volt is difference కదా చూసుకోండి so ఈ కేస్ లో when your electron will come out అందరికి where will this extra 100 gone ra hey do you think అందరికి చూడండి let us say ఈ కేస్ లో your energy is 150 electron volt you need 100 how much extra sir 50 electron volt extra energy kada where will it go ra where will it go andariki where will it go it will simply go చూడండి అందరికి remaining 50 electron volt will be utilized ra ide kada yes will be utilized to increase the kinetic energy andariki to increase the kinetic energy of electron edigo ante your total energy h mu is gone in two cases ra first case to remove it ante work function plus migita energy ante your kinetic energy ide kada చూడండి ఇదే కదా సరే now what will you understand from this is that your kinetic energy is not always the difference చూడండి అందరికి what I'm telling ra you understand 2-3 cases తీసుకోండి చూసుకోండి అందరికి first case మీ second case మీ third case ఇదే కదా yes మీ first case లో your work function phi is equals to 100 electron volt ఇదే కదా let us take work function same ra same let us take work function as same in all cases ekkada kuda your work function phi is equals to 100 electron volt work function phi is equals to 100 electron volt same radiation చూడండి అందరికి అంటే h mu is equals to 250 ఇదే కదా electron volt energy ekkada kuda same h mu is equals to 250 here also here h mu is equals to 250 ఇప్పుడు చూడండి అందరికి I want all of you to focus మీ ఫస్ట్ కేసులో this energy came చూసుకోండి ఎలక్ట్రాన్ ఇదే కదా ఎస్ ఫాల్ ఈ 250 నుంచి 100 electron volt it got finished in work function అంటే in removing the electron ఇదే కదా ఎస్ చూసుకోండి అందరికి so if this was the electron 250 received 100 gone ra remaining in sir 150 ee 150 loji let us say it has doing some collisions you are understanding doing collisions ante 70 electron volt wasted ide kada wasted in collisions ra ఇప్పుడు how much left ra 170 gone kada 250 నుంచి 80 is remaining ra మిగతా 80 electron volt will be transferred లేదా it will be utilized to increase the kinetic energy is equals to 80 electron volt idigo you are understanding so ee case lo what will you say sir your h mu should be equals to work function plus kinetic energy will you use this formula ra సబ్స్టిట్యూట్ చేసుకోండి ఒకసారి. సార్ 250 is equals to వర్క్ ఫంక్షన్ 100, కైనెటిక్ ఎనర్జీ 80. బ్యాలెన్స్డా? నాట్ బ్యాలెన్స్డ్. యు ఆర్ అండర్స్టాండింగ్? ఈ కేసులో దిస్ ఫార్ములా ఇస్ నాట్ వ్యాలిడ్. మరి వట్టుడు 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 హియర్ ఈ కేసు చెప్పండి. హియర్ 250 has been received. ఇదే మీ ఎలక్ట్రాన్. వాట్ ఇస్ ఇట్ డూయింగ్ రా? అందరికి 250 నుంచి ఇట్ ట్రాన్స్ఫర్డ్ 100 electron volt into removing, అంటే వర్క్ ఫంక్షన్. హౌ మచ్ లెఫ్ట్ సార్? 150 లెఫ్ట్. ఈ 150 ఎనర్జీ ఇట్ ఈస్ వేస్టింగ్ రా. కంప్లీట్ ఎనర్జీ వేస్టెడ్. ఇదిగో కొలిజన్ 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 అంటే 150 వేస్టెడ్ ఇన్ కొలిజన్స్. ఇదే కదా. వాట్ విల్ బి ద కైనెటిక్ ఎనర్జీ రా? 0. యు అండర్స్టాండ్ మీ? Substitute into the formula, sir. H mu should be equals to 5 plus kinetic energy. H mu 250, work function 100 plus 0. Do you think it's valid? Not valid. Not valid. Ante, I basically want to tell you the formula that we are using this has a little conceptual twist. Andariki chudandi. You are understanding? Mari em cheyali? You must say that this kinetic energy is not an ordinary kinetic energy. It is the kinetic energy in the best case ra, ante maximum kinetic energy. Chudandi. In the last case, your 250 was received, 100 gone for work function, migita 150, it did not waste anywhere. Wasted energy is 0. Best case kada? Yes. Ide me best case ra, wasted energy is equals to 0. Andariki 0 kada? Yes. Ante ee case lo your kinetic energy will be 150. Kani this is maximum kinetic energy kada? So the actual leda, the correct equation is this. Your H into mu should be equals to your work function plus maximum kinetic energy. There you go. This is your equation. You are understanding? Simply telling will not work. Arthamaindi andariki? Sare. So let us take a question, all of you. I'm making it myself raw, okay? చేయండి. సరే చూసుకో. It is your surface kada, surface. What is it, sir? Work function is 570 electron volt. Ante your phi is equals to 570 electron volt. Ide kada, right? What next? Such that kinetic energy of 20 electron volt. Ante K is equals to 20 electron volt ochindira. Idigo. So your photoelectron, sorry, your photon. I'm sorry. Your photon hitting an electron. Ide kada? Yes. So hitting the electron at 570 electron volt. Dan tarvata 20 gone in your what? Gone in your, what do you want? Yes, kinetic energy. And what next? If third fourth of kinetic energy dissipated, ante 20 into 3 by 4 ide kada. Yes, ante 15 electron volt gone ra. 15 electron volt in collisions. Yeah, understanding. What is the total energy andariki? What is the total energy? What is the total energy? Total energy ante 570 plus 20 plus 15 ante 605 electron volt. E energy must be received from the photon only. Ide kada? Yes, photon energy cheppandi okasari. Sir, your E should be equals to h into f. Idigo, finished. Kani hey andariki, but you cannot do the calculation using these values. Enduku sir? Because 1 unit is in electron volt and your H value ra, it is in SI units. Ardhamaindi andariki. So మరి ఏం చేయాలి? You convert this electron volt into joules. What is the formula, sir? Now you must remember the formula for conversion. Andariki 1 electron volt, charge of electron ra, hey, gone. Understanding, sir? So now you can simply say, sir, 605 into 1.6 into 10 to the power minus 19 joule should be equals to H value cheppandi okasari. 6.6 10 to the power minus 34 into F. Send that set. Gone. So sir, your F should be equals to 605 1.6 10 to the power minus 19 divided by 6.6 into 10 to the power minus 34. Ide kada? Do it. Okay, sorry. 85.70, not 85.70. How can you say 85.70? You can do it by yourself. Okay, now these are simply mathematical calculations, right? Okay, sir. Now let us talk about new terminologies. Andariki. Hey, all of you, try to understand, okay? Let me give you one more information. Andariki, chudandi. Your energy of photon, energy kada, your energy of photon is equals to H into C upon lambda. Idigo. H ante constant ra, Planck's constant. C kuda constant kada. So instead of this H into C, you can simply write this. Andariki, 1240 upon lambda. Kani chudandi, ee case lo, your lambda should be in nanometers, huh? Good petkondi. Your lambda must be in nanometers. Units 1.5 into 10 to the power, no, not minus 17. It will not be minus 17, okay? Please correct yourself, ra. You understanding? It will not be minus 17 because denominator is more, ra. Okay, andariki chudandi. Hey, I'm telling you once again, ra, jagrataga vinandi andariki. When you have the numbers అంటే మీ దగ్గర రెండు యూనిట్స్ ఉన్నాయి. ఫస్ట్ వన్ ఈజ్ ఆర్ SI యూనిట్స్. SI యూనిట్స్ లో H వాల్యూ, C value, you do it, it gets a very complicated result. You are understanding? And then the second unit ante, your lambda should be in nanometers and your electron should be in electron, energy should be in electrons. There you go. You are understanding? You can easily calculate your wavelength. Right. Let us take a question now. Okay, let us take a question. Question is, a photon has a wavelength of 4 nanometer రా ఇదిగో ఇదే కదా. చేసుకోండి. No. Maximum possible kinetic energy. Should not be that low, right? Calculation is wrong somewhere. సరే, ట్రై టు అండర్స్టాండ్ అందరికి. వేవ్ లెంత్ ఆఫ్ 4 నానోమీటర్ కదా. చెప్పండి energy of photon is hc upon lambda ఇదే కదా. What is the value of lambda రా? 4 nanometer. Nanometer లో wavelength nanometer, energy electron volt. If these are the conditions, close your eyes and write the value of hc రా. Your hc is 1240. ఇదిగో gone, finished, అంతే. Your understanding? Divided by lambda value is 4 ante it is 310 electron volt of energy. ఇదిగో the photon has the total energy of 310 electron volt. దీని నుంచి you will simply say that your work function is equals to 270 electron volt కదా. Yes, చూసుకోండి. This is your electron. ఈ 310 నుంచి 270 has been gone in your work function. How much left? 40. Gone. This is the maximum kinetic energy possible. Not it is. It is possible. You are understanding? Yes. Maximum kinetic energy is 40 electron volts. అర్థమైంది ఇందరికి? సరే. Okay. ఇప్పుడు let us talk some property రా. Property అంటే ఏంటి సార్? Let us talk about your quantum efficiency. ఇదే కదా? Yes. Your quantum efficiency of a surface. చూసుకోండి. We usually take the highly quantum efficient surfaces for your photoelectric effect. అంటే your solar panels, you remember your solar panels ra? Whatever solar panels are there, all of them work on the same principle of photoelectric effect. అర్థమైంది ఇందరికి? Yes. So what metal to be used ra? Our solar panels lo it is decided on the basis of your quantum efficiency of that surface. You understanding? Silicon and all those things? Yes, that's what I'm telling you. చూసుకోండి. If you want to write it in joules, your 1 electron volt is charge of electron 1.6 into 10 to the power minus. It is shortcut, okay? Joule. So 40 electron volt is 40 into 1.6 into 10 to the power minus 19. అంటే 64 into 10 to the power minus 19 joules. This is the energy. Okay. So if you want to calculate speed, you can also calculate speed. This is your energy kada. Yes. You want to find speed. What is the formula for energy, sir? Half mv square should be equals to energy kada. Half is half. Mass of electron 9.1 10 to the power minus 31 into v square is 64 10 to the power minus 90. So you can simply write, send it that side. So you'll simply say, sir, 128 divided by 9.1 multiplied by 10 to the power 19 minus 31. 31 minus 19, 12 should be equals to v square. Take the square root. So v should be equals to 10 to the power 6 into root of 128 upon. This is the speed. Okay, you can also calculate the speeds of electrons. You are understanding? So, next. What answer? Okay. So you told in joules. I'm sorry. I did not say in joules, ra. I've only thought about your electron volts. I'm really sorry. Okay, I did not see the units. Okay, I thought this was minus 19 and all. Okay, sorry. Correct answer. Correct only. Okay, correct only. Sir. So quantum efficiency of a surface ante it defines how much electrons are emitted per చూసుకోండి. Your quantum efficiency eta symbol అంటే eta, coefficient of viscosity coefficient of viscosity రా. చూసుకోండి. Your eta should be equals to number of electrons లేదా photoelectrons, number of electrons emitted రా. ఇదే కదా? Yes. Divided by total number of photons. Total number of photons emitted multiplied by 100. You understand? Simple principle. Leda simple factor. You understanding? Ante, if your eta value is high, you will simply say metal is favorable for your photoelectric effect. Okay? And high eta metals are in generally, sadharana, they're used, okay? They are used only. Okay. Next. Yes, we will start nuclei from 10 p.m. Okay, we will start nuclei from 10 p.m. So, what I want to say is effect of intensity. Photoelectric effect, sir. చూసుకోండి. Surface, దీంట్లో you have electrons. Okay, you have electrons in the surface. అందరికి అర్థమైంది సరే. So you are throwing some photons. ఇదిగో try to understand. Okay, intensity అంటే ఏంటిరా? Intensity, what do you mean by intensity, sir? Intensity is simply related to number of rays, ఇదే కదా, లేదా number of photons రా. Finished. If you have 3 light rays లేదా 3 photons, 3 different photons at the same time, they will be taking out 3 electrons రా. ఇదిగో 3 electrons coming out, ఇదే కదా 3 electrons. If you have more will come out. అంటే you will simply say, sir, if your intensity is more, your number of photoelectrons, ఇదే కదా, yes, your number of photoelectrons is also more. చూడండి అందరికి, one important topic to remember, all of you. Your intensity has nothing to do with your అర్థమైంది కదా, nothing to do with the kinetic energy of photoelectrons రా అందరికి చూసుకోండి. It has nothing to do with the kinetic energy of photoelectrons. No. Why, sir? Because frequency, you are understanding? Yes, frequency of photons decides go. అర్థమైంది కదా, all of you like the video రా. Hey, like the video. Next case లో we'll be talking about the experimental perspective of your photoelectric effect. అంటే this experiment, yes, this experiment అందరికి జాగ్రత్తగా వినండి. Okay, ఇప్పుడు we have to do an experiment. Okay, we have to do an experiment now. What experiment, sir? ఈ experiment కోసం you do one thing. సరే చూసుకోండి. So what will you get, Ra? So if this is your metallic plate, let me just tell you about the experiment first. Okay, this is your glass tube. Hey, cathode ray experiment gurtunda, anode ray experiment, do you remember all those experiments? Same setup, Ra, almost same setup. Okay, almost same setup. Okay, because your semiconductor has energy levels, bands kada, bands. Yes, so it is almost easier to excite an electron from semiconductor because in your metal the electrons are in the pure atomic state. Ra, understanding atomic state ante they are perfectly into the atoms. They might be in different energy levels. So you see on atomic level you will have to excite the electron, then ionize it. After ionizing also the electron may interact with the subatomic particles like electrons and all other electrons. Ra, కానీ మీ సెమీకండక్టర్లో the electrons they are at a very localized, I should say localized state. Okay, సరే anyways చూసుకోండి. So this is a glass tube అందరికి ఇదే కదా, this is your glass tube. దీంట్లో you have gas but you have gas at low pressure. Why low pressure, sir? Very low pressure. Low pressure in the sense 10 to the power -5 atmosphere లేదా Pascal. Your pressure should be very low. You are understanding? It's 10 to the power -5 atm approximately. అంటే very low రా దిగు. Now what should I say? Yes, so ఈ కేసులో your gas particles are negligible. Why negligible, sir? Because now we are going to remove electron by photoelectric effect kada. So I don't want any interaction of the electron with the gas molecules. Ra, if they are interacting ante attraction, repulsion, all those, I don't want that nonsense. Okay, nonsense. Chuskondi. But I need some gas. Why not pressure is 0, sir? Why only low pressure? Because I need some gas. Ra, electrons should flow kada. Yes, so I need some gas molecules as a medium particles, and I don't want much gas particles ante I don't want much disturbance. చూసుకోండి. ఇప్పుడు what we did was we actually ejected అందరికి చూసుకోండి, we actually thrown some radiation on this plate. As soon as your radiation అంటే your photons కదా చూసుకోండి, your voltage of the battery లేదా potential of the battery was V. Now what you did is you ejected some photons. Due to these photons, the electrons from this plate, andarki chuskondi, the electrons from this plate got ejected out. Ante photoelectric effect ra, photoelectric effect ayindi ide kada. Yes, You will simply say this is space charge ra. Space charge ante enti ra? The electrons that are close to the plate. Close to the plate. Ide kada? Try to understand. Now. Ippudu andariki try to understand. As soon as the electrons have been removed, try to understand, okay? As soon as the electrons have been removed, battery will do its work now. Hey, what does battery do, ra? Battery will try to push the electrons. What direction, sir? In what direction? Chuskondi. Positive terminal ante this plate will have positive charge. Positive charge ante chuskondi andariki. Hey, it is anode kada? Sir, this plate over here is having a positive charge. Oh my goodness. Ante, as soon as the electron is coming out, it will get attracted due to this positive charge. Ide kada? Yes. Try to understand. So if at all, an electron, hey, chuskondi ra, it is starting from here and going over there. Understanding? Ante, who took this electron, ra? Battery. Understanding? Battery. And also kinetic energy also. Chudani. When I throw the photons, what happened, ra? Some energy gone in work function. Migita energy converted into kinetic energy. Kada? Yes. That kinetic energy plus. Your kinetic energy plus work done by battery is responsible for the electron to move. Ide kada? Are you able to understand this? All of you. Cheppandi. So what will you say now, sir? What will you say? Cheppandi. Your maximum kinetic energy. Ide kada? Ippudu I want the kinetic energy at this point. Andariki cheppandi. I want the kinetic energy at this point. Now again the same thing. I am considering the best case scenario. Andariki chuskondi. Best case scenario ante enti ra? Your photon has energy h into mu kada? This h into mu, if it is just equal to, chudandi andariki, if it is just equal to work function, మీ ఫస్ట్ కేస్ లేదా మీ సెకండ్ కేసులో h into mu is greater than your work function. What are the scenarios we'll be seeing it అందరికి? సో మీ ఫస్ట్ కేసులో your h into mu is just equals to work function. చూసుకోండి. If it is just equal అంటే the electron will just come out ra. Zero kinetic energy. అదే కదా? Yes. అంటే your initial kinetic energy should equals to 0. మరి what about maximum kinetic energy ra? Leda final kinetic energy. Cheppandi andariki. This final kinetic energy will come only because of battery. Potential V unte, charge of electron E unte, what will you say, sir? Kinetic energy is Q into V kada? Gurtunda? Energy ra, energy. Q into V ra, idigo. So you will simply say, sir, maximum kinetic energy is Q into V. What will be the equation ra? Your h into mu minus work function, it becomes 0 kada? Chuskondi. H into mu minus work function becomes 0. You are understanding? This is the maximum kinetic energy, right? This is the kinetic energy maximum plus Q into V. Ante this is kinetic energy due to photoelectric effect. This is the energy due to work done by battery. This becomes your final kinetic energy. Try to understand, everybody. If you are understanding this equation, ante this experiment has been successful. You are able to understand. Chuskondi. This equation ra. So what in the second case? Second case lo your h into mu is greater than work function. Ante enti ra? Cheppandi. So if this is your radiation, ante if these are the radiation falling on the plate, ide kada? Yes. H mu is the energy andariki. Work function is phi. What is the kinetic energy ra? Maximum kinetic energy, sir. K max is equals to cheppandi h into mu minus phi kada? Yes. So this is the maximum kinetic energy because of photons. Kani at the same time you also have battery ra. This setup, it's there in the battery kada? Yes. Something like this. Try to visualize andariki. This is in the battery ra. Glass and all these things. Okay? Battery. So you have battery also. So this is kinetic energy due to photon. Cheppandi battery due to battery. What is kinetic energy ra? The kinetic energy due to battery is equals to Q into V. Ide kada? Total kinetic energy cheppandi, sir. Final kinetic energy is kinetic energy due to photon plus kinetic energy due to battery. Ide kada? Photon cheppandi. What is kinetic energy due to photon ra? It is h mu minus phi plus Q into V. Idigo. Same formula ra. This and this. You are understanding? This is your kinetic energy final. Sorry. అర్థమైంది ఇందరికి? Right. Once again I want you to understand. Okay, మళ్ళీ ఒకసారి చూసుకోండి. As soon as the electron is removed, this terminal, battery terminal చూసుకోండి. Positive terminal అంటే positive charge will attract. ఇదే కదా? Electron removed. Negative charge, battery terminal, positive charge ante plate is also positive charge. The positive charge will attract the electron ante the speed of electron will keep on increasing. Okay. In a photoelectric effect, the electrons are ejected from metal if the incident light has certain maximum wavelength, frequency, amplitude, none. Okay. Sir, it should actually be multiple correct because not wavelength. Point number one, photoelectric effect actually tells us about the particle nature. Particle nature unte your energy should be equals to h into mu. So frequency decides. What did I say? I said frequency decides the kinetic energy, and if it is removing or not. Okay, so it depends on frequency, not also amplitude also. Okay, sir. Next case lo we'll be talking about చూసుకోండి అందరికి. Hey, your electron is flowing there కదా. So మళ్ళీ ఒకసారి electron will go through the circuit అంటే electron is moving in the entire circuit. You understand? Energy came అంటే photons came. Due to those photons, electrons removed. ఈ మొత్తం electrons flowing to another plate. In another plate nunchi they are flowing in the wire and coming back again. Ante the flow of electron is there. Flow of electron, closed loop, current. That means there will be current in the circuit. You are understanding? Hey, చూసుకోండిరా. So there will be current. ఇదే కదా? Yes. So if you see current versus potential difference లేదా potential gap రా. Okay, graph. Current versus potential graph. అంటే ఏంటిరా? This was something like this. చూసుకోండి అందరికి. So this was your current increasing కదా. Hey, this is current and this is potential రా. అందరికి చూసుకోండి. So మొదటిగా the current was seen as increasing రా, but after a certain limit the current value became constant. You understand? Sir, it is for one intensity I1. Intensity అంటే ఏంటిరా? Your intensity of your particles. చూసుకోండి అందరికి. This is the intensity కదా. If you have one intensity, things will be different. If you have another intensity, things will be different. If you increase the intensity అందరికి I1 and for second intensity I2, this will be the graph. Hey, not decreasing graph. It should keep on increasing. అదే కదా. Hey. This intensity is I2. అంటే I2 greater than I1. ఇదిగో. This is your current I1. This is your current I2. You are able to understand? Okay. Yes. So the current will only increase up to a certain value of V0. ఇదిగో. Try to understand. Next, let us do the same experiment, but battery is reversed. You are understanding? The battery is reversed. Battery reversed అంటే ఏంటిరా? You will just reverse the polarity of the battery, remaining every setup remains the same. అందరికి చూసుకోండి. ఈ కేసులో now I want you to understand, okay? It's a very important topic, right? It's the last and most important topic. Whenever the questions coming from your photoelectric effect, focusing on this concept only. అందరికి జాగ్రత్తగా వినండి, okay? సరే. Now I'll do the same experiment అంటే the setup is same. ఇదిగో. రివర్స్ కదా, పోలారిటీ రివర్స్డ్. పోలారిటీ రివర్స్డ్ అంటే సేమ్ ప్రాసెస్. చెప్పండి, if at all you have photons, you are throwing the photons on the plate kada. Yes, as soon as the photons are thrown, ఏమైతుంది sir, the electrons are getting ejected. Point number 1 గుర్తుపెట్టుకోండి. Point number 1 the electrons are getting ejected అంటే as soon as you hit it, your electrons are here. అందరికి చూసుకోండి, these are your electrons. ఇదే కదా. So what's happening? What is happening? They have ejected, they have been ejected. Cases చూసుకోండి. మీ ఫస్ట్ కేసులో మళ్ళీ ఒకసారి your h into mu is greater than work function phi. అంటే ఏంటిరా? That means your ejected electron will have some kinetic energy. Okay? Yes. మీ ejected electron, it will have some kinetic energy. చూసుకోండి. What is the kinetic energy? Sir, ఈ కేసులో your maximum kinetic energy ఇదే కదా, should be equals to h into mu minus work function phi. Try to understand. ఇదే కదా. Yes. Sorry. Now what is happening is, let us take only this case ra. Okay, there is one more case also, h mu is equals to phi, but useless case. Our case lo you are anyhow getting this zero only answer. Okay, you will not waste our time. ఈ case లో your maximum kinetic energy is this కదా. అంటే ఏంటిరా, if this is your tube, అందరికి జాగ్రత్తగా వినండి, if this is your tube, okay, this is your battery. ఇప్పుడు చూసుకోండి, this is your battery రా, polarity reversed అంటే your electron has just exerted రా, అంటే let us say electron has been ejected. ఆ సర్ఫేస్ నుంచి electron just came out, కానీ it has some kinetic energy k max అంటారు. అందరికి చూసుకోండి, this kinetic energy will be responsible to move electron in the forward direction. ఇదే కదా. Yes, but V అంటే వోల్టేజ్. ఇప్పుడు చూసుకోండి, పాజిటివ్ టెర్మినల్ కదా, పాజిటివ్ టెర్మినల్ అంటే this should also have a positive charge because of battery అందరికి, not because of electron. Okay, because of battery. So basically this battery will try to pull this electron back. అంటే ఏంటిరా, you have thrown light అంటే photons. Due to this photons, electron came out, but battery is pulling it back. చూసుకోండి, it came out but pulling it back. You are understanding? అంటే ఏంటిరా, ఈ కేసులో you will simply say, sir, your maximum kinetic energy is gone. Where, sir? Where? In the battery. Battery took it. You are understanding? అంటే your maximum kinetic energy is equals to work done by battery. ఇదిగో Q into V naught. Maximum kinetic energy ఏంటిరా, h mu minus work function phi should be equals to Q into mu V naught. Understanding? వచ్చింది కదా. Yes. So ఇక్కడ నుంచి what you can say is your V naught value అంటే h mu minus phi divided by q అంటే electron charge రా, అంటే e. This potential is known as the stopping potential. ఇదిగో, you are understanding? So this is the stopping potential of the electron లేదా battery, whatever it's there. Okay, అర్థమైంది అందరికీ? సరే, you try to understand what is there in your hands. In your hands is this frequency of the wave photon. Okay, it's there in your hands, and you can change it, you can change the energy also. What about work function? Not in our hand, depends on metal only. What about V naught? Right there in our hands. Understanding? So we can adjust the things accordingly. Andariki chusko, this is something that you get. Okay, this is something that you get, and your work function is V naught. E V naught ki value entante, you can simply say your V naught is h mu minus work function phi divided by the charge. Getting it? So your chapter ante your photoelectric effect has been completed. Andariki chusko completed ra. Okay, completed. Stopping potential completed. Experiment completed. Intensity variation, frequency variation. Your yes, completed. Now sorry. So the next chapter we are interested in, two chapters. Actually, it's a single chapter, but but physically for the cathode, there are different answers. That's why I tell you to not ask theoretical questions. And for a cathode, work function could be said as potential difference of cathode with respect to anode, at which there is no electron loss from the cathode. You can understand. Okay, sir. It's like a Vaivara. Okay, sir. చూసుకోండి. Now the chapters we have to see are two అంటే ఒకటే చాప్టర్ ఉంటుందిరా, బట్ ద classification is in two different cases. చూసుకోండి. Okay, first classification is number 1 is your radioactivity, and దాని తర్వాత the second classification that we have is your nuclear physics. Okay, now I can at least say that these two subjects, these two chapters require 2 hours, minimum 2 hours. Okay, minimum 2 hours, 2 maybe more also. Okay, minimum 2, maybe more also. So I was thinking, let us first take the break, Andari. Okay, let us take a break, let me relax a little. Okay, and then we'll continue these things. Okay? You also go and fresh yourself. Okay, so let us take the break till 10:40. Okay. Last topic. Okay, last topic. Hi. Welcome back, everybody. Yes, 10:40 already, and I'm also ready. Okay, you're also ready. Everybody ready. ఇదే కదా సరే వచ్చింది కదా ఎస్ you're not. Hi. No, I came exactly at 10:40. Okay, the time is delayed, Ra. You understand? The time is delayed. Sorry. So let us talk something about your nuclei. Ante ide ma last chapter ra. Dan tarvata your modern physics is completed. The only chapters left will be your semiconductors, KTG, and your thermodynamics. 3 chapters. Ade completed ante your physics is completed. Sorry. No. Okay. We'll talk something about your nuclei. Sorry. So, everybody ready? Okay. So, just good. Let us talk something about your structure of nucleus, okay? And the nuclei chapter, the first interested topic that we are interested is about the structure of nucleus. Cheppandi, what do you have, Ra? Nucleus lo. Can you tell me, Andariki, what do you have in your nucleus? What is there in your nucleus? How do you know, Ray? Sir. Okay. Now, let us talk something about the structure of nucleus. So, sadhananga, your nucleus has protons and neutrons. Ide kada? Right. Nucleons kuda. Right. Correct. Chusko. A nucleus simply has protons. Protons ante positive charge. Ide kada? And at the same time, you also have neutrons. So these are your neutrons. Arthamaindi? So 90% లేదా 99.9%. Again, simply say, sir, 99.9999% of the mass, చెప్పండి, mass of atom comes from nucleus only. ఇదే కదా? Yes, comes from nucleus only. Point number 1 to be noted. దాని తర్వాత the next thing that I would be interested in telling is that, చూసుకోండి, so when you have protons into the nucleus, ఇదే కదా, that is the biggest thing రా. Single proton, no, multiple protons are there. చూసుకోండి, multiple protons కదా. What will they do రా? These protons will try to repel with one another. ఇదే కదా? Yes, they are trying to repel with one another. మరి why are they not getting repelled రా? If protons have positive charge, positive repulsion kada, then why are they not repelling? Why are they still in the same position? Leda same place. Why are they not repelling? Because you have, చెప్పండిరా, ఏ బాబు చెప్పు, why are they not repelling? చూసుకోండి, ఫోర్సెస్ గురించి మాట్లాడతాం అందరికి. మీ న్యూక్లియస్ లో రెండు రకాల ఫోర్సెస్ ఉన్నాయి. ద ఫస్ట్ టైప్ ఆఫ్ ఫోర్సెస్ ఆర్ యువర్ ఎలక్ట్రోస్టాటిక్ ఫోర్సెస్. ఇదే కదా? ఎస్, ద ఫస్ట్ టైప్ ఆఫ్ ఫోర్సెస్ ఆర్ యువర్ ఎలక్ట్రోస్టాటిక్ ఫోర్సెస్. ఇదిగో, ఇదే కదా? ద ఫస్ట్ టైప్ ఆఫ్ ఫోర్స్ ఇస్ యువర్ ఎలక్ట్రోస్టాటిక్. ఎలక్ట్రోస్టాటిక్ ఫోర్స్ అంటే ద ఫోర్స్ బిట్వీన్ ప్రోటాన్ అండ్ ప్రోటాన్, లైక్ దిస్. ప్రోటాన్ ఫోర్సెస్ అంటే repulsion కదా. Electrostatic force basically tries to bring repulsion into the system. Who is balancing this ra? Who is balancing this? చెప్పండి. There is one more force. ఈ 4 basic types of forces నుంచి your last force గుర్తుందా మీకు? What is it ra? Strong nuclear force. Oh my goodness, చూసుకోండి. You are understanding strong nuclear force అంటే this force is holding the protons in a very tightly packed manner. Try to understand andari. Okay, strong nuclear force ante this is the attractive force ra. Idigo point number 1, attractive force. Number 2 ra, it is a short range force. Okay, short range force. Finished. You understand this? Okay, మీ ఎలక్ట్రాన్లో there is proton repulsion for sure, but the protons are not repelling. Why sir? Because there is one more force అంటే nuclear force లేదా binding force లేదా nuclear force or binding force. Okay, you call it as nuclear force or binding force. Sir, so you only have 2 types of forces. Okay, the first force is your nuclear force. The second force is your electrostatic force. Correct. ఇప్పుడు టర్మినాలజీ గురించి చూద్దాం అందరికి. చూడండి, ఏ అంటే ఏంటిరా? ఏ అంటే your atomic mass. ఇదే కదా? Atomic mass అంటే ఏంటి సార్? What do you mean by atomic mass రా? చెప్పండి అందరికి. Your atomic mass is nothing but total number of neutrons plus protons. ఇది you understand? What about Z ra? Z చెప్పండి. What is Z ra? Z అంటే it is atomic number. అంటే ఏంటి సార్? It is simply number of protons. ఇదే కదా? Yes. So if I say your nucleus has atomic mass is equals to A and atomic number is equals to Z అంటే tell me the conclusions ra. చెప్పండి అందరికి. Can I simply say that number of protons is equals to Z, number of neutrons, చెప్పండి. neutrons గురించి చెప్పండి అందరికి. your number of neutrons is equals to A minus Z. ఇదిగో, you are understanding? Try to understand. Okay, try to understand. What next? ఇప్పుడు let us talk about the values of the forces. అందరికి చూడండి. So if this is my nucleus, ఈ nucleus లో this is your proton కదా? Yes, neutron, then proton, then neutron, then neutron. Hey, then neutron, then proton, then neutron, then neutron, then proton, and neutron. Something like this. Try to understand. Try to understand. If this nucleus is at rest, ante balanced state lo untundi kada, not moving, no radiation, no breakdown of nucleus. In standard case lo, what will you say, sir? For sure there is force between proton and proton, repulsion force. Ide kada, that force must be equals to force between neutron and proton, must be equals to force between neutron and neutron. You understand? Ante attractive forces should be equals to the repulsive forces. You are understanding? Right. Your attractive forces should be equal to your repulsive forces. Try to understand, all of you. Next. So what did I say? What did I say? Sir, nucleus lo rendu rakal forces unnai. The first one is your electrostatic force. The second one is your nuclear force. Kani me nuclear force ante idi chala short distance short distance at 10 to the power minus 15 ranges lo. You are understanding? Short force at hey where is it? Where is it? Where is it? Yes. Short range force ante approximately 10 to the power minus 15 meters ra. Idigo. Very short force. You are understanding, sir? When you talk about your size of nucleus, and me nucleus lo, the nucleon density is uniform all the way. At each and every place, your density is the same. You are understanding? Yes. Ante entira, your nucleus has a uniform. Idigo has a uniform density. And one more thing, andariki chusko. This was experimental observations. Idigo, hey, try to understand. Okay, try to understand. What? The volume of nucleus. Idigo, chuskondi. Ante the volume of nucleus, it was found out to be directly proportional to A. A ante enti atomic mass. Atomic mass. No understanding? Sir. Oh. So volume of nucleus is directly proportional to A. Kada? Volume of nucleus ante enti, sir? 4/3 pi into R cube is directly proportional to A. Ante ekkada nunchi your radius of nucleus is directly proportional to A. Ante your radius of nucleus is directly proportional to A to the power 1/3. Idigo. You are understanding? A ante atomic mass. Atomic mass. Sir, here R is directly proportional to A to the power 1/3. You can simply say, sir, R is directly equal to R naught into A to the power 1/3. E R naught ante this is your Fermi constant. Okay, what is the value of this Fermi constant, sir? Very small, in the value of 10 to the power minus 15 meters or something. Idigo, you understand? Fermi constant is very small. Okay, try to understand, all of you. Right, correct. Now, if you want to analyze a question, the question was asked something like this, andariki. చెప్పండి. Do it. Yes, 1.2 to 1.5. You can say any rough range. 1.2 to 1.5. చెప్పండి. So you can simply say that your R is directly proportional to A to the power 1 by 3 atomic mass కదా. Yes. చెప్పండి. What will you say, Ra? Sir, your R1 is to R2 should be equals to A1 upon A2 to the power 1 by 3. A1 value hydrogen కోసం చెప్పండి 1. A2 value beryllium కోసం 8 to the power 1 by 3 అంటే 1 by 2 RA upon RB లేదా radius of hydrogen, radius of beryllium. అంటే you can simply say your beryllium radius is twice the radius of hydrogen. అంతే కదా. ఎస్. కరెక్ట్ కరెక్ట్ కరెక్ట్. ఇప్పుడు చూసుకోండి. Effect of larger nucleus. చూసుకోండి అందరికి. లార్జర్ న్యూక్లియస్ అంటే ఏంటిరా? We will compare the two scenarios. Okay, చూసుకోండి. This is your first scenario where your nucleus is small. ఇదే మీ second scenario. In this your nucleus is sufficiently large. అర్థమైంది కదా. చూసుకోండి. Here when you look at the constituent particles అందరికి, you have protons, okay, you have neutrons, something like this. అర్థమైంది కదా. Here you have the same thing అంటే you have protons and at the same time you have neutrons also, ra. చూడండి. Tell me about the electrostatic force. Can I say it is equals to the nuclear force? Strong nuclear force. Induku sir? Because nuclear is small and the nuclear force works at a very small distance kada. Yes, in case low your electrostatic force is equal to your nuclear force. Okay, అర్థమైంది. What about the next scenario? ఇక్కడ చూడండి అందరికి. మీ నెక్స్ట్ సినారియోలో సైజ్ ఇస్ ఇంక్రీస్డ్. సైజ్ ఇంక్రీస్డ్ అంటే డిస్టెన్స్ ఇంక్రీస్డ్. దట్ మీన్స్ యువర్ న్యూక్లియర్ ఫోర్స్ విల్ నాట్ వర్క్. వై? బికాస్ డిస్టెన్స్ ఇస్ మోర్. అండర్స్టాండింగ్ అంటే ఈ కేసులో యూ కెన్ సింప్లీ సే దట్ చెప్పండి అందరికి, యువర్ ఎలక్ట్రోస్టాటిక్ ఫోర్స్, చెప్పండి, యువర్ electrostatic force, it is greater than your nuclear force. Ante nuclear force is attractive, your electrostatic force is repulsive. Okay, repulsive ra ante this nucleus will be busted. Repulsive endukante size is more kada. So due to that massive size, nuclear force decreases, electrostatic force dominates. Electrostatic force వల్ల this nuclear will actually break down అంటే radioactivity. You understanding? Radioactivity is happening. Hey, are you able to understand? సరే, సో ఇప్పుడు let us try to understand everybody. చూసుకోండి. If at all you have the element x, ఇదే కదా, you have the element x, automatically the nucleus was big. చూసుకోండి. This was your element x kada. Yes, it disintegrated ra. Idigo your y plus let us say some other entity. Okay, so this broken down into another nucleus and at the same time some particle ra, p. Idigo you are understanding, some other particle ante nucleus leda proton leda alpha particles. You are understanding? Sorry, so in case lo your main nucleus due to massive size broke down into two constituents. You are understanding? Sorry, so in case lo we'll call this as your parent nuclei. Idigo understanding? This is your parent nuclei. Understanding? And this you will call it as your daughter nuclei. Andarki చూసుకోండి. Understanding? Next, when the observation was done, andariki jagrataga vinandi, when the observation was done, they found out something strange ante entira. Try to understand. Chuskondi. For example, let us say 10 gram of nucleus was there. Andariki chuskondi. Okay, 10 gram of nucleus was there. It disintegrated ra ante radioactive decay ayindi. ఈ decay తర్వాత when you see the outputs, this was somewhere around 7 grams. ఇదే కదా? Yes. 7 gram as daughter nucleus and the rest is 2 grams. ఇదిగో. You are understanding? అంటే your product was, your parent nucleus was 10 and these two became 9. 9, 10, 9. అంటే 1 gram is missing. You understanding? 1 gram is missing. Hey, 1 gram is missing ra. Idigo 1 gram is missing. One gram is missing. Ide kada? So where did it go? This missing system is known as mass defect. Andariki చూసుకోండి. This missing system is known as mass defect. Mass defect ante entira? In your radioactive decay, చూసుకోండి. మీ radioactive decay లో the total mass of reactant is never equal to total mass of products ra. There will be little change. You are understanding? Delta m cheppandi okasari. Sir, if this is your x, this is your y and this is your z, andariki ide kada? Yes. X, y is that ra. Cheppandi. Your delta m should be equals to mass of x. Ide kada? 10. Minus the total mass ra. Total mass. Ide kada? Minus total mass ante mass of y plus mass of z. Idigo. So this is known as your delta m ante mass defect. So the question is, where did the mass go? So Albert Einstein, Vadu, he said that the extra mass that is missing has been converted. You are understanding? The mass has been converted into energy. Okay? I'm giving you a reply, Gada. No, don't think like that. Okay? Sorry. So your mx minus so the mass converted into energy. Ide kada? So the mass is converted into energy. So this is your mass defect. Now, what is the energy ra? The energy that will be formed through the mass is nothing but delta m into c squared. And E is equals to mc squared. Formula. This is the formula. You are understanding? Try to understand. Is it possible, sir? This is a pen in my hand kada. Andarki chudandi. This is pen ra. Leda. You can simply say, sir, this is a bottle. Bottle kada. Can I convert this total bottle into energy? Can I convert? I can't. Why? Because I don't know how to do it. Kani, can I say that this mass is nothing but the form of energy? Yes. You are understanding? If at all you convert this bottle into energy ra, entire world will be gone. Understanding? Ade atom bomb kada, atomic bomb ra, nuclear weapons re, andariki. Nuclear weapon ante enti ra? Me nuclear weapons lo you convert your mass into energy ade. But the thing is that massive amount of energy is generated from a very small amount of mass. Try to understand this. You are understanding? Sir, hey, andariki chuskondi. So your energy that is created is massive. Okay, sir. So let us try to form a nucleus. Let us try to form a nucleus. చెప్పండి అందరికి. So nucleus అంటే you have neutrons and protons కదా. చెప్పండి all of you. Tell me, come on. Hey, we've given the notations kada. A అంటే ఏంటిరా? మీ A అంటే your atomic mass. What about Z ra? Your Z is nothing but your atomic number. ఇదే కదా? Yes. Atomic number, atomic mass. ఇప్పుడు can I simply say number of, చెప్పండి, number of neutrons and ఇదే కదా? Yes. So can I say అందరికి okay. Everybody, just good. Now, what you will come to know is the element X and the atomic mass is A, atomic number is Z. Ide kada? It is leda, it has been formed by adding two things. Ante your nucleus and your protons. Sorry, your neutrons and your protons. So this is formed by using your protons and your neutrons. Ide kada? So what will you write ra? So protons, how much protons, sir? Sir, Z protons are there. How much neutrons ra? Neutrons are A minus Z into neutrons. Ide kada? It is formed like that. Chusko. ఇప్పుడు once again try to understand. In your chemistry మీకు exothermic reactions ఉంటుంది కదా. In those exothermic reactions what happens ra? Your reactants are at higher energy level. ఇదే కదా? When they come and form a product, the product is at the lower energy level. మీ reactants, they are at the higher energy level. This energy gap, whatever it's there, this energy will be released kada. Yes, same thing ante this proton and neutron, they are at higher energy levels. So ippudu em cheyali? Add them, they come at lower energy and they release some energy ra. Idigo, so this energy is known as your binding energy of nucleus. Idigo, understanding, this energy is known as the binding energy of the nucleus. And the more energy is released, the more stable is the nucleus. అర్థమైంది అందరికీ? The more energy is released, the more is your nucleus stable. అర్థం చేసుకోండి. Correct. So how would you write about your change in mass? Ante how would you apply the mass defect? Chuskondi. So in case lo what you can simply say is, try to understand. Hey, all of you, reactant side mass, product side mass, it will be different. Yes, it will be different. Ante if you see total mass in the reactant side, చూసుకోండి, mass of proton అంటే mp. How much is it ra? Z. Mass of neutron చెప్పండి యార్, mn కదా mass of neutron. How much neutrons are there, sir? A minus Z. ఇదిగో, this total mass will be more than your mass of X. ఇదే కదా? Try to understand. Sir, so you can simply say this is equals to, చెప్పండి అందరికి, delta m values. Delta m is equals to Z into mass of proton plus A minus Z into mass of neutron minus mass of X ra. ఇదిగో, so this is your mass defect. ఇప్పుడు మీకు ఎనర్జీ కావాలంటే this binding energy కదా. If you want binding energy, so what you will come to know ra? You will simply say it is delta m into c square. ఇదిగో, but ఈ ఫార్ములాలో your energy will be in joules, energy joules, speed of light in meter per second. Okay, SI units ra. But we don't have such huge values. Understanding? Until delta m in kg. Your mass of electron is in kg, ra. Mass of proton, no, not in kgs. So what to do? We need another system in which we can easily substitute the masses and find the answers. So our system lo will take the masses in your atomic mass unit. You are understanding? Your masses will be in atomic mass units. Chudandi. So in case lo your energy will be simply equals to 931.5 multiplied by delta m ra. Delta m should be in atomic mass units. You are understanding? And the energy that you get is mega electron volt. Hey, mega electron volt. Try to understand, everybody. Okay, and when your masses are given in AMUs, and atomic mass units, will not be considering all these instances. We will simply write atomic mass unit change. We will finish it. You are able to understand? You are able to understand? All of you. Cheppandi okasari. How many of you are watching, ra? Sir. So now, this is your total binding energy. Ide kada? Okay. So let us write somewhere here only. Your energy simply equals to delta M multiplied by 931.5 million or mega electron volt. Same. Yes. So this energy is known as binding energy. Chudandi andariki. If the binding energy is more, nucleus is stable. And when the atoms are combining to form, when the particles are combining to form nucleus, when the particles are combining to form the nucleus, massive amount of energy is released. You are understanding? Sorry. So what will happen, ra? Try to understand this equation, something like this. Children, if your binding energy is high, ante nucleus is stable. Sir, let us say I have some different elements. Different elements into entira. You imagine you have some X. Okay, it is breaking. Leda. You are adding. You are saying X plus Y gives me Z. Plus energy. Yes. Particles. Energy is released. If at all you want back, choose andariki. If this is your X, okay, this is your X andariki. And if this is your Y, okay, try to understand. If this is your Y, this is your Y, you join them. You get X plus Y, yes. You get X plus Y, it is Z. So this is your X, Z, something like that. They are mixed, and at the same time, energy is also there. But, if you want X and Y back from this, so if you want X and Y back from this, so what to do, sir? Give it the energy. What energy, ra? Same energy that it was released. Chuskondi. Binding energy. Ante, you simply give it the binding energy. Whatever binding energy was there, you give it same binding energy. They will break into X plus Y. Here you go. Finished. You are understanding? Maybe in the last the 4th of February, it will be completed. Semiconductors chapter, okay? Student, let us talk something about your binding energy per nucleon. Very good. Understanding? Ante enti, sir? Your binding energy per nucleon is nothing but total energy that has been released divided by total nucleons and then total number of atoms and protons and atomic mass number. So if at all you are having Z number of protons plus A minus Z number of neutrons, and it is giving you some random element. Let's say X atomic mass is A, atomic number is Z. Here like it is kada. Whatever energy is released, this energy, energy, yes, this is known as binding energy, only binding energy. Kani, when you divide this energy per total number of protons plus neutrons, ante A ra, A ante enti ra, simply you write. Don't get confused, sir. What is A, sir? A ante area. No, number of protons plus number of neutrons. What will happen, sir? When you divide it, you will get binding energy per nucleon. Think you understood. You understand? Binding energy divided by A. This A is not for area. Andariki jagrataga vinandi. Okay, this A is not for your area. This A ante your total number of nucleons. The same way, what we are doing, we are integrating. So I had a proton, I had a neutron, I added, formed a nucleus. Similarly, in our reaction, there is something known as Q value. Q value of a reaction. What is this Q value? God. The Q value in there, you try to imagine, okay? You have two different reactants, you form two different products, okay? Two different reactants and TNT, sir. You have A plus B. They are forming some C plus D, and at the same time, they are releasing the energy. You are understanding? Yes. How to do now, sir? Sir, you take delta M value. Delta M and TNT, mass of A plus mass of B minus mass of C plus mass of D. This delta M value, you multiply this delta M with C square, and it is energy. That is known as the Q value of a reaction. This will be your Q value for the given reaction. Okay, so now lithium kada. It's a hypothetical question, okay? Do it. Whoa. we will be concluding our lecture by mostly 12 or 12:30, right? Will be completed. Okay, I will not take much time. By 12 the lecture will be completed. Ante 9 hours kada? Yes, 9 hours. Getting it? Not getting it, Shipment. So your binding energy is equals to delta M multiplied by 931.5 mega electron volt. ఇదే కదా? Delta M values చెప్పండి ఒకసారి. Atomic masses kada? Only take atomic masses. Hydrogen is 1, helium is 3. Sorry, 6 kada? Yes. Hey, lithium is 6. Ide kada? Yes, lithium is 6. So 7 minus helium helium is 4 kada? Yes, 7 minus 4. Chuskondi. Multiplied by 931.5 mega electron volt. Idigo. So this is nothing but 3 into 931.5 mega electron. Per nucleon, divided by number of nucleons. What is number of nucleons? 7. 4 kada? 4 nucleons are left. Divided by 4. Next. Sir, so let us talk something about decays ra. Chudandi endi decay. So eppudu let us talk something about your decays. Okay. There are 3 types of decays ra, okay? 3 types of decays. Number 1 is your alpha decay. Okay, sir. Number 2 is your beta decay. Okay. Number 3 is your gamma decay. So there are 3 types of decays. We'll study one by one. Don't worry. Okay? Once these decays have been completed, your radioactivity is remaining, and then we'll be completing this lecture by 12 లేదా 12:30. At most 12:30. Finished. ఇదే కదా? Yes, sir. So now, six five. You do it, okay? You verify it by yourself. So first, మొదటిగా we'll be talking about your alpha decay. Alpha decay అంటే ఏంటిరా? Okay. What is your alpha decay, sir? మీ alpha decay లో you have the element, okay? You have the element from this. Let us say X is there, okay? X is there. Atomic number Z. Atomic mass Z. Atomic number Z, atomic mass A. Yes. It breaks simultaneously. It breaks simultaneously into 2 different continuum. Okay, the first one is your y. Chudandi. This is a minus 4 and this is z minus 2. Ide kada? Yes. Plus your alpha particle. Alpha particle ante entira? Your helium nucleus. You understand? It's alpha particle. So, now, when you talk about the Q value, Gurtunda, for a reaction Q value, what is Q value? Q value is nothing but total energy released. Cheppandi, your Q value is nothing but ide kada. This is the Q value. I want all of you to remember this, okay? This is the Q value. The question is, the energy has been released, right? Now I want all of you to remember. The energy has been released, but where is it? What form? Light, sound, heat? No. It is not released in the form of light, not in sound, not in heat. Mari, kinetic energies. Kinetic energies of the particles. Your total energy is in the form of kinetic energy. And this total energy that has been released. This is your energy Q value for a reaction. Leda binding energy. Whatever you want to take, you can take it. Okay. So now the same energy Q value under mass of X minus mass of Y plus mass of alpha particle multiplied by C square. So this is your Q value. So whatever Q value has been released, it is in the form of the total kinetic energy. I hope you are understanding this. Okay. This is your kinetic energy. Now, when you had the original nucleus X, it broke into two different nuclei. The first is Y and the second is your alpha particle. It actually broken down into your nucleus Y plus your alpha particle. Kani. Try to understand. They have energies. Hey, all of you. So let us say this is mass of Y and this is speed of Y. Mass of alpha particle and this is speed of alpha particle. Originally, your nucleus was at rest and the center of mass was at rest. Suddenly, the internal reaction aindi kada. So, internal reaction kosam your center of mass will not change. Ante entira, you will simply say your mass of Y multiplied by speed of Y must be equals to mass of alpha particle multiplied by speed of alpha particle. This is one of the most important conditions. Dan tarvata, I also have to comment on the Q values. Andariki cheppandi. What can I say about the Q values? Can anyone of you tell it? Sir, so talking about the Q value, Q and total energy, but in what form? Kinetic energy. So total kinetic energy of both of them. Q value is half mass of Y, kinetic energy of Y square plus half mass of alpha particle, speed of alpha particle square. Speed of alpha particle whole square. You can take out mass common. What you can write is, you can simply write the value of Vy. Did I say by 2 units? Yes, atomic number decreases by 2 units. Yeah, that's the same thing, right? That is the same thing. Hey, try to understand all of it. Okay? Now, you can simply say, in case lo chudandi. So mass of Y, speed of Y must be equals to mass of alpha particles, speed of alpha particles. Your speed of Y should be equals to mass of alpha particle, speed of alpha particle divided by mass of Y. Remember this. You understand? Substitute. So sir, Q should be equals to half mass of Y into speed of Y square and mass of alpha particle, speed of alpha particle divided by mass of Y whole square plus kinetic energy of alpha particle. This is kinetic energy. Yes, so you can simply say, sir, Q is equals to half into, choose quantity. You are left with mass of alpha particle whole square, speed of alpha particle whole square divided by mass of y plus kinetic energy of alpha particle. Idigo. You can rewrite your half into mass of alpha particle, speed of alpha particle whole square multiplied by mass of alpha particle into mass of y idigo plus kinetic energy of alpha particle. Ide kada? Yes. Hey. Plus kinetic energy of alpha particle. Hey, this. It is also kinetic energy of alpha particle. You are understanding? This is also kinetic energy of alpha particle. Ante your Q is equals to kinetic energy of alpha particle into mass of alpha particle by mass of y plus kinetic energy of alpha particle. Take kinetic energy common. Kinetic energy of alpha particle is equals to mass of alpha, mass of y plus 1. Ide kada? This total Q value. Idigo. Second nunchi. Let us rewrite. Andariki. I don't know, this board is not supporting. Sometimes it's total headache, Q should be equals to kinetic energy of alpha, mass of y plus 1. Hey, send this side, send that side. So you can simply say, sir, kinetic energy of alpha particle is equals to Q into Chapandi. You can simply say mass of alpha plus mass of y divided by mass of y. Here you go. So this is your kinetic energy of alpha particle. Vachindi kada? PYQs on radioactivity decay. Okay, let us see. Hey, there is a mistake, not like this. Calculation mistake, a little calculation mistake. So Q should be equals to kinetic energy of alpha into mass of alpha plus mass of y divided by mass of y. So you can simply say that kinetic energy of alpha is nothing but Q into mass of y divided by mass of alpha plus mass of y. Understand? Okay. Done with your alpha decay. You want some PYQs, So actually they are there in the sheet itself. Funny, I don't know if I'm able to give it or not. Sorry, I am more than sufficient, I can. You know Q value kada? Okay, yes, first we'll cover the topics only. Class will be completed by 12. Okay. 12 లేదా at most is 12:30 finished. That is the last time. You have this radioactivity in your nuclear chemistry also, ra. Okay? But you should be very good in handling the numbers. Atomic mass you need to kg conversion. Should be very good. చెప్పండి. What is the kinetic energy of alpha particle, రా? Formula చెప్పండి ఒకసారి. Your kinetic energy of alpha particle Q into mass of y divided by mass of y plus mass of alpha particle. ఇదే కదా. So x అంటే 9 4 got converted into y having 5 and here 2 kada plus alpha particle అంటే helium nucleus 4 2. ఇదిగో total mass చెప్పాలంటే your atomic mass simply 5 రా 5 mass of y అంటే 5 అంటే q multiplied by 5 divided by this plus this 5 plus 4 అంటే 9. ఇదే కదా. ఇప్పుడు what is q value అందరికి? q value గుర్తుంది. What is the value of q, ra? You remember value of q? Sorry. Okay, you write in terms of q only, ra, more than sufficient. ఇప్పుడు చూడండి. Let us talk something about monotypes. Monotypes అంటే we don't have much time to waste. First type is your beta decays, ra. So beta decays lo kuda you have 3 different types of beta decays. Okay, beta decays lo you are having 3 types of beta decays. Number 1, sir, it is beta plus decay. ide kada. Next, dan tarvata you have beta minus decay and then you have your K capsule. Very good. Can you tell me? I don't want to listen about your beta plus decay. What is it? What is that? All these things. Okay. Okay. I don't want to listen. Just tell me mass defects in all 3. Do you remember mass defects in all 3, ra? Beta plus decay lo your proton, okay, your proton converts into neutron plus positron, something like this. A positive, E positive, and at the same time another particle neutrino was seen, ra. You are understanding? In your beta minus decay reverse happens. The reverse ante enti, ra? Your neutron turns into protons plus electron is there. and an anti-neutrino. This is your neutrino particle. This is your what is this K capture? What is this K capture? Cheppandi. K capture is not a type of decay ra. Me K capture lo, the electron simply in your K capture, the nucleus simply captures the electron from K shell ra. Okay, yes. So in your K capture, what happens is your electron basically చూసుకోండి. So this is your nucleus, okay? Nucleus. This is your K shell ra. K shell ante it has some electron. Let us say this is the electron that is revolving, okay? This is your electron andari. So what happens ra? What happens? This nucleus actually, this nucleus captures and attracts, okay? This nucleus attracts this electron and electron gone to the nucleus. ఇప్పుడు చూడండి, nucleus lo you have neutrons kada? Yes. So neutrons plus this extra electron that has been attracted. You understand? Not neutrons, right? It should be proton. Okay. Your proton plus this extra electron kada? Yes. It forms a neutron. The conversion of proton into neutron, same thing ra. Same thing. And the neutrino has been formed. Same thing. You are understanding? It is same as your beta plus decay. Similar, okay? Similar as your beta plus decay. Ippudu, the biggest thing is, I want the mass defects. Andariki. How will you write the mass defects, ra? చెప్పండి. So you'll simply say, if at all you have a beta plus decay, in this beta plus decay, you will say that your X is there, atomic number A, atomic mass Z. Ide kada? What is converting? Proton converting into neutron. Ide kada? Yes. So one proton gone ra, Z minus 1 becomes Y. It remains A only. At the same time, a positron and a neutrino has been, sorry, anti-neutron, no, neutrino. It should be neutrino. Okay? Yes. So this is the equation for your beta plus decay. At the same time, when you're talking about beta minus decay, cheppandi, what is happening in the beta minus decay ra? Same thing, you have A, you have Z. Kani ee case lo your neutron is getting converted into proton kada, so Z value increases ra. A remains A, becomes Y. Hey, Z plus 1 plus, right? It should be electron, and at the same time anti-neutron. అర్థమైంది? Start. చెప్పండి. I'm telling you, just remember the values, okay? Mass defects values good pettukondi ade more than sufficient. If you are remembering mass defect values, sorry, so your delta M should be equals to mass of X minus mass of Y minus 2 times of mass of electron. Here your delta M should be simply equals to mass of X minus, so there are some proofs actually behind it, but I don't think that all the proofs are required. Okay, sir. Now let us talk something about your last type of decay, that is your gamma decay. You understand? That is your gamma decay. In your gamma decay, what happens ra? Cheppandi. in your gamma decay, if you have elementary x andarki chudandi, it is turning into y plus some particle, right? Small particle p kada. So the process does not happen in a single step. Chudandi, it happens in two different steps, ante adjacent steps. మీ ఫస్ట్ స్టెప్ లో, in your first step అందరికి మీ ఫస్ట్ స్టెప్ లో your x breaks into an active nucleus. Active nucleus అంటే ఏంటిరా? It is the excited nucleus of y. ఇదిగో, you are understanding? Excited nucleus. And the same time your particle p has been formed. Kani this excited nucleus ante it has energy ra, energy. Understanding? Koncham samayam tarvata what happens is this extra energy and excited nucleus will release some radiations, ante your gamma radiation, ante gamma rays, it emits the radiation and then come back to the normal position. Idigo, you understanding? Finished. So your reaction goes something like this. Your x becomes y plus some other particle plus gamma radiation. Finished. Okay, nothing much about it, to be honest. So now let us talk something about your radioactivity. Okay, radioactivity andarki cheppandi. So let us talk something about your, what's the time ra? 12, 14, 50. Yes, done by 12 ra. Let us talk something about your radioactivity. What do you mean by radioactivity ra? Three, 4. Sir, what do you mean by radioactivity? Same thing ra, the decay of the nucleus. Ade, that is known as your radioactivity. Ante enti ra? Try to understand. Okay, let us talk something about your radioactivity. Point number one. Okay, point number one. Your radioactivity is a spontaneous process. Spontaneous ante enti ra? It happens by its own. You don't have to do anything by yourself. Spontaneous process. Point number two. Okay, this radioactivity లేదా nuclear decay. Okay, nuclear decay లేదా nuclear decay అంటే your nuclear properties are different than your chemical properties. అర్థమైంది? చూసుకోండి. Next, the decay density throughout, okay, the decay density throughout the nucleus is almost the same ra. Ante same తీసుకోండి. Same అంటే ఏంటి? I'll tell you. Don't worry. Okay, you imagine andariki, you imagine this is your nucleus. Ide kada, this is your nucleus. It is starting to decay. All of you visualize. Decay ante enti? Let us say red color ante the part has been decayed, gone. Okay, gone. That means wherever you go in the nucleus ra, you lift లేదా you choose a given space ante enti? You choose this much space, లేదా you go here and you choose this much space, you will see same amount of decay that has happened. You understand? Ante the decay density is same in the nucleus. అర్థమైంది అందరికీ? సరే, ఇప్పుడు చూసుకోండి. Let us define a terminology ra. Activity అంటే ఏంటి సార్? యాక్టివిటీ అంటే dn by dt. What is n, sir? N ante number of particles. Nucleus particles, right? Nucleus particles, parent nucleus particles. Leda n ante parent nucleus particles. You are understanding, sir? So me chemistry lo you have first order reaction. Hey, chemical kinetics chapter you have it kada, zero order reaction, first order reaction, second order reaction, all these things. Your entire radioactivity is first order reaction. First order reaction ante enti ra, me first order reaction lo you have minus dn upon dt. Hey, rate decreasing kada, concentration of the particle is decreasing ante the original particles are decreasing. Minus dn upon n is directly proportional to n. Idigo n ante n naught, initial concentration. Initial concentration of the particles. Andariki chudandi, you replace this directly proportionality symbol with a constant and equal sign. Ide kada, so ikkada nunchi you can simply say, sir, minus dn upon dt is equals to lambda into n naught. Idigo, this lambda is nothing but the decay constant. Okay, yes, lambda is your decay constant. Andariki jagrataga vinandi. Okay, this lambda into n naught is also known as a naught. A naught ante entira, initial activity. Andariki initial activity. So from now we will do some calculations. We'll do some calculations. What are the calculations, ra? Chuskondi. You will simply say, sir, minus dn upon dt is equals to lambda into n. Ide kada, lambda into n at any single time. Bring it that side, bring it that side. Sir, minus dn upon n is equals to lambda dt. Ide kada, leda you send this minus sign that side. Idigo, you are sending this negative sign that side ra, ante minus lambda dt. Integrate cheskondi ra. Integrate cheskondi. dn upon n ante log n kada. Yes. Limits kuda petkandi. So at n naught at t is equals to 0, n at random time t. Ide kada. So log of n upon n naught is equals to minus lambda into t. Send a log that side, sir. You are left with n upon n naught is equals to e to the power minus lambda into t. Ante your n is equals to n naught into e to the power minus lambda into t. This is the equation for your decay. That means your rate of change is itself variable, ra. Understanding? Good. Let us talk something about half-life of the reaction. Okay, what do you mean by half-life, sir? Me half-life kosam equation raskondi okasari, n equals to n naught e to the power minus lambda into t. This concentration should be half of the initial concentration. Ante your n should be equals to n naught upon 2. Substitute cheskondi ra okasari. Your n naught by 2 is equals to n naught into e to the power minus lambda into t. T under t half kada? Yes. N naught gone. Sir, half is equals to minus lambda into t half. Log teeskondi both sides. Take log on both sides, ra. Okay. I take log on both sides. Minus, okay, minus ln half upon lambda, ra. Hey, minus ln half is ln2, okay, ln2 upon lambda. Idigo, this is your half-life for any reaction. Depends only on lambda. Lambda ante decay constant. Okay, so your half-life is equals to finished. Ardhamaindi kada? Okay, if you want to substitute, you can simply say it is equals to 0.693 upon lambda. This is half-life, t half. There you go. Finished, ra, finished. Am I forgetting something else, ra? Let me just check the bullet points, what I am forgetting. Yes, same thing, Ra, same thing. There are some other forms also, Ra. Like you can write the equation in other forms. But I'm worried, should I say it or not? Let it be, Ra. Okay? Let it be, not required to you if possible. So these were all the things about your topics. Okay? So with that being said, we will wind up the session. Yes, complete it. There are some things left actually. There is something known as equilibrium of decays, but not that much important. No PYQs. Yeah, same thing. Fission, fusion, almost same. Okay. Sir, there is not much difference, okay? Almost we have covered every single topic. Okay, so with that being said, we have been taking from 9 hours, kada? Yes, almost 9 hours. 3 to 12 until 9 hours of lecture has been covered. Anyways, the notes will be uploaded. The notes will be uploaded. Okay. Paribala, the mean life or average life is simply 1 upon lambda. Okay. Formula gurupettukondi. That not sufficient. That's what I'm telling to you. Single line formulas are, that is the only formula left, I believe. Remaining things are not used to be, they are very edge topics. Very less chance to be asked. Looking at the time, it would not be a wise decision. So, anyways, all of you. So, good night, all of you. Good night. Bye-bye. Bye, all of you. Good night. So, these notes will be available, okay? Yes. Meanwhile, make your timetables. ఎందుకంటే success without timetable is not possible. In 90 days kosame, at least make a proper schedule. I have released the week wise videos. Okasari velli chudandi. Okay, so you can plan your weeks according to the weekly schedule that have been given to you. Okay, physics kosam I can tell you, but about your chemistry and biology, your teachers will be telling, respective teachers. Yes. Physics practical, we will take it, okay, we will take it. Let me decide. Let me ask about the teachers. If they say we'll take it, ledante we will take it almost. Sorry. Yes. Okay. Bye, everybody. Bye, bye, bye. Good night, good night, good night, all of you. Good night. Oh, why you gone? Sorry, good night, everybody. Good night, good night, good night. Let me take a leave now.